Okay, thank you everybody for joining us. Today is day 2 of a 2-day event which we call our Phase 2 Thesis Reviews in the Design Research Lab. My name is Theodore Sparopoulos for those that are joining online. And for guest critics that may not know me, I direct the DRL. I have the pleasure of doing this introduction to give a little bit of an overview of some of the things that we've been working on now for the last 16 months. For us, this occasion is really an opportunity to share. I think a lot of the research that's been happening in the lab to make that accessible and to open it up to a conversation. One that is very much a part of the program, really trying to explore what architecture can be, see the implications of technology, explore the challenges of working at the scale of a brick to the scale of a city, and in some ways trying to see some of the challenges of today and how that can really be embedded within the ways that the students are critically evaluating what design research can be. A lot of the work is motivated by basically believing that architecture and people demand and need more. But the challenges today are accelerating, and the ways that we sort of work on architecture are also evolving. The program is organized as a collective. We work together on shared agendas, and what we qualify as design research are usually these open questions that we're exploring over multiple years and multiple generations. The staff are all practitioners in their own right, educators, the students as international as the community at the AA can get. And we're all coming here with a common purpose of actually trying to engage in the discourse of architecture around a subject that we've termed social ecologies, around subjects that are looking at things like gamification, participation, parametric semiology, mega buildings, deployable architecture, new ways of thinking about ecology, and artificial intelligence. The organization for today basically is set up following, let's say, the blueprint of yesterday. We're going to present 3 projects in the morning session, take a break for lunch, and then continue with 3 sessions in the afternoon. We started the conversation yesterday, which was very engaging, and I'm sure that this is going to continue today. The students will be presenting for around 20 minutes, and we have basically an hour team by team to basically discuss their work, the implications, and the discourses around potentially what the next generation of work could look like. We feel very privileged to be able to always have very informed guest critics that are joining us for these days that really help shape the conversation and give feedback to the students and to ourselves. This is how the program, for now almost 3 decades, has really tried to engage the community, practice, and actually try to really make informed decisions about how we set up kind of problems and challenges for today. It's an open door. Anybody is welcome to join in. We are streaming this for people that aren't able to join us here on site. We have a website that has all of the distinguished accolades of our critics and all of the briefs for each of the studios and each of particular projects. You'll find that at drl.aaschool.ac.uk, this kind of stuff. I'm going to read just, in the words of each of the tutors, a short, really, description of each of the studio agendas, just to give a little bit of an overview of what the students have been sort of tasked. These are somehow motivated statements just to kind of give a little bit of an overview. But each of the teams will be basically articulating that in some detail. Excuse me for a second, because fortunately I need glasses these days. We're going to start with Pier Andrea's studio, Anja's studio. It's been looking at mobile habitats, climate volatility, meteorological intelligence, and resource scarcity. In Pierre's words, our studio explores large-scale agile bionetworks as adaptive systems, responding to climate volatility, resource scarcity, and social inequality. Moving beyond static and extractive models, the studio investigates fluid forms of urbanism that evolve in dialogue with planetary processes and human vulnerability. through territories of scarcity, water-stressed regions, food insecurity landscapes, post-industrial sites and climate-threatened coastlines, such as earthquake-affected areas, wild-prone territories. I mean, Pierre, you're very expansive with the language here. We examine non-extractive architectures and metabolic infrastructures. Sajay Bhushan's studio and the team have been working on something that Sajay is calling architectural intelligence for new cities. The studio treats AI and new cities as parallel themes, but as mutually conditioning problems. AI provides new ways to reason about optimization, negotiation, and adaptation. New cities provide a domain where those capabilities are not optional but essential. Rather than focusing on automation of design outcomes, the studio is concerned with locating architectural and urban design agency within both the technical details of AI and the use value for new cities. In a sense, the studio locates agency upstream of form, operating through design of geometric energy landscapes and socioeconomic game rules. The third studio, which is run by Patrick Schumacher and team, has been looking at the subject of mega buildings, high-density urbanization, co-location synergies. The studio explores the mega building as a contemporary urban type, capable of delivering the functional intensity of an entire city district within a compact three-dimensional framework. Responding to accelerated urbanization and the demands of the knowledge economy, the research investigates how extreme density can amplify social, economic, and communicative interactions through spatial co-location. The mega building is approached as a complex urban system composed of interdependent subsystems, including structure, circulation, occupiable surfaces, and envelopes. And lastly, my studio, the Sporopolis studio and team, what I've titled Everything Intelligence. Today we find ourselves in a moment where new ways of thinking are emerging that open up questions about agency and intelligence within the wider ecology that sustains us. Our work looks at environmental and technological phenomenon as a means of supporting life. It examines intelligence, both artificial and natural, with an emphasis in the non-human. The challenges we face today point to the need to prepare for a world that's becoming ever more extreme and unstable. Whether we're talking about environmental, social, or political forces, the issues are planetary in scale. And they call for strategies that go beyond simply correcting past mistakes. They require an active preparation for what is to come. Intelligence is explored through research that examines a form of architectural intelligence as a means to construct an evolving partnership with systems and attempt to prototype new models of engagement. That's a lot of language that's going to be given form and meaning through the students' presentations. With that, I'm going to pass this over to the students, who are the show of today's event.
Thank you. Good morning, everyone. We are team 2 from Sporopolis Studio. My name is Evelyn, my teammates Ayo, Ali, and Vaibovi, and our project is Atmospheric Intelligence. The studio brief challenges how intelligence is defined today. Artificial intelligence is largely human-centered, created for people and based on human data. This limits intelligence to human needs and perspectives. This brief calls for a broader definition that includes planetary and non-human intelligence, and asks how architecture could be designed using forms of intelligence behind human. Firstly, we started to experiment with large language models to understand its reasoning. Here, ChatGPT was trying to generate sound based on given curve and then create an image of form. Then we experiment with diffusion AI models. ConfUI, the experiments show the representational nature of both those models. Intelligence is defined here as observable capacity of systems to organize itself. When inputs and constraints change, the system produces patterns, measurable responses over time. In this project, intelligence is treated as something that can be sensed as a field behavior, stored as a data, and modeled to predict how the field will be evolved.
In challenging conventional notions of human-centered intelligence, we turned our attention into the atmosphere composed by layers of gases surrounded the Earth It sustains weather, climate, and life. Through continuous responses, self-organization, and phase changes, the atmosphere maintains planetary equilibrium. The physics-based data embedded within the processes enables intelligent interpretation, positioning the atmosphere as a medium of data from which intelligence can emerge. Atmosphere intelligence is defined as patterned behavior produced by various fields, atmospheric fields under energy inputs and boundary conditions, expressed through measurable distributions of air and moisture environment. The methodological shift is from describing atmosphere through human perception to interpreting it through sensing, measurement, and analysis of physical data. To begin to see atmosphere as data, we needed to observe it through measurable changes on microclimate. We made series of experiments to create the atmosphere by capturing vapor within a bubble and using ultrasonic humidifiers. We recorded how the trapped air reorganizes through vibration, create stable patterns over time, establishing field recognition as a measurable output. In the next experiment, we trapped vapor inside a bubble. Those experiments established the baseline logic of the project. An energy input produces a measurable change in the field organization over time. We then scaled the same logic to a larger atmospheric system where the relevant variables can be explicitly defined and controlled.
Cloud formation was selected as a model system because its behavior depends on explicit atmospheric variables. We studied cloud formation by abstracting a section of the atmosphere into voxels. This low-resolution discretization allowed us to estimate liquid water content across space, providing a way to quantify how dispersed moisture aggregates to form clouds. These simulations reveal how atmospheric variables produce different cloud formations, highlighting the sensitivity of clouds to their surrounding conditions. These cloud formations demonstrate how atmospheric systems self-organize as energy and environmental variables change. This voxelized volume became the foundation for training AI model on atmospheric data. Atmospheric variables were encoded as RGB values, allowing 3 parameters to be stored per voxel, and forming a structured dataset suitable for physics-based learning. Data from the simulations were extracted both as numerical tables and as image-based representations. Using this dataset, we trained a regression model that predicts cloud formation outcome from given atmospheric parameters. This positions AI in the project as a field learning from discrete measurements. It learns variables to pattern relationships and produces probabilistic predictions. This is one of our first engagements with non-human physics-based intelligence.
To explore the atmosphere more deeply, we prototype a system capable of influencing it, allowing us to observe how it responds to intervention. As the basic unit of the system, we choose an ultrasonic humidifier. This allows us to observe how vapor spreads within closed space and gradually dissipates into the surrounding air, revealing small-scale atmospheric behavior. We built a humidifier grid to test how this atmospheric behavior could appear in real space, allowing us to simulate liquid content emission into the atmosphere. We observed how these emissions moved through the space and affected the surrounding microclimate, revealing localized response. Next, we experimented with the directionality of the emitted surfaces, adjusting their orientation to examine how these influence the surrounding environment. Then we tried different variations, convex and concave, to see different emission, how they dissipate into the air. Then we try to see it 3-dimensionally, levitated above the ground. These experiments help us to understand how different topologies can shape and modify the microclimate. Moisture organized in the air changes its density, flow, and atmospheric behavior.
However, air humidity is not the only driver of atmospheric behavior. Arguably, more important is heat. Heat strongly influences air density and airflow. Thus, any heat produced from built environments will inevitably influence the atmosphere. Computational infrastructure is rapidly growing, and so its large-scale environmental impact on the microclimates that surround it. While conducting our research, we learned that these facilities produce colossal amounts of heat as a byproduct of heavy computation. Thus, in return, it creates localized heated microclimates around them, as demonstrated in this simulation. To understand how severe this heating was, we took on-site measurements from data centers in Canary Wharf using thermal cameras. These observations revealed just how much concentrated waste heat was being expelled into this specific microclimate. Diving deeper into how data centers function, we investigated how the heat was produced by interior sources, which cooling strategies were used, and simulated how all this contributes to the heating outside. Then we looked into future concepts of data centers, like that of Hyperion by Meta. This is just one example of hyperscale typologies that can really shift microclimates, as can be seen in the simulation. Following the trend of data centers construction, how they are expanded into larger and larger compounds, we realized that the underlying technology must also evolve. This made us see both architecture and computation beyond its physical boundaries. The research extends to future computation. Superconductivity is a physical phenomena in which certain materials conduct electrical current with zero electrical resistance. This is used in quantum computing, where performance depends on material state under strict cold thermal regimes. This makes computation performance efficient, consuming less energy, and has a great potential for research to address global challenges.
Superconductivity reveals another unique property called quantum levitation. It happens when a superconductor cools down below its critical point using liquid nitrogen, and it processes a phase change that leads to expelled magnetic field. This expulsion leads to a stable magnetic repulsion and frictionless movement following a magnetic rail. These phenomena occur until the liquid nitrogen dissipates into the air. We wanted to explore these limits in our own. We use thermal sensing for superconductivity material performance, threshold, linking stability, and collapse to measurable thermal conditions.
Across all experiments, we kept one continuous goal: to define intelligence through measurable organization under changing input and constraints. We increased complexity step by step, moving from AI rating test to atmospheric experiment and then to thermal modeling of computing infrastructure and superconductivity. This progression leads us to our definition of intelligence. It's the ability to produce meaningful patterns under changing inputs, which can be recorded as data, modeled, and tested against observations. Only after this is established do we introduce architecture as the most complex interface. Within an architectural context, we begin by simulating how a line can act as an organizing system that produces consistent spatial outcomes from simple rows. Our first attempt focuses on line self-organization through differential growth. Differential growth sets a clear premise aligned with our intelligence definition. Under constraint and input, a system produces pattern organizations. In spatial terms, the line becomes a medium for measurable organization, where small changes in the rules and boundary conditions generate different legible distributions. To further develop the system, we investigated the use of attractors and repellers to influence the curve's growth. Next, we investigated the role of a dynamic agent, one that actively interacts with the evolving geometry and continually modifies the spatial conditions being generated.
We try to do it also physically. Then we move to a sectional approach, a prototype by pushing a ribbon into a transparent box with voids to see how it's self-organized. We then advance the study by analyzing this formation in section, stacking section by section to allow ultimate growth and connectivity. Here we observe different organization according to the location of the voids. From the previous research, we conclude that most superconductivity and advanced computing research happens inside restricted facilities, not accessible to the public. That's why we set the building theme as a public research facility for superconductivity and advanced computing. CERN, Science Gateway Building, was selected as a case study because it's concentrated the specific conditions for our research to address. in one site. Large-scale scientific computation, research environment, and establish a public-facing interface. CERN, European Organization of Nuclear Research, located in Geneva, the research focused on the study of matter at the atomic scale to better understand the origins of the universe. The campus is situated next to a large collider. The building levitates 6 meters above the ground, and the main premise to be an educational environment. It supports interaction between science, art, and public to help translate complex research into accessible experiments. From our experience with superconductivity, we saw how much these materials are not accessible, but by revealing them, we saw how it's exciting, and we want to make it accessible to people.
After looking into CERN and their research practices, we decided to create our own program for our research building. To begin with, we assembled a dataset of laboratories, public and administrative spaces. Our dataset contained 162 spaces in total, each designed to perform a unique task. For example, among the research-focused spaces, we have such labs as the Systems Integration Lab for optical tests, or nanofabrication cleanroom bay for work on surface contamination. Here is the full list of spaces represented in a dendrogram and grouped by several levels of categories, from higher to lower level organization. On the highest level, we divide spaces into those for research, operations, and public-facing facilities. Lower, we have more specific categories like fabrication, optics and photons, etc. The lowest category level we have is the most granular, subdividing categories of the second order further. For fabrication, we have subcategories like quantum materials and nanofabrication. Using the categories we defined earlier, we grouped the spaces and produced a relationship matrix that quantifies how each space relates to other. This formed the source of truth when calculating attraction and separation between spaces. First, we established relationships between the spaces divided by category 2. Then we added some complexity by moving down the category level. And finally, here is a visualization of the whole relationship matrix. The number of relationships and the fact that they are directed both make it very difficult to understand, even within the context. For this reason, we decided to visualize this relationship matrix as a graph. This way, interpreting which spaces closely interact with each other and which do not becomes much easier. Based on the graph representation of the space relationship matrix, we built a space organizational system. It builds the program of our building based on consistent program-to-program relationship patterns at the level of the whole system. This is the basis of treating the building as an interface and sorting machine. Architecture does not represent the program as a static spaces, but implements these learned relationships as spatial organization. We trained a graph neural network. It can parse the whole complex set of interactions between the spaces and learned to order and position the rooms correctly. For each space, it predicts the initial X and Y placement on the ribbon, and then together with an algorithm, optimizes the placement based on soft geometric and relationship constraints. While optimizing the space's location, it prevents overlapping, out-of-bound placement, and aims to evenly distribute the spaces along the available space. The program is first organized through a single ribbon. As the relational requirements increase, several ribbons are introduced to allow parallel zones, differentiated interfaces, and controlled cross-links while maintaining a coherent organizational logic.
Line organization is generated through rule-based self-organization. 3 rule sets define the relationship between programs: attractors, repellers, and wrap. Attractors are defined by program spaces that require adjacency or shared interfaces. Repellers are defined by spaces that require separation or risk buffering. Wrap rules are triggered by large spatial demands or key interfaces that force the line to fold and reconfigure. Here is a catalog of generative lines extruded to become a surface. Across two or more sections, we can create interactions and surfacing with the next ribbon geometry. This can also allow us to have programs continuing to the next ribbon to accommodate for its size and other necessary requirements. As we divided spaces into different categories, here we show one of the ways of classifying and generating space. Then we began to generate different iterations of forms based on the sorting logic of the programs. Here we restricted the height of the building, allowing it to grow in one direction as more programs were added. On this, we restricted the width of the ribbon, allowing it to grow in one direction as more programs were added, showing the dynamism of the system. After generating different iterations of forms based on the sorting logic of the programs using AI, we decided to go with this as it was more suitable for our program requirement. This has three major program categories, which are grouped to provide 18 programs. Here we have a form of a building generated through the sorting logic of the AI we created.
Because the program relationships can change and rearrange, the floor plan is designed as a dynamic system that can subdivide, merge, and grow based on needs. Here you can see how several growing spaces can interact with each other. Another iteration of even more complex system.
We prototyped this room generated system that has dynamic anchor points connected to the ribbon. Agents are controlled by the building changes by its program. Those agents are located on the ceiling and readjust according to the needs. A dynamic organization of a longer space, unrolling and packing different masses. These are flexible spaces between the floors, created a dynamic and translucent facade.
Here we have a rendering of the building showing from the approach view and showing the translucency of the material on the front facade. We have a view showing from the public zones looking into more private laboratory zones.
We're proposing a new understanding of architecture, one that puts intelligence at the center of everything. Instead of hiding research and computation behind closed doors, intelligent architecture can efficiently use complex processes to surface relationships and thresholds and to curate encounters. In this framework, design becomes less about producing a final form and more about building an interface for ongoing work. A place where knowledge can be tested and shared, and a place that can be reconfigured to better fulfill its purpose when the situation changes. The ambition is to both foster advanced research and make it publicly legible. In our understanding, architecture can help keep experimentation open, continuous, and collective. Thank you.
I will walk you through our models. This is a trial of the self-organization ribbon inside of boundaries. We're trying to do a self-organization of ribbon like digitally and printed with robotic arm. Those are the subdivision of spaces that could reconfigure and change using those robotic agents that are in the ceiling, and we try to do it in a larger scale. This is sections from the building, a small scale of our building, and this is the rule set that we used to generate the formation, the building of 3D printed. This is the prototype of our trying to recreate the atmosphere. Those are the trying to control the atmosphere using different flexibilities of the surface. Three-dimensional surface for emitting the vapor. This is from the superconductivity experiment, and those are levitated spheres. Thank you.
There's two microphones, so one on that side. If you want to start.
Hi. Hi, Ricardo here. Thank you so much. I mean, what a way to start the day. I mean, it was really interesting and powerful, the kind of idea of atmospheric intelligence. And in a way, it started to make me think about the difference between intelligence and wisdom, because we normally talk about nature as wise. And it feels like that kind of thread, or at least in my mind, the kind of difference was about control. And the studies and the research that you've done, particularly the material aspect, is really interesting to kind of understand to what extent you can manipulate and control something that it's perceived as unmanageable. And at what point, you know, like with these atmospheric studies, the kind of air sort of dissipates and becomes its own agent. And then it kind of became translated into these models here where you could see how the material was actually the one that had the intelligence and trying to kind of go in different places. And that was super, super enriching. And I wonder how then that kind of translated along the way into the more kind of programmatic aspects and then the translation into the architecture, because there's really interesting kind of moments of learnings on some of these models, being structure and program, that perhaps could be studied a little bit further on the more kind of architectural snapshots where you had to introduce a second element of structure and other bits that have to then take a different component. And I think there's something there to kind of maybe go back and explore and observe a bit more of the studies that you've done to see how that intelligence carries on to kind of help enrich and translate in a kind of more grounded and stronger way, the way that some of these more architectural examples have been faced. But overall, I think, you know, the strength is in the kind of research and the material, which opens up a whole host of questions and conversations that can be translated into other parts, not just a building, but actually, you know, the implications that this has across, you know, planetary, which is part of the brief. Thank you for that.
It's on. Okay, so I can build on what Ricardo said. Really, really fascinating premise. Again, I think Ricardo said it well about how you took on the complexity of these atmospheric material experimentations. I loved the first experiment on the speaker with the membrane. And without going into it I think there could have been more, you know, you created these atmospheres and you were talking about it as analyzing the field of data. But I didn't see enough of that analysis. I saw such a rich substance for the way that those different types of phase changes were intersecting or expressing across the membrane in different directions, but I didn't really see enough of the analysis. It became a kind of voxelization. And so I think, and I'll keep it really short, it got really, really too reduced when it came down to this two-dimensional ribbon extrusion in section. When you look at the kind of expanding ribbon in the diagram, I think what's fascinating is there's a moment where you can mark certain events, almost like if the membrane bursts or if the ribbon has the taut curvature and then all of a sudden expands, or also then expands into a second hierarchy. And those moments could have given you a lot more richness in terms of how you would translate that into a 3-4-dimensional architectural proposal. I think it worked much better in plan because it's dynamic and those spaces expand and that you create a hierarchy of large and embedded pockets of space. And you can really, again, with the atmosphere, you can imagine the visual opacity, the acoustic opacity, those kind of, even smell you talked about in some of your text. And you can imagine that works in the plan view, but then you've restricted it then all of a sudden to this sectional diagram, which really, it's very, very static and it's very, very reduced.
Love the building. It's a fantastic project. Absolutely amazing. And I agree with some of what you said in terms of the plan makes a lot of sense and as an organizing structure, but the flipping the section has its own advantages, which is it is visually much more a field which becomes transparent to the user as the elevational condition and the layering. And then you're reintroducing actually the plan element and as a subsidiary system, and you dynamize this with these robots. I mean, I absolutely love the project, and I can imagine it there. I can imagine its program and function as this exhibition of this super complex network and sequence of researches, information. I mean, you don't go much into it, and so I think it's wonderful, and also it makes sense to me at CERN in this condition, let's say, as a kind of science museum, information, contemporary. You're also thinking about actually experiments being shown, et cetera, et cetera. So I'm super excited and amazing about it. But I have to say a few things slightly. So I think we need to recognize, first of all, that the initial research, how fantastic and interesting it is. There's a cut, and then there's a restart, and we go into the project. So the atmospheric intelligence, I put this to one side. This was the way these open-ended projects work. There's some kind of free association, some kind of spin, some new discovery, which has I don't know how we associate into this. So that's fine, it has its own merit, but it's not the project. The project's absolutely amazing. I wanted to say something about the way you then worked on that. So with some critical remarks. So you have a number of presentations of that program catalog. And these are all spatial representations because they are 2D at least. So you have the kind of field of circles, you have the kind of matrix with degrees of density, so the 2D and you have the network, 3D network. Now, I mean, what I felt is lacking the awareness that, for instance, if this is the way the information wants to be explored. First of all, it's interesting that you explore them in different ways, and you have to ask yourself, which one is a better match? There's always a kind of system absorbing something, and which one is the best of them? And if that's already the best information architecture and information design, then for me, this means as little as possible to instantiate it in 3D. So that you, for instance, 3D network is then, why don't you build that? If that's the connections. But then you can say, no, this is actually not ideal because some of these lines, I can represent them, but they're not really active or they're too far. And somehow I feel is lacking a little bit. When you have these kind of loops involuting, first one can fill the space. What organization is that? It's a sequence. Actually, it's two sequences, an inner and an outer. It needs to be set, and how do I map that onto the programmatic structure? What would be all on the outside? What would be the inside? What is the sequence A? What is sequence B? Because you can then break through that wall. How these sequences could be matched? Can they be matched? And then you say the other thing is, of course, we have several concentric involuting. And I keep color coding them. You should keep color coding the inside, the outside, circle 1, circle 2. And then you, of course, start layering them. And I think that's what I was making. If you map out from the network into the strip, of course, there's information loss. Now the strip substitutes for the network. So, but, is it the inside, is it the outside? It's still maintained. And what does it mean when it involutes on itself, when it brings close together? Anyway, so there's a lack of seeing that the architecture is always already an information architecture, and that when you map one to the other, there's gains and losses, there's pros and cons, there's the final model. But I think, and of course, there's too much there. But I love the idea, 800 items. I mean, that's the kind of things. I'm an exhibition designer for the last 30 years. I've been thinking about a lot of these conditions. And you have multiple orders in the same space. But I absolutely love it. But that's the next, the discourse which is inside. I'm absolutely super excited. And perfectly okay that atmospheric intelligence was left behind, if it ever was, if there's something like this existed. Anyway, who else?
I have one very quick one. Thank you very much for your presentation. I think some of the comments were already said. I really appreciate the initial part of your study where you correlate the data versus the behavior. And I think at the beginning of your study on this atmospheric intelligence, you actually looked at it from both the two sides of the spectrum, meaning looking at the data, the pressure, the temperature, the humidity, and so on for the cloud formation. And you also looked at how those clouds are formed. So you actually had a very good methodology in trying to look at the entire system as not one set of data creating a behavior, but also look at the behavior, how would shape or how to are conditioning the data itself. So there is this part of your work that is, I think, very strong, that I, in a way, see somehow translated in then your architecture project, this fantastic new exhibition space or set of spaces interconnected to each other. What is actually maybe would have been interesting for you now at the end of this, this work is to look at it with the same logic that you applied in the first atmospheric intelligence exercise, meaning that you have an outcome now, a behavior that is given by those strips that are controlled by the series of agents or dots or spots or whatever you want to call it. And I would have encouraged to look at it now from the final result, how some of the data could have been changed to create yet another set of information that might have brought you to a more, coherent and cohesive connection to what you set up as the complexity of the system.
Yeah, thanks a lot. Fascinating breadth of research that you've done. I think I'm not probably entirely agreeing with your definition of intelligence. I think, or your definition of planetary intelligence. It's what probably I would refer to as physics. Intelligence implies also an element of reasoning, abstraction, and hypothesizing over observations. And like a Bernoulli effect is not intelligence, but I think you have to.
It requires goals. So organisms are the first intelligent creatures. Physics are not intelligent.
Yeah. So I think you can debate whether nature is motivated or whether it's just the stuff that we observe. But I think that becomes a philosophical debate. But I think what is quite interesting is that you subconsciously, or maybe because out of necessity, made some quite strong deterministic decisions, right? So I think you had this ambition, or you have this ambition to use or to create systems that organize and then more or less produce the result. But then if you really look at what you did is you reduced dimensions. Yeah, you moved from something that is 4-dimensional, like your weather simulation, to something that was 3-dimensional, which was your kind of graph network organizing. And I think it would be interesting to learn about the fitness criteria for your organization, because we just imply them and we see them. It might have to do with adjacencies. And then you turned it into a 2-dimensional system, and then you constrained it with axes, right? So what we see is a very conscious statement at the end of the day, and it's I think Patrick kind of talked about the implied aesthetics and that it does something, but I think also being self-aware that it's not really self-organizing. You are organizing it, and I think that's what we do as a profession. But I think also kind of it's almost like a meta debate over what you do in your own in the process of rationalizing the system that you have created. So I think that could be quite an interesting element to that debate, and I think that also kind of when you explain your project makes it more tangible to the audience. But yeah, a lot of work, quite impressive. Thank you.
So I'm not an architect, so I'm going to try and actually a good many of my notes here have already been points in my notes have been said already. So I'm going to try something original, which is on communication. So I'm a former journalist, so. A couple of things. Yes, on the self-organizing and whether nature can be intelligent in that respect. I also would disagree with your premise there that nature has the laws of physics, and so there's a point to be discerned there. But you were really clear about communicating and demonstrating your abilities with the process, right? Your ability to collect data, to interrogate. The data visualizations are amazing. The heat thermal imagery, all excellent. And then we kind of ended up with this conclusion which was rushed, and rushed in two ways. One, you all spoke just a little too quickly. Got to speak slowly, because that's how you keep people engaged. So, and the second point is that when you got to that conclusion, it was all over as soon as we kind of got there. So I really wanted to know far more about, right at the end, when you're talking about intelligent organizing buildings, what do you really mean by it? A little bit more would have been so much more helpful just at the end. I loved, building as an interface is an excellent concept, but I only heard about 30 seconds of that. So that would be my other notes. But otherwise, there was a lot to agree with what the other speakers have said. So excellent work.
Yeah, many points well made. Extraordinary range of work, even in the time frame that you've been given. I mean, really quite extraordinary as a range. And I suppose, as has been remarked, that flip from that preparatory work and then the thinking that derives from that suddenly has to become a building. Or in this case, I would say basically this is an interior design, and nonetheless interesting for that. I don't think it matters much what the outsides are. You know, get Renzo Piano to do some crinkly tin, it'll be okay. But Patrick's point, you know, this business about the juxtaposition of innumerable different things in a given confined space is something that could apply to museums as well as exhibitions, to workspaces, to medical. I think the range of possibilities that you've proposed more or less has no limits, and I'd be absolutely intrigued to see these principles applied, for example, to hospital design, or perhaps medical center design, we should think of it as these days. And I suppose the question that, for me, you know that old thing about, oh, well, the plan is the generator, the response to which was, well, if that's correct, what generated the plan? And I think you have told us what's generated your plan. We saw it in your line drawings, which rapidly, you know, transformed into sections. And what I particularly liked was this idea of internal arrangements being formally based on ideas of attractors and repellers. And I say that because I suddenly thought of that phrase, you know, the blast zone round the club bore that you get in any bar. There's somebody there and there's a sort of zone of indifference around them, but then there's somebody else over in the corner, and do you know what? They attract a crowd. And to me, the question then that left hanging was that all the different prompts that you've put into your self-organizing system, it can only self-organize once you say what the attractors and the repellents are and what the different uses are, etc., etc. And the one thing that's missing out of that is the human element. In other words, as in that bar situation, sometimes it's not the spatial organization that determines the outcome, it's individuals and people. That's not a criticism of your program, because I think it becomes an addition to it. So I think a fantastic, fantastic piece of work.
I'll just add a few words. Thank you again for the very well told story about your whole process. My only question would be, I really love the whole sequencing from the images you show about your analysis of the atmospheric behaviors and how, you know, particles self-organize in a defined space. I also really liked your interpretation of how that would, you know, benefit to programmatic organization, and how you turn that into which is a proposal about these stripes that could self-organize. My question is, you decided to interpret it as you are using the void in your system to define space. What if the stripes was actually the thickness of the stripes was, since all your work is about the relationship and the influence of one particle to another that is then translated into one space to another, what have been super interesting to see how that self-organization and reconfiguration in a dynamic way would benefit the relationship between the space you want to connect. And maybe come back at the end of the presentation on the 3D connection that you create by your Stripe system.
I want to thank you about your presentation as well. It was really informative and very thought-provoking, especially the starting points, obviously. I also want to say something about the models, because no one has commented on those. They are really beautiful, and I think it really is useful to use all the different media you have been exploring, and it comes really well to life. I like the way you presented your project, and also the graphs and the different data sets were really nicely presented. And I thought that was really important to explain the concepts. So congratulations.
Thank you so much. Incredibly enjoyable and fascinating presentation. I think it addresses one of the really critical challenges to the studio and to the program, which is, you start with something as complex and unimaginable and sort of quantifiable as the atmosphere, which of course there's a lot of work going into, and you've done a wonderful job representing. And that coincides with this idea of intelligence, be that artificial or otherwise. And then we have to finish with a building. And fundamentally what you're suggesting is that you are experimenting with something that has a potential, I suppose, unresolved, open-ended, dynamic condition, and yet you're compelled to represent one version of it. So I think the challenge for the program and for the studio in particular is, how do you describe ambiguity and perpetual change in a final presentation? Yeah, discuss. Sorry.
I like the fact that I'm you guys are like becoming the prompt engine for me to have to critically on the fly think, which is good. It kind of keeps me nimble. I think the team has made a good effort to try to bring this together without the creative friction that basically has transpired over 16 months, which is when you start off with a question, the trajectory and the path is not always legible. I think the important part is that it's motivated with interrogating what that is. So the question of intelligence can be philosophical, but at the end of the day, it needs to be somehow addressed and attacked with also the different models and conversations that are happening. So in the process of this, they started with all of those diffusion models and image generators and all of that stuff to be able to become aware of what people are calling intelligence today, but also to reject that and to be aware that this is over 65 years, if not 70 years of engagement. One of the things that I think is important is that each of the teams were tasked with trying to find a response and to see where architecture can participate. So I agree with Patrick that there is a break because the process hasn't been linear. And I think that there needs to be an acknowledgement about where each of these conditions and experiments that actually had a lot of novelty, if they just become excuses to be formalized, instead of really looking at maybe the underlying question in their case, which was the path to try to understand these deeper relationships are really about fostering spaces for experimentation. They took their experience as a starting point to then ask the question about how those things can continue. And I think the building is a first attempt in that. That was something that was, let's say, mandated from my side, because, let's say, for the last 10 years, we haven't done buildings, and nobody believes me that I'm an architect and I like buildings too. So the reason for that, I think, is really motivated, because I think specifically in this science and intelligence, demystifying things and making it publicly accessible, I think is a very, very important driver, not only to demystify a lot of the things that are mediated, but to also create a space where that exploration really fosters curiosity. I will say one thing about intelligence. Long-standing discussions over the last 50 years, sometimes even in this space, about a lot of that early cybernetic work, a lot of the early days of computation. I spent a lot of time with some people that spoke about intelligence not really being a product or embodied in the thing itself, but the space in between things. We can behave in an intelligent manner, but we will only understand that through a very situated engagement. And I think the conversation around a lot of these sciences and technologies are really important. I think architecture creates the space for that kind of understanding, and I think this was the first attempt from them. It came late. They went from acknowledging data centers, trying to explore very different models, but I think the public accessibility thing became something very strong. Looking at existing systems and existing programs became their data set instead of trying to blue sky think what this thing is actually opening that up to think that the building is a framework for others. So I commend the team for actually believing that they could put this all together in a meaningful presentation, because that's not always legible until you do it. And I appreciate the comments that are coming, because I think the team has struggled quite a lot, and there's been a lot of internal friction to be able to get to a point where I think they can really appreciate this as a design research. This isn't about the final building. It's not the closing or a conclusion of something. It should be the opening up of, I think, a path forward for the way that you actually think about things and the way that you guys work together. So I think it's a good start for the conversation today. And Patrick, of course.
1 second. I wanted to answer Ingrid, because in terms of how do you maintain the fluidity and ever-changing quality, and my thesis is, at a certain level of complexity of the space and artifact, it's actually never the same. If you have a square with one building in the center, one room, or 3 buildings, 3 rooms, yes, they will always be the same, because there's no, but something like this keeps shifting depending on which direction you move through it. What have you seen before? You're moving the second time, it's different. And there's so many ways of orders implied, multiple overlaying simultaneous orders you can draw out. And the ambient parameters, you can shift and emphasize. Observer parameters, how the camera moves, like in our mega buildings. It's never the same as you encounter remove, and that's the function of a complexity. And I think it could be brought forward if having camera moves through this, but also the crowds, which Paul mentions quite true, and we can now embed them. And I've been saying an architectural model now has to have occupancy simulating crowds engagement to show. Then you see which are they moving along these lines? Some others moving across. Somebody's, using something which is at a center spot. And in the club, yes, there are individuals, but they will choose points for projecting. So their action is already kind of set up, but in ambiguous. So it's continuous, ambiguous, simultaneous reading and rereading. That's rather dynamic. By the way, they obviously also have the secondary, literally object parameter shifting, kinetic transformation. But I was thinking you don't need only that. There's this kind of continuous gestalt switching triggered by maybe some kinetic transformation, maybe some lighting, but maybe also be simply by the crowd, the way the crowd kind of starts occupying this, and then kind of underlining certain readings through its presence, like this, the valency. Even the space like this has now an unusual kind of order, which is different from when you give a lecture. Anyway, so that's my answer to complexity delivers deliver that. But how are you presenting that? That's another question. Sorry, guys, to come back in the second time.
That's great, and it's good that we got the disclaimer from Patrick. I think the question is that as long as it's a question and it's open for conversation, I think that sets the table for a meaningful day. So I think with this team, I think we can bring this one to a close and continue the conversation with 2 more teams before lunch, if that's okay. Thanks so much.
God, my phone is here. I was and I was pressing out because I left my phone here. And I was like,
Amazing, but I'll tell you that after. Take this? Yes. My phone. I didn't bring my phone. It's on the table. On the. Yes. Yeah. There. I just talked to Agus. She's gonna put the models. Yes. Te dejo el celular y voy a arreglar los modelos, ¿ah? Where am I to use it? Yes, this is. Thank you.
I won't be here.
Okay, go. No problem. Wait. Okay.
Can you squish it? So
Yes. No, I have it, but I need to do it because I need to see my.
Yeah, you will automatically duplicate when you record it.
No, I don't necessarily. How do I do that? It is.
But it's not showing, so that's why you do this.
Where?
Okay, first of all, it's
Because usually I do this and then it pops out.
yeah, so it's not really because of duplication. Wait, so are you sure that it's working?
Is it because you put this on? It worked for a second and then I
Yeah, so it's not working.
It's not connecting.
So,
No. But can you just help me because I need to. I don't know if when I put it on display, it's going to show the comments or not. It should show, right?
Just try.
Thing is, it's not showing on the screen.
Oh yeah, there's nothing at all.
No. Yeah.
Yeah. You started your slideshow now, yeah?
Yes.
Maybe close that for a second.
Okay.
It is close up.
There we go.
Hopefully.
Or do I need to duplicate it?
Oh yeah, it just takes a second, but now it looks like it's on.
Okay.
So
And that's it.
there's no notes on the screen, so that's great. But you can see. So,
Oh, that's the switch.
Okay.
can you advance the slides?
How? Okay.
If it's open, you're the other.
Do you
Yeah,
have
but
it
if it's open on the other side, I
Do you
can't
have
see
it open
the.
twice?
No.
Chance.
No, it's just that
Can you
one.
close it real quick again? So just because it looks like it's acting strangely. Oh, no, that's.
I'm sorry. But it's connected to my But usually when I do this, and then it's supposed to show me duplicate screen, and then that duplicates, not duplicate, extended. So I don't know why it's not extended. Ah, there we go.
It's fine. Yeah. I think you have it open twice.
Okay. Can you give me my phone? Yes. Right there. Okay.
Just double check all your
good.
fonts are all good, everything's working. You have videos? Any
We
audio?
have videos.
Any audio?
No.
Okay. So just make sure everything's fine.
Okay.
Now, before you start.
Okay.
Can you turn it a little bit so I can
Yes.
be on the first part?
And you need to put this somewhere, so
Yes.
maybe find the spot for it.
Here in the middle.
Yeah.
You put it here.
You have two, so you can.
Ah, okay. Wait.
Yeah, just if you can, just try to have them closer.
Here?
Like, you don't need to be super close, but
One second.
Yeah. There we go.
that's a bit too far, I'd say.
Okay, one
Maybe
minute.
move that mouse.
You don't need the mouse actually.
Yeah, this one.
Congratulations. There we go. Happy days. Thank you.
For when you're walking around, that might.
Okay.
Ah, okay. It's on already?
No, you need to.
Ah, okay. Thank you.
Okay. Cool. Hola. Hola.
thank you.
We are in Cora from Generative Studio. It's going to be a presentation. So then you change that next unit, and then
I can't see. Oh. No, but okay, yeah, perfect.
It's there, right?
Yeah, it's there. This one. You just
Okay.
need- There we go. Okay, we're good.
Wait.
Go. Yeah, perfect.
The Indians, did they have like the tables like ours? Or did they bring more models?
And models are really nothing. It's just the models are really good. That's it. We're just talking about it. Do we look good?
Yes. We're already on camera.
Oh,
Right now?
really?
I know.
People know.
Okay. Look at this. Okay.
No, right now they're looking at the screen, so like people moving there.
Yes. Okay. No one's looking here.
Please.
We can't. We will. Okay. Yes. Okay. I'm gonna hear my voice in the microphone. I don't know how that's gonna sound. But it's okay. That's okay.
using up actually.
It's a waiting, that makes sense.
Yeah, I'm just going to make it a little bit nervous.
Tío, no. Trust us, trust us. Tío, after? Let's do it now? Okay. Because what? Yeah. We have to start the balance.
They cannot interact. That's my opinion. It's a very much computational task. It's our chance to trade a huge prosperity, productivity, satisfactory interaction, you know, and they it's not exactly live stream. Yeah. But if you had this was a kind of digital event, which is physical digital, where they would be the essential as avatars. I mean, we have a simulation kind of thing. Where you incorporate one level scale interface technology in between the amount of projections represent, so there's in between it. So there's a kind of 50-50 physical, there's a kind of physical this kind of and marina basic sand is this really yes, it's hey, getting yes, he has, yeah, it's so the day's house we can have a chat.
Okay, everybody, we're going to slowly take our seats and continue with the thesis reviews. Ricardo, please. Good real estate up in the front here. Okay, so we'll continue with the second team from Patrick Schumacher's studio.
Good morning, everyone. My name is Agustina.
My name is Regina. My name is Dana.
My name is Juan.
And we are Team Cora from Schumacher Studio. So basically this year, the brief proposes the mega building as a new typology of hyperdense urbanism at a mega scale of 500 by 500 by 500 meters, positioned in Wapping between the Square Mile, London's primary financial district, and the large-scale mixed-use development of Canary Wharf. Taking inspiration from Ron Kulha's Bigness Manifesto, this urban form treats extreme scale not as a loss of control, but as a condition that enables complexity, coexistence, and autonomy working on one single space. So our project basically responds to the brief of designing a mega building, a large-scale architectural system that is going to integrate multiple programs, circulation, spatial logics into a single continuous structure. The aim is not just to densify, but to create a new model of vertical urbanism where spatial interdependencies and programmatic layering redefine how we live, work, and move. It's basically coherence through complexity and developing an architecture that operates more like an ecosystem than a building.
We studied the Mukab as a critical reference to identify the limitations of object-based hyperdensity and to develop alternative strategies for integrated, legible, and socially coherent urban complexity. We also studied the line to critically assess the limitations of an ultralinear, centrally controlled model of urbanism, particularly its rigidity, segregation of the systems, and reliance on top-down optimization. We also studied Kowloon Walled City as a reference to explore the limits of unregulated organic urbanism and the necessity of legible structured differentiation. And finally, we studied multiple precedents that is a bit about the process of the different case studies to understand the subsystems that enrich our megabuilding. We also studied London, which basically is where our building is located, to address the pressures of the population growth, urban sprawl, and land scarcity, and to explore how the increased density, vertical mixed use, and integrated urban systems can transform these challenges into opportunities.
As for the brief, we took Wapping as the site, and we started to develop an analysis. Do an analysis about Wapping, and we noticed that there's a variety of program, which basically mainly is residential. We also found connectivity points that were key for how our understanding of the project will be, and also we found an opportunity of connectivity between one side of the river to the other. Also, we found like these side marks that we noticed that are like the Tower Bridge, the Shard, Canary Wharf, and Kings Park. And from that we took an opportunity to place our mega building inside with rotations to actually take advantage of the sites. Also, we wanted to be really conscious of the scale of our project, as the Shard is the tallest building in London, and we wanted to do a comparison of how our massing will be compared to one of the tallest buildings in London.
So basically, you can see here a small comparison that we did in terms of measurements. So basically, in the 500 by 500 by 500, we can fit not only 25 shards on one side, but if we rotated it 180 degrees, we can fit 50 shards. So you can actually understand the complexity that we have to handle in terms of circulation, structure, program, etc.
Also, we compare Wapping with Stratford and Canary Wharf because Canary Wharf is a financial district and Stratford is a retail district. So we wanted to actually compare the kind of program that the site had compared with Wapping to actually activate what we were lacking in Wapping. Also, we went outside and we recognized that Wapping, one of the characteristics were the canals, so we wanted to actually take advantage of that waterfront.
And just as a methodology of our project, we wanted to use swarm intelligence as an organizational logic through which urban subsystems collectively generate a coherent whole. So we conducted multiple experiments within simulated environments inspired by the natural systems using simple rules of alignment, cohesion, and separation to govern how individual agents respond to one another in space. The deployment of these agents generated formations and fields of interactions in which spatial order emerged through a balance of proximity and divergence. Selected iterations of the resulting trails were then extracted and translated into spatial voids that organized our building.
Therefore, we started to track the movement of the swarm, and from this point, we wanted to see how we could translate it to actual form and massing. So what we did, we tracked the swarm with curves and started to populate it until we blended as one mesh, and we wanted to integrate the directionality of the swarm on the mesh. From there on, we started to do different explorations, and we started to apply it inside the cube that we already have, and therefore we started to create different orders of void, which we use one of the swarms to do the main atria and then another porosity, and yet we were lacking something else. From there on, we decided to slab the whole building, and there we applied the swarm intelligence in each slab, and we set a different parameters of rules, set of rules and ranges. So the program, and therefore we also started to develop a program. So based on the parameter and ranges of areas like housing, will we have certain amount of area, a different range, and retail also, we started to set those rules as attractors and repellers on the XY plane. And for it to start to give that lack of what we were doing, because we had a lot of massing, we needed porosity, so therefore we started to implement all of that in the set plane, so with different set of rules that were actually twin to the elements that we apply in the XY, and we started to create this porosity and movement and carving. And therefore, we created the third order, that is the porosity.
So here you can see a small solar study that we did. So basically for us, a primary thing since we started the project was actually being concerned about the depth of the 500 meters. So our idea also for the carving is not only to have differentiation in the program, but also to allow to have enough sunlight on every space of the building in the majority as we can. So here you can see we have 3 different orders. The first one is with the massing complete with 500 by 500. Then the second one is with the second order of voids, and the third one is with the final mass that we have. This performance analysis directly confirms the volumetric strategy of the mega building and how the carving enables more access to the sunlight into the building.
From this point, we started to apply as the code. As we apply the code as a program, we also started to develop the cluster, the mega building in 5 different clusters, so we can actually add what we were comparing in between Canary Wharf and Stratford. So the first cluster is the urban gateway. It's what we bring people at Wapping. It's the retail gateway. And the cluster 1, 2, and 3 are dependent to the city. They fit the city as they take from the city. So actually, even the housing from the Wapping that we took from the site are applied in cluster 1, 2, and 3. And then cluster 4 and 5 are independent from the city, are a proposal of a different kind of living. So it actually is completely independent of the city, and we are proposing a different part as farming, hotels, retail, different typologies of housing, and more. We also, yes, we mentioned that 3 parts of the clusters are dependent from city and the other part are independent of city. The program on its own is dependent of one from the other. So we wanted to integrate that blend of program that it communicates from one another to the other, creating a synergy inside the building at its own. So everything is feeding from one another. And also we have a phasing. So if we have cluster 1, as we were mentioning, it's already a gateway. It's something like an iconic point that will bring people to have the retail that was lacking in Wapping. It will be a part where people will come and have interactions. And in each phasing, we are starting to add more. Cluster 2 has more cultural. Cluster 4 has that financial district that actually that will compete with Canary Wharf and stuff. And also, as we are developing the program, we also want to integrate that program within the program. So actually retail has different typologies of retail. Like it doesn't stay as like something static. It actually has a continuation of one that communicates with the other. As also offices, it has co-workings, it has even its own retail, it has cafes, it has that program has another program. And also we have housing, we have different typologies. We are integrating what we took from the city, we are adding more. We're adding a new type of living. And also in the cultural, we have museums, we have cinemas, we have even an amphitheater, we have the farming from the cluster 4 and 6. And the typologies of the housing, we actually did an analysis of that in Wapping, it has the housings are between 30 square meters to 240 square meters of 2-story height. So we tried to implement everything on that, and we started to develop different typologies within that. For example, in cluster 5, that is the most dense of all, we are applying a different typology of capsule living. And also we are applying green areas, open areas, parks, that is nothing it's not only like people having slabs, it's also a way of living and open spaces.
So for the structure subsystem, we began by analyzing the structural layers that is required to ensure the performance of the system. At this scale, the challenge is not only to carry the immense loads, but also to respond to the program that we have and maintain that openness and flexibility, especially given the porosity that we have and the spatial complexity of the configuration. So the structural system is organized in a sequence of layers in which the program slabs first take the gravity loads. They carry those loads onto the endoskeleton, which basically deals with the vertical loads. And then the vertical loads, basically, they go to the connection levels, which are the node levels. Those transfer zones then connect to the exoskeleton that deals with the whole lateral forces of the system, and also it encapsulates the whole building. And then the exoskeleton, therefore, disperses all the loads onto the foundations. As a process, we started with the endoskeleton. We used topological optimization as an algorithm to generate it. We set some loads. Those loads basically respond to the increasing gravity loads towards the base and the opposing lateral loads. We assumed some loads in every 100 meters that gradually increase towards the bottom, and we set some wind loads that gradually decrease towards the bottom. And then this is basically the stress-based density mapping. The result of the branching that you see is basically where the highest points that we need to basically design and rationalize. And this is the raw mesh that we got within our initial phase of the program. And then basically the process is to take that result and try to control the cross sections. And we use that, basically they will double as the structural cores within the building and carries around the voids of the program. And this is basically how it works, and you can see how it connects from the bottom to the top of the building. And these are just some views. So we also did similar process with the exoskeleton. We used the offset shell of the bounding volume with variable support points around the massing and load parameters to produce that enclosing exoskeleton that will resist the lateral forces. And then basically that process is we wanted to take that network, the resulting network that we got, and morph it onto the development of the massing and the program. So, and you can see that we also tried to, we have this system where every 100 meters, the thickness of the exoskeleton starts to increase towards the bottom. And then this is how you see the network within the mega atria that we have. And this is one of the views. So this is a close-up base study to better understand the layers altogether that go into the structure. We consulted technicians from AKT2 who thought this whole system is anchored to each other and becomes all connected, therefore easier to break down as an initial framework, to rationalize and solve structurally later on. The exo and the endo basically connect through those node levels and that you see, and also there's a horizontal band that connects and makes it easier to transfer all the loads within the way that the building is divided. And this is just a section that shows how it goes throughout the building.
Perfect. Then moving on to the circulation system. So basically, we understood that for actually designing circulation, we need to do like a data breakdown to understand the scale of people that we're actually moving. So here you can see that we're working with a total built GFA of approximately 10.8 million square meters. Within that, the resulting population is almost 370,000 persons per day. So basically, these numbers define circulation not as a matter of course and elevators, but as an urban mobility inside a single continuous structure. So here the program is basically unpacked as the surface area. Office and retail generate the largest daily flow and the highest worker density. Here we did a differentiation of the areas to know the flux of people according to the square meters of the program. So circulation is to mediate between fundamentally different rhythms simultaneously. So going a little bit deeper to actually understand where all these people was moving inside the building, we did this people breakdown that basically presents a breakdown of the estimated 368,400 inhabitants related to the mega building. We classify them into 4 main categories: residents, workers, visitors, and hotel guests. At the bottom of the map, we basically map how these populations move through different programs over the course of a 24-hour cycle, distinguishing weekdays and weekends from behavior. So this will actually help us to understand when and where density peaks occur. Basically, these diagrams will show you the hierarchy that we're working on in terms of circulation. We're going to have a primary circulation, secondary circulation, and then transfer zones. The primary circulation is working with a loop, with a capsule system. The secondary circulation is going to be working with lifts, escalators, and diagonal elevators, and then we're going to have also in the transfer zone a system of trains. So when we map the circulation against the massing, the building is divided into 2 large systems, as Regie explained before, because it's working with the program itself. So clusters 1, 2, and 3, that are urban connected clusters, are directly integrated with the external city, and then 4 and 5 are autonomous. They operate more like an internal city itself. So the mobility here, we understood that it needed to be different to actually differentiate this programmatic idea. So this diagram basically shows from the 0 to the 300-meter strategy how it's developed, where we divide the clusters every 50 meters to actually get a smaller scale to work on. So here we can see that for the main circulation system that I explained that is going to be a system of capsules, we're going to have 2 rings of loops that they are exactly the same, but they run in opposite directions to accelerate the movement of people. They are basically three-dimensional mobility wells. This capsule system travels through the void, and it's designed to move with the structure.
So as an idea, we wanted to combine the structure and the circulation together and without doubling up the amount of structure that we have within the building. So as an example, we studied the connection, and we used the exoskeleton as one way to support the sky capsule loop. And we did that through layers of basically having a primary rail that is connected to the exoskeleton, and then a secondary rail that connects to the primary one, and then basically those connect to the profiles that then the capsules move through. And this is just basically the study that we did.
So moving into the capsule system, so this is the primary mobility that we're going to be having. We're using this capsule-based loop with a skip-stop logic. So basically we have two systems inside the same loop. One where each capsule is going to stop on every station, and another one where it's basically like a skip-stop idea. So every capsule is going to stop every 3 stations, so this will actually keep the system fast. So it gives us like a fast way to move inside the building itself. So basically we have a nominal capacity of 40 passengers on each capsule, 34 effective, with 16 loops per hour each capsule. This gives us a system throughout for almost 80,000 passengers per hour in peak conditions. So the required fleet is 167 capsules, also having in mind that we have a percentage for with technical problems, like a spare number of capsules.
Also, we started to develop the design of the capsule that it will be the main area of circulation.
And then for the last part of the mega building, cluster 4 and 5, basically at the 300 meter, we located a sky lobby condition. So this is going to work as a transfer plate, basically. It's going to reorganize the circulation hierarchy at the height and allows inter-cluster transfer without forcing everything to go back to the ground.
And as August was mentioning, we have two main circulations, and also, therefore, we have two stations. The ground station basically is going to be capsule circulation and bus circulation, and the sky lobby station is going to have the subway and the capsule. And we started also to develop a design that we wanted to show like a tattoo of the swarm that will actually motion movement and the pacing of the people that will be as we develop the swarm.
And then in terms of the secondary circulation, this slide basically shows how the internal circulation network derives from the architectural massing. So we realized that the structure is a really big thing or fact inside the mega building, so we thought that it would be good to actually use it for the circulation. So here you can see that as how the endoskeleton that we took the center lines of it, and then we did a network for that to use an angle strategy based on these lines. So after getting the center lines of the endoskeleton, we filtered them according to the angle strategy to get the secondary network. So we separated them in 3 categories that you can see, from 0 to 15 horizontal circulation, from 15 to 75 diagonal, and the ones that are vertical are going to be basically vertical circulations. Now, here you can see a small breakdown of the number. And then we have how these lines are going to be translated into architecture in the project itself. So the ones from 90 degrees are going to be vertical elevators, the ones between 15 and 75 are going to be diagonal stairs and escalators, and then between 1 and 15 degrees is going to be bridges and ramps. And the last thing that we did, as we understood that the complexity is still a lot, basically we overlaid the both previous systems that we have, and we took the stations from the loop that you can see, and the initial points of all the cores that we got from the endoskeleton, and we run the shortest path between them. So this will actually give us the fastest and the most direct way to move inside the building. So here, basically, you can actually see how people would actually traverse the building.
So as part of the connectivity, we just wanted to develop a sketch of the ground interface that deals with the building to bring back the charm of what Wapping was, which had a lot of water channels and attractions to the environment. And we used the same design language that we've explained in our stations and our building, which is basically the swarm fields. And we used points that are anchored to the site to develop like a sketch for that space. And we generated just some initial sketch of how that space is going to be. And this is just how it works within the building. And we also, as part of enhancing the connectivity towards the site, because we've run space syntax analysis and we realized that Wapping is disconnected towards the other parts of the site, even though it's very central to a lot of the high points of London. So we decided to propose some bridges that will connect pedestrians to the building. And that's just an initial sketch of how we use the swarm to design.
So when it comes to identity and design, we decided and tried to tackle all scales from the smaller to the bigger picture in order to give a glimpse and be able to see how people could experience this new architectural typology. For that reason, starting from the smaller scale, we decided to develop and design some key spaces of the hotel, not only because of its privileged position within the building, but due to the actual dynamics of how the City of London works. We wanted to translate and bring the architectural language of the building to interior spaces, starting from the lobby space, where the key element is the huge atria where people would be able to gather and start having this feeling of awe, to more private lounge, where private gatherings can happen, to the hotel rooms, which we gave two different atmospheres, one brighter and one darker, more intimate, giving a more cozy atmosphere through the use of warm and wooden materials, and keeping in these spaces with a smoother, calm, fluid design without losing the essence of the radical exteriors, to end up relaxing in the new highest sky swimming pool in London, where the fluid architectural language is kept.
And from that point, we started to the mega scale to actually have the identity of the whole building, which actually what we are doing is having a facade that is a facade, no facade, because the actual swarm that is applied for the porosity is part of the main character, as such is the structure that embraces and carries the whole slabs. And we started to develop the different spacing that we wanted to invoke how the swarm could be living and how the spaces could be starting to be developed and have like that identity that Cora actually brings, that is porosity, open spaces, slabs over slabs that give these openings. And for example, this one that is the office is the belt, is the core, is a more like peaceful area where people can work. In the station, you can see more velocity. It goes with more closed spaces, pushing people out. And for example, this is the housing that is on the cluster 5. That is another typology that actually uses this structure as the secondary circulation, where you can actually use. So we are using everything on its own, that it goes from facade to structure and circulation as one. Thank you very much.
There's just
Then, like a quick explanation about the models. So basically, we did this model to actually understand the scale that we were working on, to have in mind to have this chart here and then Canary Wharf, and then be able to see how the building would react to these both main points of the city. And the idea would be to actually be able to remove it and then put it again to see not only the part of the city that we're going to relocate inside the building, but also to see how this affects the city itself. Then here we move on to a smaller, like a bigger scale, to show the program and how we can have all these different programs in the entire building, and it's not stuck only in some floors, as some buildings that we studied before. And then this one is the final model of the structure, and it shows how it works all together, endo and exo, and also with the foundations. This one is actually the 4 systems that we explained before all together, and how it's relating to the site with the ground condition and with the bridges that we showed before. And this is scale 1 in 2000. So then the idea would be to move to a bigger scale to show the station that we're going to have in the 300 meters. So this is the Sky Lobby station, let's say, that is going to have capsules and also trains. And here is a showcase of the design of the train and the capsules that we did for the transportation methods. Thank you.
I'm just going to give some emotional reactions here, which is say the premise is so bold, and I found myself just incredibly excited by the future of kind of creativity and humanity through watching the presentation and going through all of it. Your questions are huge. Which is amazing. Humanity's place in nature or with nature, central decentralization, or organic and inorganic forms, and density and the economics of human agglomeration. These aren't small questions, and you took them on with not just as kind of theoretical premises, but with, it would seem, a real kind of practical dissection as you went through every kind of practical reality that you'd have to then solve, fix, create around, work around. It was just incredibly exciting to watch. My one question, I don't know whether you can answer questions now, would be this. And I'm not saying it can't be done, and it's not a critique. It really is just a question. How would a 4-year-old, because you said there were about 54,000 people who live here, how would a 4-year-old navigate this?
Well, actually, the age sorry. So the idea is that with the different facades that we have, that is a non-facade strategy, but we actually gave them like different identities to each of the programs. So the idea is for people to move towards the building and actually be able to recognize where they are standing with only looking at the facade itself. So that was our idea of how actually traverse it without getting lost.
Thank you. Again, just very exciting. Very, very exciting.
Thank you.
Yeah, thanks. I mean, I have to say, I love the bigness. You used that word at the beginning, and also how fearlessly you tackled all of the different layers. And I think you haven't hypothesized. You didn't forget to hypothesize about any engineering dimension of the project, but I would like to challenge you on one thing, and maybe you can just say a few words. How does society within work? Like, is it emergent? Do you design it at the outset? Is there kind of an internal economy? I mean, you're designing a city in a city, right? So there will be different neighborhoods. What's your idea about that?
Well, actually, the way that we developed the program as the clusters were on, like that's why we started to do like the 1, 2, 3 dependent from the city. So it will be like part of what we took from Wapping. So it's like on its own, it's part of London. So it's connecting and communicating with the city. So it works as part already of a already well done city. And from cluster 4 and 5 is independent. So it has its own diversity, its own economy, its own like housing and farming. So it's dependent and independent.
Yeah. Thank you very much for your detailed presentation. I really enjoyed the post-rationalization of your initial proposal. I just have one question for you. I just wondered if, since your approach was really about swarm and carving that initial block, I wondered how your strategy on swarming could have been embedding maybe intelligence on the whole organization of your building, instead of leading to that post-rationalization of how you end up defining spaces, areas, clusters. That images you put at the end about how you link bridges to your overall system, maybe could have been almost the start of your project by defining the. You go super fast at the beginning about the rules you set up for your swarming strategy, and maybe that could have been the basis of how you define that carving, and how you've been maybe a bit fast on the hierarchy of your swarming strategy, and maybe that could have been benefiting a bit more the spatial organization and quality, instead of doing that post solar analysis. Maybe that could have been a rule from the start on how you define the carving process so that it benefits solar exposure to all the programmatic spaces you create.
I want to congratulate you for this fantastic project. I think more than the outcome as such, I think you have been able to ask the right question when it comes to how to intervene in an already quite dense city like London with something that is actually relooking at different aspects. For me, was very interesting the way you asked the question about how to programmatically look at these. And yes, you have the 5 zones, but those zones are very much looking at integrating vertically in section different programs across. I like the methodology that you use in defining the different types of circulation, establishing, the primary node versus the secondary one, and try to work this ginormous project in a way that is, coherent in its own, set of parameters at the beginning. there are many aspects that I think you managed to cover. Also, the definition of some of the detail areas from the capsule to the way you looked at the super villas on the top. There is a lot of richness in your design, and there is for sure a methodology that I think will stay with you, will be part of the way you will work in the future as architects. So congratulations, well done.
I want to congratulate you as well. It's really amazing to see these projects. It's so rich. There are so many different aspects you have tackled. And I think it's amazing the way you presented. You're so optimistic. You're so upbeat about this, because it's quite a daunting project. I think it's such a big element you have placed in the middle of London. Let's see how the developers will be judging this and the local communities. But I thought it was really fascinating to see how it might happen one day and how much effort and energy you put in the presentation and also in the detailing. So congratulations.
Thank you.
I have so many comments, so I was kind of happy to go last to see what doesn't get picked up yet. Yeah, again, initial reaction, let's go. This is really exciting, provocative. This proposal for a non-homogeneous, simultaneously multi-scalar densification in an urban three-dimensional, four-dimensional realm. There's so much to discuss and continue exploring. I kind of feel like you've done the first big run down the piece. Now we can go through and refine some of those approaches and some of those ideas. Okay, to pick up on what Neil said first, just a question. So does this come as one big construction, or is it phased and then it becomes densified in over different periods of time?
So it's phased. We're thinking basically that we start from the first to the first clusters. So the way that we've divided the building is from the 0 to the 500. Every 100 meter we have the clusters divided, and then we have the phasings of the program, and then we have the phasings of the construction as well. And then basically we start to intensify the activities and the program one by one, and that's basically how we're thinking of it.
So there's one thing also that Regi mentioned when she was explaining the program, that the first cluster would be like the urban gateway. It has a lot of retail, so that would actually bring people to the site and will actually start like a lot of network in the area. So that would actually start calling people to the site. And as we go up, we start changing the different activities. But the first cluster itself, it remains as retail. And then as you go up, it starts to develop more. So the idea is to actually do those phases. So that's why we thought that retail would be the best thing to have in the first cluster.
So it's independent, but also dependent. So that's the way that we've basically created that.
I guess it could have been great to see that also as animated through time, because I imagined when I look at your project that there's this mega endoskeleton, and it's maybe very porous, and you see views of it through the city, and then it eventually starts to become more and more opaque and filled in over time. A few things that I'm missing, because you've gotten all the congratulations and compliments. I think it's great how you've done that non-hierarchical urban gateway, the way that these kind of urban chunks are fitting around and with each other. But I haven't seen enough in you started it in your analysis, how this sits in London, but I don't see anything on the periphery of the project. Every diagram has been a cube with no, even on the model, there's a kind of like blank desert ring around the building. So how does this tie into or grow out of and emerge from the existing urban programmatic cultural fabric of the City of London? And also you touched on the water, and you're showing all of these views from the River Thames, and you've designed this bridge. I saw some other perspective about the water moving in a three-dimensional manner through your atriums, which is really fascinating, but I don't understand if that, like, what the thinking is behind that. You want to answer?
Yes.
Okay.
So the way that when we studied the site, we actually we visited the site, we saw how it is. It's a bit disconnected. We could have been enhanced. So we took every good part about the site, which is basically the water channels, the housing, there's a sports center as well. And we tried to replace it within the program, but also enhance it. So we basically replaced all the cultural parts that were there, and we increased that. So we added to the program. And then we also, within the design of the ground condition, as an initial idea, we actually took the points that created the fields from the existing connection points within the site. So within that perimeter that you see, is those points were used to generate the fields that guides people. So there's still some connectivity and some relation to the site. And then also the bridges, they connect, so the center one connects to one of the parks from the other side of the river. So it basically as an idea to connect people. So, yeah.
I think just as advice for future, to try and convince and bring people along with you, back to Shiv's comment, for the other team, you need to explain that, and that needs to be a visual communication. It needs to be part of the story, because I can kind of read into it in some of your model, but it looked very isolated. And also the comment before about these swarms, okay, there's a certain sense of movement, but what is that relationship programmatically? Even your diagrams of the bubbles, they're kind of offset spheres, and I understand it needs to be quite abstract at a certain level, but there's so much more. You've gotten into such detailed metrics that the qualities, the qualification of those movements and the interface between these programs and the interdependencies isn't really clear in how that works in a three-dimensional matrix.
Yes, perfect. Thank you.
Just to add to some of those comments, some of the comments will be with a caveat, because I appreciate that you were very rigorous and systematic in the way that you approached, and there were some meaningful moves and strategies at the urban level. But as I was kind of going through your presentation, it strikes me that there were some key elements that could have been enhanced and explained, just to Melody's point. For example, the case studies that you were mentioning, right? You kind of have to assume that there was something interesting about those case studies that led you to some insights or questioning. I think those would enrich a bit more the argument to understand better what the kind of thinking behind some of the decisions, along with some of the other kind of moments where, you know, the way that the program is distributed, and we have to kind of assume that it's okay. But I think those things, if they're kind of snapshots and kind of understand what the experience or what's, you know, an example of what that looks like, it will be really useful to enhance and improve even better the scenarios. And the bigger kind of question that I have, and it's just a general question because of the ambition of the project, is what's our take in terms of creating monoculture and multiculture? Particularly in the context of Southeast London. It's one of the most multicultural places in London. And in a way, they celebrate and they kind of really fight for it. And at the moment, there's a big question for me on like how much of the analysis went into just the kind of urbanistic aspects and really understanding what makes Wapping Wapping, and how do you translate those elements to at least take a position on whether there's something that wants to be enhanced or it requires something that a new element that will kind of continue the future of Wapping, as opposed to a more sterilized approach. And I think it's just a provocation for you to take on and maybe reflect on. But all in all, amazing ambition and effort. Thank you.
Well, everybody's been so nice, but it's an architecture school and we're here to criticise, so here goes. Let me first I applaud, of course, the ambition, the dimensional kind of bravura nature of the project. But let's just start off with your swarm. Swarms are things, or flocks, where they're all exactly the same and they move simultaneously. In your project, nobody moves simultaneously and they're all exactly different, which is why you've got posh people in the penthouses and kind of drone workers in the little studio flats. That's point one. Point two, there's something extraordinarily old-fashioned about this because, okay, it's scaled up what isn't these days. It's a 60s megastructure, but in certain other respects, it hasn't moved on, has it? I mean, what's the big zoning plan here? Zoning, there's a 50s idea, never mind about 1960s. As soon as you get in there, the hybrid nature, it's zoned here and there. You've got to have transport to move from one zone to another. You created a problem, how ingeniously can you solve it with your vertical transportation and your diagonals, etc.? But in the end, you're saying the only real relationship to the outside world is a shopping centre. That's the only reference to why people are going to go there who don't live there. You've got, hey presto, not only have you got zoned retail, I mean, they don't call it that anymore. It's embarrassing. They don't call it shopping. It's kind of consumer-led, you know, visiting regeneration. But then we move on to something even more old-fashioned. Offices, zoned offices. I mean, they kind of call them workspaces these days. They're not supposed to be offices. You know why? Because the people living in your delightful capsules don't need to go to an office. They can use all that tech you're referring to without the need to go into a worse space and sit at a workstation which is less comfortable than what they can experience in your no doubt fabulously designed kitchens. So I think what we've really got here is kind of fortress whopping. That's the phrase that came into my mind, which is unfortunate because fortress whopping was the occasion of one of the biggest industrial disputes London has ever seen, where Rupert Murdoch and the power of capitalism and technology defeated fuddy-duddy print workers who were all thrown out of work. I see no reference in this to anything to do with the industrial history of Wapping, and nor come to that with the fact that it was the site of the London docks, the very start of the London docks, with this fantastic relationship to water. Incidentally, if it's a fortress, why don't you just cut a little channel off the Thames and put a moat round it, and then it could be really isolated physically as well as psychologically. So the fortress thing is happening, and I suppose the comparisons that you make, well, the line, semi-abandoned. The walled city Hong Kong, demolished because it was completely disgusting. Another contrast you might have made is Canada Water, which is what you're proposing, but without the megastructure on the other side of the river, which is actually quite good for comparison purposes on population, etc., etc. And for a kind of mini version of the same thing, you could look at Battersea Power Station, which, guess what, has retail, it has offices, it has people who live there. It has a transport system. It even connects to the river by you know, boat or whatever they call it. Where's your pier? I didn't notice it. Maybe it's in there, but it would be nice to see it. So it is a fabulous project, but actually I think that some of the assumptions made and some of the comparisons made could have done with a bit more analysis and a bit more critical perspective. Because I think finally, you know, just because you can do something doesn't mean you should.
That's a great critique, I think, and I'm glad to sort of go back to it. I think you can expect that London will be the last place in the world that will ever accept these projects, for all sorts of historical reasons. But what is right and what I like about Paul's critique is that he raises a lot of issues that you guys have not thought about. Number one is the issue of the societal model that such a big part of city begins to discuss. What is the project here, right? And I think if this is, I did a quick calculation, this project will house 3.5% of the whole of London, okay? So maybe you need 30 of these and then London is finished. But I will say this, in terms of the project idea as a projection of what a future human society or cybernetic or completely digital, I don't know what society is going to be, is a question that you haven't really responded to. I think the downside in your presentation is that you went off in a real estate rampage at some point, and you started discussing areas, 2, 3, 4 bedroom apartments, you know, all the normality, because I think you didn't want to take it far enough so it becomes completely unreal. And knowing Patrick, I think he would have liked a little bit more unreal, if we are honest. And I think there is a reason for that, because I think if you're projecting a utopic society here, then you've got to describe what this is all about. Paul's comments about zoning is very spot on, okay? Because you don't do all of this stuff so that you can create little sort of suburbias of neighborhoods that are hanging up in the air at great cost and expense. The other thing is, I think the logics that you're using here are sometimes good in small boutique projects. They're very, very bad in very large scale because they're very wasteful. So I think, it's interesting to think about the Eiffel Tower. It's doing something, but the rationality of the structure is always there. And I think here, in some cases, you've taken it a little bit too far. So there is a tension in these projects always, that the mega structure as a structure wants to be simple, and the mega structure as a societal project wants to be very complex. And I think what architects need to do is strike that balance one way or another. So the real question here is, given that your project is not and cannot be contextual, whatever you say about it, retail malls, big open space on the base, connection to the river or whatever. You can put a river in there and it would be a river in its own side, Thames 2.0. And I think your point shouldn't be about how much stuff you can fit in here, but how eloquently, how elegantly, and how beautifully you can synthesize a new society. And a new society is based on principles: justice, fairness, equity, access, visibility, light. And I think you've now learned what it is to do the big dirty projects. But I think if you will ever continue in this vein, or as professionals, I think you have to also now begin to consider more carefully at the real values that architecture brings, because I think that's what's going to make or break a lot of these propositions. So I would like to congratulate you for having the stamina and the courage to take on something like this. It's not easy, it's very complex, and I also know it's a lot of work, okay? But I think we have to, at some point, keep in our minds that there is a whole lot of conditions that we have to continue beyond the craftiness of how we as architects make projects, going from systems to subsystems to secondary, third and fourth and fifth and sixth level sort of type of subdivisions to make something beautiful. So I think that is my comment. Thank you.
I just want to say very, very few words. I mean, fantastic. I love it, and redeeming the kind of risk we all took as a studio on this one. I think extremely well explained, and I love the way you come back and you're dialoguing, and it's not just between us. So congratulations for all of that. I mean, I feel the photorealistic renderings are very important, and I've been a bit subdued because I think it makes it tangible. You can start seeing it, and even we need that, even though we learn how to look at abstract diagrams. And that helps me, and some of these spaces, I mean, why I think yesterday was that this will be the new landmark of London. This will be defining London, like the way the Eiffel Tower defined Paris after it was there. And it has a number of things. It's not a fortress because it is not in Wapping, because it is in London. It's between the city of London, the Square Mile, and Canary Wharf, and it's anchors, and you see it from everywhere. St. Paul is gone basically as a secondary, and it defines it, and it has this depth of intervisibility viewing through it, and this fantastic three-dimensional urban squares or atria spaces we've been looking at and talking about mega atrium, and that's just scaling it up. I love the richness and density. That's why it's different from a 60s megastructure, which was just endless repetition of cells on an isotropic space frame, and this has this kind of differentiation swarming. I mean, there's still a lot to go with the swarming, by the way. These are 3-4 different programmatic swarms, yes, and these swarms need to be differentiated. They come not as, in nature they are kind of single species swarms, although they're also so kind of multi-species. And so these things, maybe it's still a bit crude, it's still collaged, and isn't as kind of legible and information dense and as it should be, but it does a lot. And by the way, one more thing, just a little thing, you're talking this interesting stages and steps, and severing off the top as an autonomous thing, I find quite fascinating. And then maybe you should have articulated this more. The sky lobby should be dense, and then there's something happening which is different at this top, and so on and so forth. There's more articulated work, but I love it, and I'm deeply rewarded by your fantastic team.
Look, I think the conversation speaks a little bit to the fact that it needs to be a conversation. The reality of these things is that these buildings are happening, and they're not buildings in a traditional sense. They are, in some sense, a reflection of a whole series of different forces. And at the same time, the way that we kind of speak to these projects, I think, needs to change. I think yesterday we started with a discussion about seeing the first generation of these things that, you know, we can't talk about this project as being context responsive to Wapping. I think this is not a criteria that's important. You can say it's a strategic place, but you have to kind of give a window into what is motivating this kind of organization, and it won't come from traditional language or programmatic drivers. It will have to come from radically different forces that potentially could be shaping the exploration of these kind of spatial strategies. The reason I say that, yesterday I put a subject of something like, you know, Liam Young decided to put a project together speculating on the idea, what if all of humanity was actually in one city, in one construct? He called it Planet City. That speculation was more about environmental concerns, and it was a proposition as a manifesto. At the same time, the megastructure, even if we always kind of oscillate between utopia and dystopia, the reality of the megastructure, sometimes without vision, has happened over the last 30, 40 years, with the amount of actual footprint that's actually being built and continues to be built. So the reason I state that is that I think it's very important to look at these projects and to look at them as pieces of design research that we can interrogate and actually start, I think, to really inquire about what are the terms of reference that we are looking at. The history of architecture continues and evolves, but yet we are, in some sense, very traditional in terms of the normative associations that we have. And I think that it's an important project in some ways because it's provoking attention, which is obviously always there, but we have to somehow, I think, leverage that to really try to engage new ways of asking these kinds of questions. You know, we talked about the line. I mentioned yesterday Alan Bootwell's proposal. The provocation is not enough. Things are really, really complex at the moment, so we need to speak about complexity, but we need to talk about it from a social point of view. We need to talk about it from an equity point of view. We need to talk about it in different ways and open up the conversation and expose that tension in ways that are meaningful for an audience like this. Because in some ways, we have a closed conversation right now, but we are always, in some sense, in dialogue. For any developers in the room, I'm sorry, but you will not construct the future based on the terms of market and so forth. There has to be other agendas because, and I think that that has to be spearheaded with some motivated kind of agenda from your own side about how this thing is going to be a living infrastructure. And I don't think that we're doing justice to the possibilities because we focus internally on its generation, and at some point it's a bit of a celebratory approach to get to this stage. But I think for a forum like this to be able to have the conversations about how we can actually work on some of these challenges, I think is really important. Nobody talks about design these days. It's a dirty word. Vision sometimes is seen as something that is like always just like some grandiose monument to ourselves, and I think that the challenges are much more complex, and the time and the patience to have those discussions are almost non-existent, which I think is really not helping us. So the reason I say that is I think Paul's comments and the other comments that are being made on, I think, really need a deep reflection. The way that we choose to analyze things, or if it would happen in London or someplace remote, the challenges are whatever and wherever the complexity still resides. What does it mean to have this density of people together? You could make the argument, how much housing is London really trying to build, and where is that going? You could make the arguments from very different places, and I think you need to do that. Like just showing 50 shards is not a justification. It's just a way to understand scale on your terms. So I think we need to do a better job to really be able to qualify the complexities of why projects like this should be explored. And I think the more that we can speak about the dynamics of that, at least the better we'll be able to understand their appropriateness to certain problems or not. I state that because the conversation is going to continue. We're going to move on to the next project and then break for lunch. Just a reminder of a schedule. But I think the discussion is really important, so I don't want to kind of gloss over some of the comments. I think you guys really need to self-reflect on it. It is an exciting project. It's full of paradoxes, and I think you should own that complexity and really start to, I think, address maybe different ways of communicating and discussing maybe what the next generation of motivated kind of things and thoughts that you guys need to sort of work on beyond structure, beyond program, beyond selling and marketing and developing and all that jazz. Anyway, with that, I think you guys got a lot of really good feedback. I think we'll break on this one and we can continue with the next. Thanks.
Thank you.
Okay, everybody. We can try to find some seats. And this is the third team for this session and the concluding one for the morning session. We'll take a break for lunch afterwards. This one is coming from Andrea Andrews' studio. Please.
We are Team Nautilus from Angie's studio, and we're honored to share our work with you today. I hope none of you are hungry, but lunch will come soon. Project Nautilus began as an investigation into how architecture can adapt dynamically to extreme environments and respond to growing resource scarcity. The studio explores mobile self-sustaining bionetworks, units that aggregate together to form urban systems capable of supporting life in environments traditionally considered hostile to human habitation. Cities have historically grown through expansion and sprawl, placing immense pressure on limited resources, particularly land and food. This led us to question how architecture might create adaptive systems that relieve this pressure, and what role architects can play in the production of food, a foundation upon which civilization has always thrived. Today, most megacities are located along coastlines with a dense concentration around the East China Sea, regions increasingly vulnerable to climate change, sea level rise, and coastal erosion. In response, Project Nautilus turns to the ocean as a new frontier, reimagining it as a site for resilient, adaptive, and food-producing urban life.
As we start to map the urban densities and the rising sea level, we notice 3 important zones with the maximum population in danger. The third zone is home to around 200 to 300 million population. It is an intercept of a triangle between Shanghai, Incheon, and the Japanese cities. And in the center of the triangle is an island, Jeju. Jeju Island is a volcanic island in the south of South Korea, and it is cartographically limiting the urban growth due to the central Halasan Mountain, forcing the urban growth to the north and the south. This is why we think our testing bed is the best placed in the Jeju Island. Project Nautilus positions architecture as an active respondent to climate change and resource scarcity. Through the lens of Steps to an Ecology of Mind by Gregory Bateson, we derive a framework wherein we approach conservation, industrial ecology, human ecology, sustainable development through energy, climate change, resource scarcity, and through strategies such as investigation, activation, and visualization.
We began the project by researching historical, existing, and speculative precedents that have explored alternative models of living and resource production. From this research, we identified a set of key requisites, which we translated into mobile unit types that work together to form a complete system of urban life. These include habitable units for human occupation, fully automated farming units for food production, community units that function as shared harvesting zones for both food and energy. As our research progressed, we focused specifically on methods of harvesting food and energy in the ocean, which led us to the potential of underwater farming. Farming beneath the surface offers a very controlled microclimate, which is pest-free and a very pest-free environment, along with several ecological and spatial advantages. This led to Project Nautilus, a model of sea farming urbanism, where automated farming pods form a large-scale underwater aggregation, while human life occupies the surface. At the point of harvest, these pods detach and rise to designated harvesting zones, activating community engagement and creating a cyclical system of interdependency between the underwater and the surface walls.
So first, coming to the habitable unit, we framed the habitable unit around two optional states, the floating or cruising state and the emergency state, and how the interior adapts to each. Conceptually, the project draws from Great Link's room vehicle with its rotatable interiors and Luigi Canoni's biodynamic influence and performative design, extendedly biodynamism. We study clump shales, observing how crisp yet smooth surface achieve structural stability. We identified a similar behavior in a family of geometries known as ferricones. These geometries consist of perpendicularly intersection identical shapes wrapped in a developable skin. We attributed at those shapes for fluid efficiency and production feasibility. Through comparative testing, the alloy emerged as the best performing methodology. The alloy is formed by two perpendicularly intersection circles and exhibits a constantly rolling without a fixed axis. The geometry naturally supports stable flotation, efficiency magnification, and favorable fluid dynamics. However, its primary limitation is restricted habitable volume. To address this, we parametrically control the methodology. This was done by shifting and elongating the construction panels, and additionally, set of parallel planes was introduced to accommodation headroom. The resulting geometries was calculated based on circle-ellipse combinations. Each variance was attributed for habitable volumes, export surface area, fluid dynamics, and hydrostatic stability. Through comparing this, the field was narrowed down to two optional geometry, CC-XX and EE-XX. These were further investigated using an evolutionary design approach, the selection criterion, habitable volume, and surface area. The geometry with the highest fluency of occurrence, EE-X-axis, was selected.
As we seek to respond to a more extreme environment in the ocean, we move to the stabilization characteristic of a gimbal, a 3-axis gimbal, which locks at 45 degrees, forcing the unit to stabilize itself by distributing weight equally. By simulating this same thing with the Beaufort number ranging from 1 to 11, we see that the time and the rolling graph has significantly decreased by 80%. Now moving on to the more detailed design of the habitable unit. We started to develop a theoretical framework in collaboration with Marine. We spoke to Flor Spargen from Marine, who was an offshore engineer who developed these offshore energy harvesting units in collaboration with SolarDuck, and we derived our theoretical framework in terms of hull design and designing shapes for stability in water. We observed that the V-shaped hull was the best performing hull shape in the extreme environment and in the volume that we required. Later, we started to parametrically control the alloy to reach the hull design that we desired in terms of the V shape by controlling draft, gunwale, and gunwale depths. Go back. Later, we started to control the center of buoyancy and the center of gravity, and we observed that the central arch keel of 55% draft was the best performing one, and again, the same was the best performing in hydrodynamic situation. Thanks. Now, later developing the exoskeleton, we started to derive all the forces incident on the surface and then topologically optimizing it and overlaying it with a stress and strain diagram, which helped us develop a very delicate and intricate system of structure horizontally and vertically. Now moving on to the intra-unit connection, we sought to derive this logic from inflatable emergency rafts, wherein we pleat the inflatable to achieve maximum volume. We achieve the same thing by extruding the central arm to form a triangle, an equilateral triangle with a chamfer of 120 degrees. This gives us a connection axis in 3 different directions, helping us to form triangular, linear, and hexagonal connection through an elastic modulus connector. For inter-unit connections, we chamfer the unit by 45 degrees to connect to the community unit and the farming unit, which will be discussed later. Now moving on to the programmable soft interiors. We start deriving the idea of punch cards to computation through Ada Lovelace and Charles Babbage's analytical engine, wherein they have a difference between operational and variable punch cards. And we also observe that the Harlem handweavers of the Jeju are pretty well equipped for manufacturing large-scale productions, and we derive the idea of computationally deriving the knits by controlling porosity. So we used a KH830 knitting machine from the 1970s to start our testing bed with 2 porosity controls, the needle bed and the tension dial. Starting with the operational punch cards, which we again derive from Ada Lovelace's analytical engine, we start our physical production of controlling the porosity with different punch cards manually. However, we observed that there was a limitation to the machine. That's why we turn into computationally deriving the logic in terms of converting a catenoid with rotated plane axis, deriving its principal stress gradient, converting it into a binary sequence, and then deriving a punch card. Later, we also try to test it with a different rotation of the axis within the XY plane and YZ plane, and also by scaling them proportionally. Once we had figured that out, we started to derive more complex geometry and deriving the punch cards for the same. Once we had figured that out, we move into the variable punch cards, which are the second part of the double skin membrane that we're designing. This is where we start introducing different materials by lamination and tuck weaving. And we started our tests with elastic fiberglass, carbon fiber, and optic fiber. Later, we start developing our design with these knits, wherein we start operating it through inflation. So the idea of our unit is the central sphere nested within the oloid is inflating during the stabilization duration during stormy weather. So we again start controlling the knit by laminating the knit of variable porosity within latex to observe that there was controlled inflation in different parts based on the porosity. Now moving on to the design of the habitable unit. We start the habitable unit design with the help of anthropometry and basically deriving the minimal volume with respect to the human occupation and the activity inside. The floor, starting from the top at the connection podium, connects to the harvest unit, taking us down to the central living space, kitchen, dining, and the cockpit, and later taking us down to within the sphere for study, bedrooms, and the engine rooms. The sphere acts as a refuge area during storms wherein people would enter throughout the stormy weather, and the whole sphere inflates and creates a protective environment within. Deriving the floor layout, we started to align them with the structural patterns and both on the side profile and the floor profile. This is the exploded isometry, basically describing the structure of the unit. We have a fiberglass hull protected by an exoskeleton of fiberglass nits covering the marine-grade stainless steel structure. The floor plates of 3 levels are again made of fiberglass with steel brackets, and the plexiglass forms the transparent and translucent layers within. We have a stainless steel bearing mechanism which helps the sphere to rotate within the axis, and the inflatable nits are again made of fiberglass, and the fixed staircases are laminated fiberglass. These are a few renders of the same. These are interiors shaped by tension.
The design of the farming system began with the fundamental question of how architects can actively engage in designing sustenance for habitation. As Carolyn Steele asks, what does it really take to feed a city? Our primary design inspiration comes from Interstellar Labs' Biopods, a closed-loop farming pod system, and Nemo's Garden. We were also very honored to have a studio lecture from Jim Rohn, Chief Product Designer at Interstellar Lab, who is also here with us today. Thank you for joining us, Jim. The biggest non-negotiable in designing, we started to derive the design mainly by focusing on 5 main considerations, which is buoyancy control, how it can be pressure resistant as it needs to go underwater, how does it connect, and how can we passively generate fresh water, and is there a possibility to harvest sunlight from the surface? The biggest non-negotiable were to understand neutral buoyancy, which helps an object stay passively at a certain depth in water, and geometries that can resist the overwhelming water pressure, of which the multiple intersecting sphere geometry was concluded as optimum.
Since spheres are the most resistant shapes in an underwater medium, we start to look into sphere packing logics to derive our base geometry for the farming unit. We identify spheres naturally tend to stack in a stable tetrahedral manner, so we derive an inverted tetrahedral sphere cluster as a base unit geometry. We opt for a helical packing cluster for efficient resistance of pressure underwater. We explore possible cluster typologies and evaluate them on packing density, connection access, and surface exposure for potential light harvesting, and we found type 1 to be the most efficient cluster module.
The next step was to design the individual farming unit. Once we did the sphere packing study, we got the axis of connection and the edge of connection between 2 units. And from there, we started developing the structure. From our study and research, we understood that the curves at the intersection of these spheres are very critical. And so that became our crux of the structure, and we embedded the axis into that structural frame. The next step was to topologically optimize the fins by putting the pressure that it would experience underwater, which is along the axis, lateral pressure, and other forces as well. And we derived our structural system from that study. And this is our evolution of our exoskeleton. We first did an initial iteration, and with the study, we developed our current iteration. The next was to look into how we can harvest light. As we know, the visible light attenuates very drastically as we go underwater. And it is an inevitability that we would need to have artificial light in our units for the growth of these plants. But our question was, is there a possibility of increasing the transmission of natural light underwater? And could we reduce the amount of energy that the unit would need in using artificial light? So we looked at the theory and practical example of Fresnel lenses and domes, and how it can focus sunlight into a specific receptor. From here, we developed a system where we used the dome that is already embedded in the geometry as a Fresnel dome. And the light can be focused into a receptor and transferred to other units for transmitting the light using wet-made fiber connections. We looked into freshwater generation. The main inspiration was Nemo's Garden. They derived a system where you heat a very thin layer of water and a thin layer of salt water that you get from the ocean, and the water vapors would be fresh. And it is collected on the surface of the sphere that is in contact with the cold water of the ocean. This brought the question of, can we have a corrugated skin on the surface of the sphere, which would give us more area to harvest water, and also, if we can make it morphable, we can have unhindered sunlight during the day, and we can have this skin during the night to harvest water. So we started our study into trying to see if we can develop a modular skin of morphable a morphable skin of corrugated members. And these were an iterative study that we did throughout our research. These were some studies that we did in trying to understand if we can have like a perfectly created dome out of these modules. And we tested the dome, the corrugated dome, and a simple dome to see how much of a difference we can have in the water that's collected. Coming to the interiors, we derived the dimensions using the robotic arm because we want these units to be completely automotive. The top three spheres of this unit is focused on farming, and the bottom sphere is focused on servicing the unit. And we developed two main iterations, one which has a shelf-like arrangement of these plant slots. As you can see in the section of this unit, you see that the bottom sphere, which is the technical sphere, has a ballast tank which helps it move up and down in water. It has a technical space for the machinery needed to harvest and form this closed-loop system. It also has a freshwater tank that harvests the water from the skin. And since we have a robot that is catering to all these requirements, it is situated on a robot piston that can go up and down in the spheres. Once we did that iteration, we started to think if we could make it modular instead of having it as shelves. So the idea was to divide the sphere into equal or as minimal of a variation as possible, and we can have a subdivision which could be modular. So we developed the second iteration, which has plant slots that are identical modules, and it provides a much more dynamic arrangement. So once we started developing the plant system, we started to understand that having the transmission of light in a unit that is harvesting plants was not possible because the plants would obstruct the light. So we segregated the function of the unit where the top unit in our aggregation would have the light receptors and the water harvesting system, and all the other units would be used for plants. And this is an exploded view of the design of the farming unit.
So coming to the harvest unit, the harvest unit is structured around two primary options, foundation utilities. So in this, in this harvest unit, it has three states. In the energy state, the unit generates solar power through the floor and also has an ocean thermal energy system beneath it. Together, this system produces sufficient energy to support the surrounding network. And in the food harvest state, the farming unit pumping up and it can dock after each produced circle. Also, the unit can become the social node, hosting ocean-based communities beneath a developed dome inspired by a maritime sail system. So based on this research, Jeju Island remains highly dependent on fossil fuels, but aims for carbon neutral by 2030 through offshore renewable energy initiatives. So as we calculate harvest unit energy, it supports a ratio of 1 community harp, 200 farming units, and 50 habitable units. And for the food production capacity, each farming slot yields 2 kilograms per circle. A network of 1,000 units can support 250 habitable units while offering approximately 5% of Jeju Island food consumption.
Moving on to the small yet mighty unit, the carrier unit, which connects the farming units to the community units and also taking it to the offshore. These units connect the system with the land. Coming to the collective logic, we start with the idea of a system, a modular system that is helical and connects to each other in a helical manner. So in responding to the 3 non-negotiables of the ocean environment, which is the rolling depth, the pressure, and the visible light, we come to the conclusion that this modular system, which is composed of a single module multiplied and which is multiplied and then made more dense as you go down to increase pressure resistivity. Next. We do the same and start deriving the line diagram from this helical system to further develop it within our system.
From the network study, we extract and simplify the variable network to derive a simple modular cluster, which will be populated with a farming unit. And we further expand the network and the resultant packing spatially. Our collective logic starts with the large-scale spatial deployment of the farming unit. We start with a highly dense close-packed deployment, and it's carved out porosity for functional purpose in an incremental manner, starting with creating unhindered vertical tunnels for ascension and descension of the farming unit when they complete the harvest cycle. With introducing incremental porosity, we analyze the helically packed column of farming units for surface exposure to analyze the light harvesting capacities in a densely packed environment. We look into natural and artificial breakwater systems and replicate the behavior in our mass deployment by introducing a lateral gradient porosity dependent on the shore direction. And then we go on to do a wave breaking simulation and analysis based on this induction of porosity, and we observe that as the porosity increases, the wave breaking capabilities of the structure also is much more efficient. We test it out. We test it out physically as well to once again observe these behaviors. And then in relating the surface networks with this underwater network, we have buffer regions for both the harvest unit and the light catchers units, which is floating above water. And these buffer zones kind of sorry about that. These buffer zones intersect with each other to form a circulation network for the habitable units on the top. And then this is a light transmission simulation which shows the deconstructed transmission network because of the way these units are aggregated spatially. And to further solidify the relationship with the land, these units act as a wave breaker as well as a coastal shore protection for the land, and the transport units at the same time carry the farming units to the shore for surplus production and repair and other needs. This is an overall view of the project and how each unit works in relation with one another and the environment. Thank you.
Thank you. We would like to thank everyone who helped us do this project, especially our tutor, Pierre, and all the other tutors, our phase ones, and everyone in general who helped us do the project. Thank you.
Thank you so much. I'll be tested. So we start with the catalog of our units, which we then started to weave to test the meshing idea. This is our knitting machine that we use throughout. And as you can see, there are many have mistakes, which we learn from, which is how we derive the idea of the tension gradient. So these are super important to us. Then we have our sketches for our interior models through knit surfaces. These are our resin cast knits with tensioned area here giving us the curvature. This is the unit which has a rotatable, as we discussed, the gyroscopic center. This is the 1:15 model of our farming unit. The initial prototype with the thinner, which is why we understood that it wasn't working when we physically produced it, and then we later optimized it topologically. This is the model of our aggregation, so you can plug and play. These are all magnetic. This is the condensation model where we tested how much water it can collect with respect to a smooth surface versus a corrugated surface. So this is an interesting study which we didn't present yet because it didn't work out really how we wanted it to. So it's essentially acrylic balls touching each other with the laser showing us how much light passes through and how much light is lost throughout the process. Then we have the aggregation modules. This is one of our first iterations of our habitable unit, which was the original oloid, but it didn't work since it had a wider width to it, and when we simulated it, it wasn't working. These are, again, all our test prototypes that we tested in water to see if it's really working according to the simulations or not. And this is, again, another prototype that we had initially. Didn't work, so we went to that. Thank you so much.
Should I start at the surface? I'm just going to congratulate you on your presentation. Lots of the other people on the panel, I'm sure, will go in depth in your project, but it was very professionally, graphically, well presented. It was entertaining, which I think is also important. Your verbal, oral communication was very easy to follow, but also, most importantly, it shows a lot of depth in your research and an ambition in the project. And I think that your process was very methodical, clear, critical. Again, this is a very impressive array of experimentation and creative output and research. You didn't touch on those topics that Theo ended the last discussion on, which I'm sure is going to come up in discussion, but congratulations.
Super impressive. I think, look, I mean, whether you buy into the premise of the project is a different question. I think there's an underlying question, is technology the solution to everything? But once you buy into that, I have to say the rigorosity with which you developed the project is pretty impressive. And I think the sequence of models shows it, like how you went from kind of an initial kind of very fundamental principle and then step by step develop like the different parts. I quite like how all of that here is kind of connected to a very consistent story. So I think once you're in your universe of let's say alien farming underwater, I think it's quite impressive how many dimensions of this project you have explored. I also want to say something about aesthetics and beauty. I think, I mean, as Melody already pointed out, for like graphically, but as well also as how you've developed the models, but also the spaces that you kind of think of. I mean, this is kind of a modern oil rig, yeah, for people living offshore, and that they could be much more basic. But I think like not only kind of you have kind of completely kind of gone down the engineering rabbit hole with fluid simulations, but you also have then put a lot of detail into how these kind of seaborne individuals could spend their time there. So I think it's quite a fascinating utopia you've created there. Yeah, well done.
I also want to take a moment to congratulate you on a very consistent, coherent exploration of this project, particularly when we are dealing with environments that are beyond the traditional realm of architecture. In this particular case, this water world scenario. It's interesting to see what project makers, the students, the researchers, the lengths at which they go to, first of all, understand the new environment, its conditions, its difficulties, and how those become then the inspiration and the ground foundation for the research work as it evolves. And then the learning just explodes. You begin to talk about buoyancy, you begin to talk about light penetration, you begin to talk about movement, hydrodynamic power generation, all these types of things that you spoke about. And I think just the sheer engagement with all these different fields is something for which you absolutely deserve congratulations. If anything, I think this gives us an opportunity to then revisit more normative architecture and to now begin to consider what it is that we are missing in our, let's say, day-to-day practice of architecture, because not only from a formal design perspective, but also from a sustainability, ecological perspective, and the way we engage truthfully with different planet conditions to explore and invent opportunities for how to do things better. And I think that's what you've done today. I think all of you have spoken very clearly, and I want to say a big thank you and congratulations for the work you've done. Okay.
Thank you very much. I mean, despite the fact that this is the last presentation of the morning, you did really well in keeping us very engaged. A few things have been already said. I think the part that I really appreciate is how you thoroughly go through this investigation research on the different geometries to respond to the different characteristic or the different condition that you are setting up for your project. I mean, throughout your presentation, there is a very, again, thorough way of starting from something and develop it geometrically and developing with precision that comes back then in the modeling of your final product, precision that comes back into the quality of the precision, how you treat, for example, the dragon skin and how you develop that to respond to a specific input or function, you can also say. So that part of the project, I think, for me, is extremely well done. And to be fair, it is something that whatever you're going to do afterwards will be very important for you to have such an in-depth control of how to develop ideas using, quite complex geometry and still be in this complexity, in control of what you are doing.
If I can jump in. Again, thanks. I think everybody will thank you because it was a really enjoyable presentation. I particularly enjoy the thorough exploration materially, because I think these are the things that actually gives you a lot of information and insights. And you can see how the rigor that you took had led you to certain conclusions and certain kind of open questions. I wonder if this is a good moment as next steps to kind of maybe reflect on who's the hero on the project. Because we're talking about marine farming. And it was only towards the end of the presentation when we started to see those glimpses of actually nature coming into life, no pun intended, that I wonder if there's something about thinking how this can move forward, even as a process of reflection in terms of, what's happened before. Ronald Rell talks about AI in the sense of ancestral intelligence. And there's something to be learned about different techniques that can be then, kind of reflected and translated into this. So it sort of complements the thoroughness on the performative aspects and the kind of ability to try to resolve such a complex problem from a kind of material and tectonics that can actually kind of produce a wider strategy that feels even more meaningful.
An extraordinarily rich project, I think. Immediately, when you use the word stress and strain, I immediately thought about, first-year engineering. It's the world of Young's modulus. Stress divided by strain. Quite a good description, by the way, of professional life for those of you heading to the world of practicing architecture. What I think was great about it was that the designs you ended up with were absolutely explained from your initial concepts, some of which worked, some of which had to be modified. So we've got a very clear picture of why you'd arrived at what you had arrived. I think it was exemplary from that point of view. And not only was it dealing with structure, but it was dealing in a detailed way with materials and interiors in a context of a world where the number of habitable units doesn't have to be great, because you don't need a lot of farmers these days. It's not labor intensive, especially if you're doing it underwater. And I suppose my only slight regret is that there were no references to what might be done about fish, but I guess you can't have everything.
A very good transition, actually, to jump on this topic about fishing. Now, first, congratulations for the credibility you bring to such a complex topic, which is production systems underwater. First of all, yeah, all the details you have been bringing, from the materiality to the deep study about what closed-loop environment system actually is really really impressive. In terms of, I wondered, you talked a lot about the effort you put into the interior design of your system. I wonder also, because when I see the potential of all the stack of your units together, you talked about coastal protection. I also see a huge potential for creating nurseries for fish and potential growth of natural organism, since you create these cavities, these like complex systems. Which is a huge topic at the moment, is how artificial reefs will be a potential source of food production. So I see really a duality. I mean, a complement potential to the food production system you actually designed. And lastly, yeah, congrats also for all the approach about the fluidics, which is a main topic when we talked about closed-loop environment systems. Your approach about light, the way you would grow plants inside. The only maybe opening I would bring is how you open that to the symbiosis between your production system and people living in this structure. The way, it's all about gases as well. You talked a lot about the water, but the air inside, the CO2 human produce, how they could in the end benefit the plants. Because what you built is actually a system, and that goes way beyond, you talked about Nemo's Garden reference, but these are split units. You thought about autonomous units that could actually plug to a way larger system, and I think the symbiosis you could create between humans and the plant and the living systems is also a great potential of your design. Thank you.
I just want to say two things, and maybe they're kind of phrased more as questions, but you started off with the premise that there's immense pressure on the land, and therefore we should, almost by logic, move to the oceans instead, so colonize the oceans in a sense. The reason why there's immense pressure on land is actually because we grow food. Food is really resource intensive when it comes to using land. And if you, I mean, I know you've spoken to kind of vertical farmers, but there's a whole load of things you can't grow. So you'd be definitely living in a world without naan and bread, croissants, all those things. Lots of carbohydrates can't be grown. Most fruits, strawberries. It's a very dull world, living in a world in which you've also got limited room for growing food. But also then I didn't understand the light thing. We vertical farmers they don't use natural sunlight. It's crazy to do that. They use lights. We have lights. They're all around us right now. They use that because it's perfectly controlled. I don't quite understand why you spent a lot of time thinking about how you'd capture external light when you've got lights. We make them ourselves. And then the second part of that was the water. I don't know. Again, it felt like in trying to create brand new solutions to things that are actually really well done already. Desalinating water that's all around you is way more efficient than trying to collect it from the air. And the water being the ocean that you're situating yourself in. So I was very confused by some of these things. But those would be my responses.
Hi, thank you for your question. I think it was maybe because of the way I presented. For the first question, in terms of light, we are not proposing a system where there is no artificial light, but we're trying to think if we can minimize the energy that is being used for these artificial light in such a large aggregation. And if we can use even a little bit of the sunlight that is on top, if we can transmit that in some way and offset bit of the energy that would otherwise be required for the artificial light, maybe that's an interesting thing to do. So that was something that caught our attention and we wanted to explore it. In terms of the water harvesting, actually we have a ballast tank inside the farming unit, which already takes in salt water from the ocean. So the idea is to connect a simple valve in that ballast tank to have this layer of salt water that is on the floor. So the floor condition of the farming unit has salt water that is taken from the ocean, and then we slightly heat it, and the water that evaporates is the fresh water. So then we collect it on the surface of the sphere, which is in contact with the cold water of the ocean, and so it can quickly condensate. So that's sort of a semi-passive network of generating fresh water, something that we wanted to explore. I hope that answers your question.
It does answer the question. The reason why, I'm not an expert, but boats move around, so it's really hard to do those sorts of things. And there's good technologies out there that already work. So I guess my wider point would be asking people who live on boats how they do things. I don't know how much that fed into the project, but there's this kind of, it felt like there's good solutions already out there to some of the problems you're trying to resolve.
Yes, that's true.
So,
thank you.
Well, so now we have to ask you about the premise for the entire brief. I don't know if that's pointed towards Pier Andrea or towards you guys, because I think there's obviously a robust amount of work done on the material studies here, but the site is in a place of a lot of political tension. You've talked about the coastal areas. None of that was addressed in your presentation, and why. And this is an inordinate investment of material resource. Like, do these last? How do they get replaced? Like, why do we even need to invest in building this colony in the water?
It's a very, very good question, actually. And it's my fault. I am placing the brief in a very kind of particular sort of, let's say, attitude. But I think the location itself, creates a sort of subliminal friction, interesting one, because, of course, as you're mentioning, is a politically geopolitical area that somehow is full of tension and problems. And I think most of the tensions are visible on the aspect of, for instance, fishing or managing the sea and managing resources. And resources is actually a big issue nowadays. That's why scarcity, I felt that was one way, one concept to address, because resources will lead to tensions, and I think we are seeing like a lot of tensions happening right now, and they come from oil, but they come also from food production. So the idea is to use the project also as a kind of catalyzer for a reasoning or a kind of a question. How can we potentially, essentially, find more opportunities in other conditions, other areas, and extend a bit the effort. The agricultural effort is one of the efforts that I think we need to extend and we need to deal with as architects, not as engineers. And I think the idea is to challenge the status quo. So even, I agree, like there are many off-shelf solutions for many problems, but this doesn't mean that we need to proceed technologically, we need to advance. So we need to be inventive, we need to test things, we need to fail while we test it. And I think, out of 100 ideas, perhaps half of these, one of these ideas will be potentially leading to development of a new concept, a new patent, a new, let's say, a tool or a method that we could potentially use forward. So that's why I think this project, in a way, to me, it's very dear to me, like in the way the students are essentially, as you mentioned also in the comments, they work through so many aspects in a very experimental and proactive way, and they were never afraid of going to the engineering rabbit hole. And that's important, because that rabbit hole is actually an opportunity. It's full of constraints that we are not fully aware of, but still worth to explore. And even if they are not strictly architectural in the kind of traditional way, they are opportunities to discover more about laws of physics, which are at the end, are kind of shared across from sea to ground. And I think it's important to use those sort of territories to find new design opportunities. So that I think is something that I felt is quite important in this project. But also, like, it's coming from a question that was posed almost 60 years ago on the limit of growth kind of problem. Like, how can we think about the future of the planet if we cannot stop the growth and the overpopulation, and how can we feed the planet? And I think, starting from jet rotal and automated kind of agriculture, I think those kind of technological steps are part of the evolution of humanity. And I think we are now in a position that we will need to think about different ways of feeding the planet. So, of course, we're not feeding with everything. Like croissant won't come out from these farming units, of course, but I think something will, potentially. And I think that's already an opportunity to perhaps take.
Can I just drop one more thing in, which is South Korea is probably one of the, well, in about 3 generations, there won't be any South Koreans. So you said overpopulation, because they're not having children. It seems remarkable. I think 50 years ago, most people assumed that overpopulation in a Malthusian way would be the biggest problem humanity faces. In about 50 to 100 years from now, again, South Korea's population will be about 3% of what it is. So actually they have the opposite problem. They're going to have a whole country without any people in it. And it won't be therefore a country anymore, because presumably someone else will kind of move in. And same with Japan.
You're right.
Same
you're
with,
right. You're right. There is another trend coming up, but that trend comes from inequality, I think, and the way things are distributed across the planet, and the way things are managed in different ways. So I think if we look for more equality, there will be for sure a better growth, in my opinion. That's my opinion, personal opinion. But you're right. Like, some areas of the planet are actually, kind of counteracting this trend of overgrowth. But other areas are not. Go to Africa. Africa is going to grow. It's going to be twice the sites in terms of population.
I just want to get back to, I think, what Melody was, I think, trying to ask of the students is more like in this kind of tsunami of development, we start to get into, I think, a way of like tunneling through problems. And maybe one of the outputs of that is that we have a unit that somehow needs another unit and another unit to kind of collaborate. Because in some sense, the more you go into that rabbit hole, whatever, the more problems you're discovering. The question is if you kind of just continue with a kind of additive logic, because I think at this moment in time, it's not to qualify, I think, the work that's on the table. I think there's a lot of research, there's a lot of vitality, there's a lot of skill. There does need to be some self-reflection. There does need to be a kind of critical awareness. You had a specific question. You guys have thought about a lot of these things, but sometimes it gets lost in, I think, the fact that I think it's very important to look at where you can critically intervene to these very complex problems. Not everything on the table is equal, and not everything on the table is as meaningful in the process that you were developing to the application, to the conversation. And I think it's just an interesting moment for you guys to take stock of stuff. I think, for example, you talked about light, and the artificial light was a discussion point. You're in a very kind of ecologically diverse area. You're very sensitive to the human ecology that's there. But if you created these kind of artificially illuminated elements in the water at the density that you have, you would challenge, and I use that word to say it nicely, the existing ecology that's there. So even in a sense where you're trying to better serve one, there is this delicate balance which I think necessitates you guys to be open to that kind of complexity and to always actually be the ones that are bringing doubt into this kind of technological parade moving forward. Because I think that we can't be that certain that we have a solution, but we can find better ways of identifying problems. It is an interesting thing for me personally, the living on the sea is, I don't think where the project from my side actually has value. I think the farming infrastructure and just trying to find different ways to automate in very different conditions makes this really a prototype for different things. And you've gotten, I think, comments from Jim and Paul and others, that Melody, that are maybe suggestions that the same kind of systems that you're looking at may be applicable in a prototypical way for different challenges. If you can identify that more on first principles, then you give your research the opportunity to actually really be tested against very different kinds of needs without necessarily having to absorb the whole research as a package and evaluate it as thumbs up, thumbs down, like in some kind of Roman Colosseum strategy. This is about really trying to open up the complexity of things. And part of that, if I can be very honest, is not to fall into the trap of like discursive rhetoric of things. Everything is unapologetically trying to do something positive, but good people do bad things. And that's also like a kind of an awareness that we just need to be able to kind of look at the work, especially in this moment in time, I think in a way that we can both celebrate it, be self-critical of it, see what the next steps are, because I would be much more interested to understand, you know, what's next week look like after you submit your book? If you go down this kind of experience, do you try to find an alternative to practice? Do you try to become more entrepreneurial? You celebrated Jim and his things. You have him here. You could speak to him about how he decided to move into that space. And I'm just saying that because I think that that's part of these kind of conversations, is also trying to actually not allow this work just to sit at a table that gets presented and sit on a shelf, but it needs as much creativity, if not more creativity, to try to find where you can actually navigate this world and how you can really actively contribute to it. Because otherwise it's going to be discredited as another utopian idea, which like the history of radical architecture always falls into, and then there's always the pros and cons to all of that stuff, but then at the end of the day, things go on in the world without any friction or only friction. So I think like you guys should be celebrated for, I think, a lot of the work that you've done. I think you can curate it better so that the conversation, I think, is a little bit more engaged too. I think the points of contact where I think you have made a meaningful contribution. And I think with that, I'm not sure if we have croissants, but we have Melody's concluding comment.
I can't top Theo's comment just now, but I just want to add, I mean, looking at this, like the thing that stands out to me about your unit is that you talked about the human vulnerability. And this is very scaled to one human. I don't, like where do people come together collectively to support each other? Like I'm not sure that I want to be that person surrounded by this protective pod with a number of pods of farms. So it's just something to always be aware of. You also have to zoom out a bit when you're looking at this as an architect.
Sorry,
go
just one line. But having said all that, what's great about this project is that when you get architecture and engineering like this, there's a sort of temptation that the architect tries to become an engineer. Now, engineering ideology in relation to water is essentially to resist it or to control it. Dams, flood defences, you name it, the engineering attitude is fair weather, foul weather, as though we're in conflict with nature, which is like a mother nature, a human being that has moods. It's not, it doesn't, and it's not intelligent either. By contrast, what you've done, which I think is a far more architectural approach to water, instead of resisting it, you embraced it. Congratulations.
Okay, everybody, thank you for joining us again. Everybody should find a seat. And we're going to hand it over for the first of 3 teams in the afternoon session. Okay, thank you so much, guys. All to you.
Good afternoon, everyone. We are presenting AI for New Cities, a research thesis developed within Studio Bhushan. Our team consisting of Palash, Raj, Shyam, and Tarakesh. Our point of departure is the year 2050, where inevitable global urban expansion necessitates a radical shift in design. We treat cities as high-velocity engines of prosperity and employment, moving architectural agency upstream to design the socio-economic rules that balances private growth with the common good. Drawing from historical models of integrated architecture and urbanism, such as Chicago, and DRL research on relational and adaptive urban systems, the studio positions AI not as a representational tool, but as a framework for reasoning, negotiating, and stabilizing architectural and urban decisions. Urban form emerges as equilibrium, not as master plans. In the previous DRL's research by Team Meta London, urban order emerges via 2 players driven through reward and cost design. With the help of AI, we can reduce this cost of experimentation to find the best possible outcome that maintains an urban equilibrium. AI to us means of rethinking how architectural and urban decisions are structured, negotiated, and stabilized. Our methodology is driven by 2 AI frameworks, Game AI and Shape AI. Game AI employs win-win equilibria between institutional stewardship and economic growth. Shape AI is used to derive a variegated morphology through a procedural field generation. Further, the building morphologies are decomposed into a system of building components. We begin by analyzing Chicago as a historical model of integrated architecture and urbanism. To drive the prosperity and economy, we look at technology startups as an urban catalyst. Silicon Valley achieved this by fostering a collaborative culture with a campus-driven environment. However, it lacks the planned density, spatial interactivity, and walkability, unlike Chicago. Chicago is an example for its bold, visionary design, having a monumental center, civic plazas, and lakefront. Our philosophy is guided by Daniel Burnham's 1917 injection to make no little plans. We aim for a visionary urbanism that uses technology as an economic catalyst while maintaining architectural grandeur. With a GDP of over $725 billion and a human development index of 0.9, it represents a successful realization of urbanization for the common good. Our analysis of the urban grid highlights a downtown density of 26,000 people per square mile. We look at how standard 100 by 100 meter blocks facilitate standard building templates that can be scaled effectively. We identify these templates as mixed-use commercial towers and courtyard residential models. Historical districts like Lakeview, Rogers Park, and Kenwood demonstrate how these local wonders provide shared civic grandeur within a dense framework. We contrast the expressive street walls of Chicago with the vast interior urbanism found in modern California office campuses. While efficient, these modern models often lack the spatial interactivity and walkable course our research seeks to restore. Our goal is to design a geometrically ordered urban vision like Chicago that has a strict urban order and varied density as we move away from the Lake of Michigan.
We transitioned to the Oxford-Cambridge Arc, a development corridor designed to link academic and business assets. We analyzed this intersection of innovation as a testing ground for the UK's version of Silicon Valley. Our focus within this arc is Milton Keynes, which currently support a population of about 300,000. Despite its size, we note a relative low density of 27 to 30 dwellings per hectare. We look back at the 1970 vision of Helmut Jakob, which emphasized a rigid grid system and pedestrian market. While orderly, it established a low-density, car-centric precedent that we aim to challenge. We find that current infrastructure defined by roundabout and uninterrupted roadway has created a level distinction that separates the pedestrian by the city that has led to a fragmented urban experience. We documented a significant loss of activity along major road and local plaza. Our research identifies a lack of planned density and spatial interactivity as a primary cause of this urban stagnation. However, the economic engine exists. Milton Keynes has been a thriving startup ecosystem in robotic, creative tech, and data. Our goal is to provide this industry with more collaborative and open plan urban morphology. Drawing from Patrick Schumacher's parametric urbanism and Theo's adaptive ecologies. We search for a variegated urban order while being an adaptive city framework that are shaped by bottom-up rules from the district scale to the building scale. We move away from the top-down monotonous master planning towards AI-assisted decision-making. This allows us to use urban growth simulation to test decisions iteratively rather than relying on a fixed plan. Inspired by John Nash, game theoretic urban simulation allow us to treat urban design as a negotiation between stakeholders. By replacing procedural rigidity with parametric field, we groundscape our urbanism with complex spatial features. This approach allows us to integrate freedom and order into a singular framework. In phase 1, we explored and analyzed land use simulation and urban shape grammar through computational tools. We did reinforcement learning based on the basis of adjacency metrics rules that allowed us to create polycenters. We also examined various types of road grid and combined them to generate a unified road network. Similarly, we are taking this adjacency rule and integrating it into the urban game. Previously, we analyzed the adaptation of typologies to parcel condition, a study we subsequently advanced using parametric fields.
Game. The history of game is, with respect to the John Newman introduced game theory in 1928, later formalized by Oscar Morgenstern. The min-max theory describes rational decision making in two-player zero-sum games, where players maximize their guaranteed outcome by minimizing the worst case loss. The principle and laid the foundation of Nash equilibrium in 1950 and later develops in AI decision making and reinforcement learning. Nash equilibrium operates at the local agent level yet produces global system stability. This is our site in Milton Keyes, wherein we have a railway station nearby, and there's a M1 corridor on the right hand side which goes from London to Birmingham, and there's a proposed highway which flows from west to east from Oxford to Cambridge. There are existing typologies in Milton Keyes like retail and office, residence, warehouses, and public. The game has two players, the urban developer and the economic developer. The urban developer envisions Chicago's logic of grand green structures and civic well-being. The economic developer envisions Silicon Valley logic of innovation, clustering, and economic acceleration. Their interaction mirrors real urban tension between spatial quality and economic intensity. These are the actions for the players. Cost and revenue are the reciprocal. Player 1 buys material from player 2, while the player 2 buys land from the player 1. Each action benefits one player while costing the other, forming a zero-sum exchange that reflects one human's min-max logic. The placements are being done on the basis of the adjacency matrix, wherein it defines the neighboring awareness limiting decisions to local spatial relationship. Each move responds only to a nearby condition representative at agent level decision making without long-term foresight. So this is the game UI, wherein we have left hand side the urban developer, right hand side we have the economic developer and the land value map and the adjacency score. This is our game 1, wherein both the players are playing simultaneously. By the outcome of this, we are able to know that both of the players are going in negative. These negative funds are being developed by adjacency matrix because it's just random in the start. Without strategic or learning involved in the game, it failed to converge the resulting in unstable outcomes rather than the Nash equilibrium. That is why we need to resolve this using latent space, which acts as a shared optimization landscape under min-max constraints. Local Nash equilibrium merges reduce the loss to each turn while producing global stable yet path-dependent urban forms. Player 1 prefers proximity to the transit station, supporting affordability and fresh talent. Player 2 refers highway access for economy. Their overlap around the lake generates a central well-being and innovation hub. Latent space guides adjacency using quantitative rules, future land value, living quality, green connectivity, and opportunity cost. Local decision becomes informed rather than random. This provides varied neighboring condition for our city. We added a latent space in the UI for our game. This is our game which runs along with the latent space. We can see that still there is a large area towards the right hand side of the site which is underutilized. This is our game 2, wherein we are trying to portray different start points for the players. On the left hand side of this game, the innovation hub is becoming a bit more dull. Game AI. The cities are irreversible. We need informed decisions for the future growth. Latent space optimize short-term gains locally, but Q-learning projects long-term value. Trained on the past outcomes using latent space, the AI learns policies that favor future urban intelligence, achieving Chicago scale coherence with Silicon Valley economic powerhouse. By combining John Newman's min-max logic and Nash equilibrium with the latent space and Q-learning, where talent space acts as a body, latent space acts as a body, and Q-learning acts as a brain, the system translates the local competition into global order. This generated the maximum adjacency score as well as the economy for both of the players. Chicago's green structure and Silicon Valley's economic intensity co-evolve, demonstrating how AI-driven game theory can generate resilient, adaptive, and intelligent urbanism.
Shape AI. For Shape AI, we traced our step back to the very root of artificial intelligence, the multi-layer perceptron. We looked to Jeffrey Hinton, whose work turned this basic neural network from a mere idea into a functional model, effectively shaping the entire landscape of modern deep learning. Our MLP breaks down into 3 stages. It begins with the input layer that accepts floor plan as the data. This information is passed to the hidden layer, which uses wet and nonlinear activation to identify abstract feature before finally reaching the output layer to produce the predictions. Once the drafter plan is given as an input, the model is then optimized to minimize the discrepancy between the original input and the reconstructed output, ensuring high fidelity data recovery. Consequently, this generated an output compromising the blend between shapes formed between the input floors. The main goal of the latent map is to accurately construct SDF curves, preserving spatial distance as every sampled point. On the right-hand side, the image illustrates the integration of the input plan and the blending between the floors via latent space. This is our few examples how they are working with various plans and being integrated into one structure. Instead of going by hindsight to fit the shape to the latent space, we wanted to form find through a rule-based approach.
To achieve this, we use parametric fields, a method to generate fluid interconnected groundscape typology that prioritizes continuity over vertical separation. To achieve fluidity, we moved away from static mesh modeling. Instead, we utilized sign distance field. This allows us to treat architecture not as just fixed boundaries, but as gradients of intensity. We calculate a distance from center point to an edge, defining positive mass and negative voids. This mathematical representation is what allows the form to blend rather than collide. Scaling, voiding, and movement, these basic functions define how the blending is going to work. We begin with function as the seed for form. We categorize the program into work, visit, and live. These are spatial drivers. The drivers are, here is spatial expressions rather than the form itself. This is an example of single building massing from atrium, entasis, crown as expression over the massing rather than just shapes. Now we are looking at how a massing will be transformed within a single parcel. The base shape changes as the attractor and the expressions are being built over top. The SDF blend adjusts for different functions with varying base shape. Proceeding further, instead of just blending one building, we wanted to blend multiple buildings and connect them. Building to building morph is influenced by density, porosity, and vector. These parameters ensure cohesive but varied urban fabric. For this, we have multiple rules. Local attractor influences neighboring buildings. Building nearest the attractor may scale up while others remain subservient to the bounding box. Here, height and size variation rule is applied based on response to site logic. The buildings near the attractor will scale up vertically as well as horizontally, while the one further away will be smaller. Attractor influences nearest buildings to have large openings, while distant buildings remain denser to maintain private edge. Depending upon the position of local attractor, the openings, the size, height varies here. The overall parcel is influenced by that point. The carve-out spaces for plazas, parks, and water bodies within the bounds. Buildings are assigned as an adjacency logic here. The shorter building will carve out the taller ones. Connections are made through terracing. As buildings merge, they create these carvings, which these terracings merge and they step platforms. They create vertical density into a series of interactive outdoor social spaces. The size of the land parcel dictates the number of building points generated. The grammar then populates these points within the responsive massings. The grammar is applied to the master plan derived from the game AI. This results in continuous fluid airborne form that evolves across the entire site. This is how buildings are populated within the parcel. The point is distributed. And based on these parameters, this is how it is done. As a height and density increases, the features evolve from simple void to complex connected floor plates and wedges, creating a variegated order here. Yet we had to gain more control over the floor plates and voids, so we tweaked our rules further. However, the problem with this approach is the lack of control over massing, creating unusable spaces. We found one of the reasons is positioning of the buildings. So a better way of distributing buildings across the parcel was explored. The points are referred here as building centroids. Based on the area, the number of buildings within the boundary will be determined. The points find equidistant from the centroids to boundary for equal distribution between them. This rule is applied to parcel to see how the massing is getting affected by this. As a last step to attain maximum control, the threshold based on features is being added. As per the density, the spatial feature will be added here. Buildings scale from 16 meters to 120 meters as a template. As a height and density increases, the feature evolved from simple voids to complex connected floor plates and wedges. Standardizing typologies and gaining better control over morphology, like how we have seen from Chicago's building template. By refining the rules, we arrived to final iteration. The urban morphology isn't final here. It is the evolution based on locally defined rules. Next, we will move on to see how these massings will be post-processed for plans and building system to make it into a reality.
Procedural buildings. This research presents a building system where spatial program and building parts such as structure, facade, and roofing systems are co-generated through geometrical methods. By processing these sign distance fields, we extract a unified system where the floor plan boundary directly informs the structural grid and the facade. Our spatial subdivision strategy uses a topological dual approach. We start with the floor plate boundary and subdivide the volume based on programmatic density. The common spaces take up the large span structure at the front end, and the smaller spaces such as the office areas go to the rear end. Our spatial requirements cater to 3 standard sizes of office spaces, varying from startup pods to small offices and large office spaces. The supporting functional spaces, such as the conference hall, display zone, and cafe, are situated every 3 floors. At the 150 square meter scale, the geometry accommodates 15 people. The layout integrates a desk zone with the pod with screens for digital collaboration. The 300 square meter cluster scales the program to 30 people. It introduces a presentation wall and a central focus pod utilizing the polyhedral geometry to create distinct zones without the need for traditional interior walls. Privacy is managed vertically through level distinction. Meeting areas are placed on the lower, more accessible planes, while quiet work areas are elevated on mezzanine-like tiers found within the spaces. This view shows the startup cluster. The structure is a timber colonnade enclosed by a facade shell. Technically, we employed 3D graphic statics to maintain structural equilibrium. Here, space is treated as a polyhedral form diagram, where the geometry of the void determines the path of the internal forces. Each spatial cell is presented by a closed 3D polyhedron. The areas of the polyhedron's faces are proportional to the magnitudes of the internal forces, ensuring that forces structure. This allows us to design global large span structures that are inherently in compression or tension. Once we derive the equivalent polyhedron for desired subdivision, our form-finding process concludes with the superstructure. By optimizing the force diagram, we derive a crown that manages the transition between the office towers and the open sky. The central skylight is the heart of the structure. It is a reciprocal frame system where each timber element supports the next distributing loads through the envelope to the ground. These timber colonnades define the terrace voids. This is where the building offers a large outdoor access and view through the facade. The final system is an assembly of these layers: the podium shell, the mega roof, and the structural grid. The same system is being applied onto a cluster of buildings as well. One of the constraints of this approach was to find an approximation of the building massing that we had studied previously on the urban shape grammar study. So we decided to use this approach to create the building feature sets, such as the skylights, the mega roofs, the podium shells, and the courtyards. We applied the system to an incubator building designed for a high-density startup ecosystem. The program is stratified. Retail and public access occupy the ground, while anchor offices provide stability for the flexible startup and collaboration zones above. In order to subdivide complex flow shapes, we used a procedural subdivision of flow plate method, wherein we get the contours, and using the medial axis, we can subdivide the rooms further as per the size hierarchy needed. And based on the core placement logics, we can derive the program layout for the whole flow plate structure. At the urban scale, the mega roof shelters a street-level plaza. This creates a large-span sheltered public space that facilitates public access from the ground below, effectively inviting the city into the incubator. This is the view of the mega roof above the public plaza. This is the pedestrian transition to the tower. Moving into the heart of the building, we resolve the atrium through a roof shell that acts as a structural diaphragm. The atrium structure is designed using polyhedral force diagrams. The views show the roof shell through the cutout from the street level between the buildings. To achieve the large span flow slab, we utilize a node network derived directly from the force from plan. By subdividing polyhedrons, we create a rigid structural skeleton that allows for column-free work environments on the inside, specifically where buildings intersect at the street level to create wide open public thoroughfares. This plaza acts as the primary urban placeholder for our district. The facade reflects the internal structural logic through facade differentiation. We utilize a smooth exterior for the primary office volumes, contrasted with carved voids that reveal the internal structural ribs and provide shaded balconies. Technically, the carved void is a force-informed void. We analyze the vertex edge and vertex face relationships within the 3DGS polyhedra to determine where material can be removed without compromising structural integrity. The logic extends to the cantilevered balcony system where the exterior and interior cavities merge. These cantilevered balconies provide essential breakout spaces for startup clusters. In the carved interiors, we can see the system logic as a habitable space. The structural ribs become partitions and host the floor plates.
This is the overall catalog of our building system. Like Chicago's buildings template, we used this within our city for fast production and bring order to it, from which we have taken our best result from our game. Chicago, like urbanism, a startup system and anchor offices were powerhouse for the city that brings equilibrium between both the players. We started to implement our building system to this district. The result is a well-articulated functional distinction between typologies with large openings. This is the view of a district, from which the sectional view shows the multi-heights, atrias. Atrias, interconnected building with voids that we set out to do in the start during the massing process. Coming to the conclusion, our studies culminate in the generation of 140,000 jobs through a new urban morphology by reconciling Chicago's metropolitan scale with cluster logic of the valley. We have moved beyond isolated campus into an integrated architecture and urbanism.
This is our structure model derived from the shape. This is our atrium model from the polyhedra study that we did. Our very initial urban that we created in our term 1 to study the vectors that are in the site. Moving to the final site derived via game AI that has a very variegated order and a flow, and the template like a Chicago where we have opening near the water bodies, the parcels open up and creating order from Voronoi to a square. Our initial model where we studied how the shapes can be blend together, how they can be morphed together. This is a podium model for the elliptical. So this particular parts extends out to connect to the outer building, creating connections. Our cluster building, this is our version 1, version 2, and version 3. Creating a more control as we go from first version to the last one. This is our structural model where created via the 3D-GS. The main column that will be between the carvings. This is the rationalized version of it. The flooring template over here that is done via the floor study that we did from timber. This is a manual study to learn the bending of the wood and its fibers. The scoop study that we did over here, like the very first model for our facade system over here, like creating balconies, the indoor space over here, and the fabrication of the column and the structure that we derive out of it. Thank you.
Thank you. I can start. I have one. Thank you very much. I think yesterday at the end of the day we were saying that it's a bit unfair because you're almost doing 3 projects in one. There's so much work, and each of those chapters that you have in your deck are, standalone projects. So first of all, congratulations for just the amount of work that you have done. I still want to emphasize that I think it's amazing that you start from first principles and you really go at the beginning to investigate the underlying technology and try to, really own it in that sense. The 2 comments I have are, one, this approach of working really requires us, the designing is obviously, you making decisions about the restrictions and the choices that you make, which tools to use in which way, right? And I think that's a really interesting paradigm shift where design becomes very much the mental effort of understanding and shaping the tool set. And I think it's not to be underestimated that it's not planning in the traditional sense, obviously, but the gravity or the impact that you have by choosing this restriction or parameter over that one, right, is an extremely important part of the process now. And so in the future, or in the future iteration of this project, I think it would be nice to dedicate a little section which just helps us understand your logic of why you chose this over that, just for us to follow this logic. But all in all, I think it's really very impressive, and it's really highlighting a future direction of travel, and it's exciting to see how far you got. So thank you very much.
It must be the future of work, and what limits us is nobody else can do that, right? So it's absolutely compelling to work like this. Not only is it incredibly productive, so that you can, once you set up the system, you can generate 140,000, whatever, a new workplace, or 500 and 600,000. Of course, then you would have variations and adaptations and so on. It's absolutely compelling. For me, the first time, I mean, we've seen it coming, and I've seen it several iterations. It's pretty compelling here how this kind of goes through. Of course, there are issues and problems and questions on each of these, and these decisions are questionable, but the way this rolls through here is absolutely powerful. And the other thing is, this is not only a promise of productivity, it's a promise of rationality. Because once the system queries have been followed through and you've iterated a few times, then these are kind of defensible, tested decisions, which you then can trust at least on a certain range of application. And that is extremely powerful. It makes really the process of design, brings out of the inevitable and what you thought about it when you confronted building number 5, something new came up, and then, but you don't go back to the previous 5 buildings anymore. I mean, this is real, true, deep rationality and deep productivity, and it's absolutely spectacular, and also running it to the visualization and so on. Some absolutely stunning achievement, and of course, once I've said that later, I'll come back. I mean, there's a few things, just what it's saying. Wonderful, I love these polycentric, interbleeding grid points, and I don't know why isn't it there anymore, and be the playing field had that shape, and how this all, and if there's even that remains a bit fluid when depending on how this fits in. I think the density of the gameplay, I mean, they're too far apart probably, but I love these morphology studies. I love. I mean, this is very productive as well. Of course, there's a question of what is regulating the attractor points. But to see that happening, that complex pyrarithmic model be handled by, I don't know how the 3 dots are driven, or they're driving each other through something. I mean, this is a wonderful start. I think the final visualizations are fantastic. The gaming logic, I have lots of questions, but that you're doing this is also very, very incredible. There's something about this kidney shape, water body, and the grid, and so on, and why you didn't take some of these things. But wow, that's the future, and it's really, if that doesn't generalize, it's because of incompetency of the rest of us.
I mean, just for everyone else who just joined, I think the way to look at this is really day one, right? And so the exploring the game, obviously there's only 2 players, there's only a limited amount of parameters, but you can start to imagine what would happen if we would add the real complexity of our real world into those simulations, right? This is really just trying to explain a process.
It's just a dry run of
exactly
the ingredients.
And I think that's how we should critique it also.
In the workflow design, system design.
Yeah.
I didn't want to mute the rest of you guys.
Thank you very much for your presentation. It is indeed a quite challenging a project for us to give you some feedbacks, but I'm going to try my best. Reason being that while I appreciate that there is an immense amount of work, first of all, for you to understand how those engines are working, And as Patrick was saying, there is quite a lot of work that you are showing us also in the final visualization. It's challenging for us to maybe fully understand it because some of the critical setting up of your own rules of the game weren't that clear or weren't really explained to us. I'll give you an example. There are at one point one of the drivers for your own game to actually function is about wellness or productivity. Those are big words that I'm wondering whether there is for you a definition that might be quite different from the definition that somebody else will have in this room. So there is a part in your presentation right at the beginning where when you are setting up the key elements for your two players to play with, it is rather difficult for us to fully grasp how one reiteration that maybe is the developer versus somebody else really are changing the actual outcome of some of those initial setting up. There is also maybe another aspect that that makes your project to a certain extent still quite abstract, that a lot of the consideration when assigning, in this game, the different plot and density and so on, there is a lack of consideration of basic things like one shading another, the orientation of the plot, of one plot versus another, where to have a higher density versus a lower density. So these are the things that I think you might want to go back after you finish your book and rethink where are the critical, which are the critical steps and what have you learned by playing the game with a certain amount of information up present, no?
No, it's just clear. Of course, it's just it's a dream of a project. Once you poke your finger and it has 1,000 falling apart, but the dream is extremely important.
Well, I agree, and it's really one of the most powerful presentations I've seen this year. And I'm sure everyone will be fully complimentary. So just to challenge you guys a bit more, I was wondering, having all these tools in hand and being so good at it, at the use of it, how actually do we introduce some kind of personality? Because I'm a urban planner, and to me cities are more about streets, journeys, different places, different materials. They don't necessarily need to be fluid. I would argue that if everything is fluid, people get lost. There's no way to orientate yourself. And actually, I can't think of any city which was just created with one press of the button. It takes time to get it right. And sometimes, as the master planner, you almost don't want to do it all, because it's better if you divide the roles, if you give, each building or even one unit in the building to different developer, and they create the variety. So to me, in all your attempts, which are great, it's missing. And my question is, how do we use the tools to actually create this fake variety? You don't need to answer.
And maybe quickly adding to that. First of all, I think the brief and the project is really fantastic. Congratulations as well. I really like this provocation of looking at Milton Keynes, looking at Chicago, looking at Silicon Valley. I think that's a really relevant project for the UK, and I can only applaud that and support this. What I find really provocative and kind of I'm sitting here kind of trying to wrap my own head around it. It's like your project has no problem, right? Like in the beginning, you set up somehow one problem. There's Silicon Valley, there's Chicago, right? Two cities that come from very different paradigms. And then I was hoping, okay, we're going to get like a provocation and a problem, right? I'm going to be involved in this story of a protagonist that's going to fight this thesis against, the enemy, right? And I didn't know even was Milton Keynes the enemy. Probably it is, like who likes Milton Keynes, right? Although it's very successful. So maybe Milton Keynes was the enemy, but you didn't really say like exactly why it was the enemy. And like, I just kind of missed a little bit really articulating that problem. But then I started thinking this is such a kind of boring comment to make, right? Because maybe one of the consequences of actually that whole system that you've set up and all this amount of work is that there is no more struggle and no more problem. And then I was like, what do we do now? Like in this kind of world, if we have no more problems, right? Like architects love having this kind of a little bit of like existential angst and a little bit of, you know, problems that we're grappling with and we can debate. And really like the whole way how you presented all the research didn't show any struggle. So it's a kind of a struggle-less project. And that for me is kind of interesting to think about, right? And to take that away. And to maybe the takeaway is like, what is, for you guys as well, is to think about what would be, you know, the problems, or should we just be like, our attitude should change, and we should just be like, actually, there's no problem, right? So, first time I saw a struggle-less project.
Well, I think it's such a formidable piece of analysis. I love the word procedural. It's like, you know, crime procedural, except in this case there is no crime. I think as an observation, the problem about creating master plans and the procedures that you've used and the things you've chosen to be your points which generate your polycentric things is that the outcome almost inevitably becomes architecturally and aesthetically, I think the word will be relentless. If you like one of those buildings, you probably like several, but do you want them all to be like that? I don't think so. And I think I was thinking actually about Zaha's museum in Rome and how successful it is, because it's a building of kind of which both fits in and provokes. And one of the reasons it's so successful is it actually conforms to historic, not historicist, curves in the urban grid of the city. And the contrast is what makes it powerful. And I think when you get a series of things, I would say even these interiors, you know, it's just one after another. What can you do with it? Even if you were given one of those interiors to transform, how the hell could you do it? And your rules would probably prevent it anyway. But that actually isn't the way how cities develop, and it's not really the way how series of buildings or their occupiers want it to be, because they want to add their own distinction and change. So I would say that's the challenge that you've set up. Does this work? If you say, actually, for half of those buildings, we'll write a rule which says, ignore our rules. And that whole business about writing rules, especially in the Middle East and the Gulf, where you start off saying, well, you've got to do certain things about shading and this and that. And all of a sudden, the question is, does that mean you've got relentless streets, or does it mean that your restrictions are enabling, that they're constructive rather than prescriptive?
I think it's the second, but I mean, you have to think about it more like a tool that can be used in many different ways, right? And so, in reality, you know, this is just another tool which facilitates different processes, and depending on the input, the parameters, the ambitions, the underlying intent, you can produce many different shapes or forms, right? This is just one example, and I do agree it's a bit unfortunate that it all looks, you know, a bit too much, but it's not, that's not
no,
the
but
point,
I don't
right?
think it is. I mean, actually where it works and what's the problem actually to generate the knowledge economy city of the 21st century, and where we have this degree of variety in systems and subsystems and transformational theories, but also different ontologies, and they resonate with each other, they feed off each other parametrically through these methodologies, and that's that's the problem, is to develop this. And then the question is, for instance, from you, is it too monotonous, is it too uniform, too self-similar? I don't think so, to the extent when you look at the scale of the district. For me, it's quite compelling and convincing. It is at that right tipping point between, you know, it balances that diversity and unity and difference, unity across difference and differentiation of something which still has an identity and unified sense of principles. and that's something we've been trying to home in on quite a while, and you've done quite well on this. I mean, I think in terms of the grid is not doing that, but in a subset like this, I wouldn't challenge you that this is monotonous and things. That's quite, because if you allow the disruptions and give every a chance to disrupt, then it collapses back to what I call garbage spill, or something kind of disaggregated and indigestible, and where you have no prediction potential and anticipation potential and learning of some kind of systems logic. That's really the garbage spill versus the ecological kind of valley with 100 species coordinating and feeding off each other.
But then but Patrick, I agree with you. It looks beautiful, but you look at it as at one building, whereas in fact it's a live city. It's a selection of buildings, and all these systems they are brilliant for single buildings. I think I question whether any of us is skilled enough to just master plan the whole city on their own. You know. I work with master planners, and what is fantastic is to actually engage with others who will focus on on one element of what you do, and they will do it better, because all the time you are spending, designing other areas, they will spend designing one unit or one building, and altogether it will be more rich.
Yes.
That's all I'm saying.
But only if all the authors have that facility, the tools, the ethos of generating difference, which isn't just the breaking the continuities which have been there, and it's just collapse. Yes, of course, it should be multi-author ultimately, but multi-parallelism, tectonism author.
But on the one hand, it's being said it could be like this, and on the other hand, said it's got to be like this. I think this is a very thin line, and it raises some big questions about what if somebody wants to do something different, and that's the problem for all master planners, because they're not God. And they usually don't own the site, and they certainly won't own it over time, and other changes will take place, political, social, and economic, which will then question the basis on which that plan was made in the first place. Look at Chicago.
No, but do you want to be the elephant in the porcelain shop, or you want to be a kind of contributor to a synergy process?
Luckily, I'm not a designer.
Like the provocation, I think, when we think about the problem, right? It's like ultimately the problem here is like there's nothing problematic with what you did, right? You've eradicated the problem. The real problem is that almost when we look at these images, we find it, I find it personally like almost impossible to imagine that a Western economy would ever build this, right? Because this would be built not by a single entity, it would be built by hundreds of thousands of different, not hundreds of thousands, but like a few hundred developers who all have their own, market forces that they have to deal with, and you need to kind of synchronize them and bring them together.
But we don't have a sophisticated architectural culture at this point. We're totally fragmented.
But
we have extreme backwardness, self-indulgence, ignorance, and some sophistication, but a very thin sliver.
Yeah. I'm thinking about the client side, right? Not even about the architect.
The clients have nothing to. The client come with program, but the solutions are colleagues, which need to be clued in and tooled up.
I think just to I think the conversation is great, it's credit to the students that they have not sandpapered some of the issues that Patrick has pointed out. Like if you poke a finger in, you will find mistakes, and I think that's very good. And it suggests the potential, as Jan and others have kind of latched onto, how we can deal with complex briefs and complex urban problems and architectural problems that we all face. And new cities is the kind of enemy, as in Gilles's world. We need about 250 of these cities globally in the next 25 years if you have to support the urbanization that is expected. And so this is a kind of attempt at a systems thinking of what are the ingredients that we might have to put together from rapid construction. And obviously, we can critique it and say it's monotonous, or it's all the same, or it is diverse, or it can be more articulated and so on. But the attempt here in this first year of the studio was to look at what is a challenge that is worthy of AI in a way, right? like, can we throw a sufficiently complex problem and then at the same time investigate in depth, like what are the algorithms that drive AI, like what is, like not just the text to image and text to code, like these kind of ChatGPT interfaces, which already show a lot of benefits, but how we can intervene and look for architectural and urban design agency within a transformational technology like AI, like, and so in that sense, again, I agree with Patrick and Jan that like I commend the students that like they stuck through it. They really tried to make everything procedural and highlight the possibility of dealing with complex problems like in a kind of systems way. And again, that's why like some of the aesthetics is also like in a bit crude, and others can like bring in refinements or like complete other, like another form of manufacturing and so on. Like, and this is where I think like the Chicago reference was not fully brought through, because Chicago managed to grow in 50 years rapidly because they had like these different templates, building templates for towers, building templates for civic buildings, building templates for residential buildings, and so on. And which is actually many different developers were able to kind of use these templates and modify it for their plots. And that's allowed Chicago to grow rapidly in 50 years, and rapidly as a multi-sector economy, not just a uni-sector economy like some of the other cities and in the US. Yeah.
I just want to thank you for the presentation. It's really interesting to see how you got from concept to completion and to show the audience what kind of tools are available these days. Of course, as we were saying, things can be further developed. We have to see if more than two players play, what is going to happen, who will get the final decision, who will be able to decide what the city ultimately would look like. But it's really interesting to see that the tools are available. And it's exciting to hear from you what will be possible going forward. Milton Keynes definitely could be improved, so let's hope that might happen one day.
Yeah, personally, I really enjoyed your presentation. I think you are very brave enough to rationalize your design process by dividing urban developer and economic developer. I think these two big bunch is not really the final the stuff we actually can design, but somehow I think for me it's kind of great metaphor. I think you can develop further, and especially when you are in real world, you probably need to speak to the couple of people, not only designer like governance and government and users and all different people. And then certainly I think I start to think about, architect is always out of the game when we design the master plan. We are always come to the competition to design a single building. But now I think you are sort of challenging kind of new sort of era where you can actually introduce kind of new way of master plan. I think for me, beginning of presentation, I thought it kind of bit dangerous actually because you're rationalizing too much actually. Then you are kind of just ignoring all the human factors and the kind of emotional factors. For me, which is it's quite important. But in the end, I realized that we actually create kind of successfully a format to control the entire master plan. And finally, I think you have got kind of, but it's not final complete set, but somehow you have a great set to develop further after you finish this job. So thanks very much.
I just want to say thank you very much for the presentation. It was very inspiring. I have to say that it was impressive how you take the challenge, as Jan was saying, to do two projects at once. So you came from a very different scale all to the directed to the building scale. It was very impressive, and also to try to give through gaming and AI, try to give form to almost like this game intention in between the urban development and the economic development. I think it was very entertaining, but I think the most successful part, one of the most successful part, I have to say, are the close-up models. I enjoyed it very much, especially there's the sculptural elements and inhabitable space that you've been able to produce, that actually makes also total sense in that type of office environment through collaboration, but it depart from the classic office box that we're used to, right? So I really enjoy that. Congratulations.
Just very quickly, but one element that is really, really strong that you explained at one point in your presentation is how you work with different way of bullying out the geometries. And I was just re-looking at some of those reiteration here. There is a real richness in the way you organize those voids versus terraces versus inner spaces. So that for sure is in itself a project to just go through the different kind of typology that you created by just a very simple, rule of bullying out geometries. Well done.
You want to endorse?
No, I think I've a little bit.
Is Theo over here?
Oh, okay.
Oh, okay.
Shall we move? Shall we close and move on? Great stuff, guys. Thank you. After this, we have yet another 2, so we need to keep these resting moments a little bit shorter. Thank you.
这字儿可以吧？可以。我给你拉上去。
看那边。
提前抬头。我给你
Okay, let's continue with the project. Thank you.
Good afternoon, everyone. We are team The Emergence from Remarkable Studio. My name is Boan.
My name is Deng Jiajia.
My name is Ni Ziqian.
My name is Jin Ziyi. So our project proposes a 500 by 500 by 400 meter three-dimensional urban district in Utopian, London, and its function density is equivalent to an entire urban fragment, and such as the City of London and Canary Wharf, but compressed into a single coherent architecture system. Here, bigness is not a formal choice, but a necessary condition for achieving the complexity, co-location, synergies, and urban intensity. An Oma's theory of bigness argues that only at a sufficiently large scale can architecture enable the mixing, overlap, and friction of programs. And similarly, in our project, scale is regarded as a condition for maintaining overall coherence within a highly complex system. So projects such as the line push urban concentration to an extreme, which demonstrates how density can be dramatically intensified through three-dimensional compression, but also with a critical risk. When bigness serves efficiency alone, the spatial legibility and the possibility of reoccupation are often lost. So this tension is also precisely what our project seeks to address. And in the New Babylon, rather than processing a fixed form, it imagined a city defined by instability and continuous transformation, where architecture can be dismantled, reconfigured, and reoccupied over time. And this idea of a spatial reinterpretation forms an important theoretical foundation for our project. So returning to London, the site sits between the City of London and Canary Wharf, two highly productive financial centers, yet remains spatially underdeveloped and uninhibited. So while the site is surrounded by strong transportation infrastructure, its spatial potential has never been consolidated into a coherent urban condition. So at this scale, the project operates as a piece of urban infrastructure. So the architecture decisions here inevitably become urban decisions. Extreme co-location of programs produces efficiency, but also risks loss of orientation and social. So the core question here is not about how to stack programs vertically, but how such an extreme accumulation can remain legible, inhabitable, and continuously reappropriable over time. So this leads us to the architecture transparency as our theoretical starting point. Drawings from studies such as Peter Assmann's House 6, we understood transparency not as visual openness, but as spatial ambiguity and legibility. And this concept forms a foundation for the design strategies throughout the whole project. And before commencing volumetric generation, we translated the concept of transparency from abstract discourse into three spatial capacities. Firstly, the selectability of pathways, and secondly, the legibility of spatial relationships, and lastly, the habitability of boundaries. And they don't point to any specific forms, but rather define how space should be connected, perceived, and occupied within the three-dimensional urban system. So Rule 1 addresses transparency through the movement. Intersecting paths allow multiple roads to overlap and become mutually visible, which allows people to comprehend the space through walking itself, rather than relying on the floor plans. Rule 2 here addresses transparency through cross-layer continuity, which allows the city to be perceived as a unified spatial field, rather than a collection of separate floors. And Rule 3 here addresses the transparency through the occupation. In spatial terms, boundaries are not just lines or walls, but rather spaces that can be entered, occupied, and reoccupied. So against this backdrop, we started the exploration of spatial density and form. We initially selected Voronoi as our primary geometric tool because it enables precise control over the size of spatial units based on the point density, and which causes a state where high density and low density areas coexist. So in 2D research, we tested different spatial texture using regular and irregular point grids, which suggests more standardized applications and stronger public accessibility, respectively. And then in the 3D, the Voronoi enclosing and enclosed relationships begin to emerge. As we continue to adjust point density and grouping strategies, the multi-layered enveloping systems emerge. And these geometric patterns provide the original prototypes for the public functions, such as the theaters or the stadiums. And when using a rectangular grid as a generative foundation, the Voronoi generates regular volumetric blocks that approximate standard office layout. Compared to the rectangle, the hexagon generate more multidirectional and continuous volumes within inherent neighborhood properties, which makes them one of the prototypes for the residential units. So back to the site, we draw inspiration from Warpin's main roles to establish a texture of regular and irregular elements for the ground floor and forming the foundational logic. So moreover, the gaps between blocks can cause patterns that initially appear more figure-like to gradually become neutral. And in physical objects, the figure and ground perception also varies with other factors such as lighting.
So once the form has been established, the project requires a strategy to connect the building within the city. So in this section, we conduct a spatial syntax analysis based on the site original road network. Based on the most accessible boundaries reviewed by the analysis, we define 5 primary entry points. 3 of these entries appear on the city interface, each connecting to one of 3 high traffic areas. The other 2 were situated by the water's edge, appear in a bridge. After this, we analyze the spatial connectivity of the building's interior spaces by using 3D spatial syntax. Here, the 2D and 3D connectivity of the building and the site is fully reviewed, presenting the complete spatial logic. So the following section presents the design development of each subsystem. First is the circulation systems. This shows how point-to-point logic develop into roads. By testing direct grid and branching patterns in 3D, we turn simple point connections into workable circulation prototypes. We explore 2 early circulation directions, testing both primary and secondary systems. These investigations gradually diverge into mechanical and pedestrian systems. We find gaps in 3 steps, first by scaling volume to generate initial gap hierarchies, then by modulating gap weights through sunlight intensity, and finally by consolidating gaps in an area requiring larger programs to avoid fragmentation. The optimized gaps define commercial, residential, office, and green zones, generating distinct spatial qualities for each program. Based on this, we further refine the hierarchy of the mechanical system, focusing on the organizational role of the loop system and the elevator course. The diagram shows how routes pass through different program zones and how the mechanical system enables efficient cross-zone movement. We verify the system by testing point-to-point circulation distance, confirming that routes remain within a reasonable and workable range. Next, we conduct a stride analysis of 3D space syntax, establishing multiple starting points to compare variations in accessibility, distributions, and different conditions, thereby reaffirming the high accessibility of public areas. So this analysis reviews the connectivity distribution of the overall circulation system and highlights the highly integrated street with the highest connectivity. Here are 2 internal spatial states within the gaps, conserved as buffer zones between volumes rather than as physical separations. As pivotal junctions within the circular transport network, Stations are seamlessly integrated into the architecture, enabling efficient transfers, clear orientation, and the convergence of multiple passenger flows. Responding to the concept of traversal versus detour, the bridge node is generated through spatial syntax at a direct traversal across the void, linking both sides as spatial manifestation of passage. Moreover, the lift mode package serving premium residential units and the ground floor office directly align with the loop routes, vertical lifts, and also pedestrian mechanical systems established in the preceding macro circulation framework.
Next, I will introduce structural design in the building. For a building of this scale, topology optimization enables the structure to adapt to irregular Voronoi shapes while maintaining large, column-free interior spaces. We group the Voronois firstly. The structure grows along the outer shell of each volume, which helps to free up the interior space. Therefore, floor loads are transferred to the shell, while the support points based on the relationship with surrounding blocks. Based on these conditions, the structural form is calculated by topology optimization. The entire structure is divided into 3 parts strategically. The bottom structure connects directly to the ground and supports the entire building, functioning like the tree roots. The middle structure works as a truss system, transferring both horizontal and vertical loads. At the top, many regular volumes are arranged for residential and office functions, and the structure grows along and adapts to the geometry of these volumes. Here we can clearly see how the structure grows in the gaps between these irregular volumes. Through this 3-part logic, the structural skeleton of the building gradually emerges. For special volumes, we develop specific structure designs to meet their particular requirements. Take the stadium as an example. Owing to its immense scale and suspended position in the air, with contact points only at its 2 ends to surrounding structures, we therefore sought to combine bridge structures with suspension systems to support the entire mass. The topology optimization process is carried out in 2 steps. First, the structure growing along the outer shell acts as a secondary structure, carrying the self-weight of the volume. Second, the bridge-like structure in the middle acts as the primary structure, enabling the volume to be suspended from both ends. In terms of functional zoning, the stadium is integrated into the framework, following this geometry. Here we can see how the bridge's 2 ends connect with the ground. For other spatial parts, we also apply different structure designs according to their specific spatial requirements. It includes structure of the theater, the residential platform, the interlocking office platform, and so on. Within the building, people can understand where they are through the expression of the structure itself. We use the same office function as an example. The structure at the bottom is relatively heavier and more solid. In the middle, triangular structure forms become more dominant. At the top, the structure becomes more regular and ordered. Also, the structure responds to the function of the space. Complex and open structural forms such as spatial, flow, and circulation and are often used in HM gardens or exhibition spaces. Irregular structural forms imply spatial diversity, making them more suitable for public and commercial spaces. More regular structural systems are better suited for respectively private spaces, such as residential or hotel.
Here comes to the facade. When we begin to see the facade not simply as a building scheme, but as a space that can be entered and reused, we re-examined the boundaries between massing and the exterior. As a result, the 5 outward-facing boundaries were simplified into 3 basic conditions: regular, irregular, and void. This black and white model establishes a clear overall reading of these different boundary conditions, creating a solid foundation for defining each facade's property. The 5 characteristics were identified by color coding: concentrated office, commercial clusters, useful vitality, sky garden, and green belt on top. The southeast receives the most sunlight and therefore becomes a residential site. A vertical void connects to the roof and is developed as a sky garden, extending horizontally to form the main residential area. Along the river edge, the boat pier and the bridge are introduced to strengthen the connection with the Thames. On the southwest side, defining the commercial cluster's property, there is a vertically continuous atrium generates a recognizable ring-shaped circulation space. A horizontal tunnel organizes interior space and movement across the building.
And then crossing the tower bridge, the relationship between the volume and void becomes clearly legible. And when entering the Utopian district, the building no longer appears as a unified whole, but is instead broken down into multiple segments that can be occupied. And standing on the Canary Wharf, the structure emerges as a complete three-dimensional city again. And in the afternoon, looking back from the city stage, the building is set against a complete open skyline. And as the sun nears its setting, the building's volumes and voids are softened in the play of light and shadow. Under the cover of night, it becomes visible traces of activity within the city. And at the daybreak of the following morning, it enters a fresh cycle of time. So lost in the first emergence of sunlight, the building and the city are like welcome new footsteps and new stories. For the physical model, we would like to start from this conceptual model first. So here's like, in the conceptual terms, we try to get the building slices into both x and y axis and see how the void can appear in between these slices. And this is the z-axis, which is the same concept with this one. And here's the black and white inversion that we mentioned. We try to observe the shift between the figure and ground relationship between these two models. And here, this model is like for now, it's the urban relationship. It shows the 5 interfaces that we designed. 3 of them are on the city side and 2 of them are on the river side. But actually, we prefer to call this research tool not only as a model, because it's more usable on the hand rather than on the table. Because when we use this model, it's quite easy for us to observe the void space from any different angle. And also, if we have a light in hand, we can see how the figure and ground relationship shift. If the light is outside of it, the surface will be lighter, and if the light is inside, it will change. The role between the figure and ground will change. Okay. And for this one, this is one corner of the whole cube, which is focused on showing the whole structure from the bottom to the top. And as we can see, the structure on the bottom is obviously stronger. And then in the middle, we have a more truss-like structure, where we have more triangles here. And then on the top, we have more regular patterns, which is thinner than the bottom. And when we zoom in the structure, here we have a secondary structure, which shows how we organize different distance between the main structure. We have some truss, and we have some pulley beams, and we have some grid. Okay, and then we come to the biggest one. This is also, we can see here is one section of the whole building. And the reason why we choose this as a section is that in this section, we can almost see all different kinds of function in it. And from here is our office part. And then this is a vertical corridor for the office. And here is obviously the stadium, which is hanging in the air, and it's like a structure, the bridge structure. We have 2 points here to hang it in the air. And here is our platforms in between the residential part. And all of notes here is helps us has a better understanding of the scale of the units on that model. So this is the residential model, and this is some special blocks which we have the exhibition space, we have the cinema, and we have some shops inside. All of them are just in one block. And here is some residential on the top, which we can see on the big one. And this is our office units, and we can also see this on the big model. And this is our very early version of the stadium, which doesn't have a structure yet. This is the theater. Thank you.
Yeah. Thank you, guys. You guys already had me at the very first slide. When you said I'm going to do 500 by 500 by 500 meter cube, I was like, yes, right? So, fantastic idea. And I think, weirdly enough, contextually, it fits really well in London. I think London is a kind of a city who actually does this kind of things, like with things like Canary Wharf, like Canary Wharf, or the London Eye, etc. So that's, I think, very successful. What I like about it as well is that, as a kind of architectural thesis, this immediately generates a problem, right? Like just a statement, let's do a 500 by 500 by 500 meter cube, sets out like a year-long project and a thesis that you have to work on. So I think purely as an architectural premise, I think this is super exciting. What I also really liked is that your presentation started not with the autopoiesis of architecture in a Schumacher studio, but with OMA's small, medium, large, extra large. Like I thought that was great. I think for me the project becomes at its most successful really in these images, like in these contextual images, where you see the kind of confrontation of this, the mishmash that London is, the collage that London is, and then just adding this enormous cube on top of it, and it weirdly fits in, right? Like I don't feel offended by this. I don't feel like in any way like that it doesn't fit. Like this image I really love. I think that's fantastic. The moment for me that it's at its least successful is with the sky villas. Like I think at that moment you become very conformist. Like they're so polite that the most expensive property are these kind of really normal villas on top of that massive cube. Like I think that's not experimental. That's just conformist, right? It would be cool that the most expensive spaces are somewhere in the core of this thing, right? Like you're almost saying by putting these little villas on top, you can see them here, right? This is like tiny little super luxury villas on the top. That's just really sad. Like they should be, they should be there, and like this should be for the, the cheapest villas, right? Because you have to live in a normal house on top. So I thought that was a bit self-sabotaging in a way. But a part of that, I think it's great. And what I also like, there's so much freedom when you guys are talking about how you fill in this cube. You're just throwing in stadiums and train stations and bridges, and it seems so much fun, right? Like you're really kind of putting in all of that stuff in one big cube. Very much actually along the lines, and it's a good reference, of OMA's Très Grande Bibliothèque, which is really that kind of playful system. So congratulations, very, very, very enjoyable.
Yeah, I think it's a tour de force, both as a presentation and a project. We've been given the Nolly section, not just the Nolly plan, which I think is a new and a wonderful thing to explore. I think the way you explained the differentiation between the facade treatments in terms of use and aesthetic was admirably clear. There's that kind of mind the gap analysis which you showed, which was impressive. And the fact that you'd use space syntax analysis for the steps within the building was just a tribute to the thoroughness of the research, I think. And pretty brave to put a stadium and a theatre in, a la the line. I mean, stadium's a big word to use because it would probably be more like a kind of kickabout for local residents, possibly, rather than a mass attractor. But nevertheless, even the act of suspending a public facility within the space, I think was hugely encouraging. And the bridge across the Thames and your reference to connections at the ground plane, I think were worthwhile, because actually this site is not well connected in terms of public transport, which is one of the reasons why not an awful lot has happened in Wapping since the London docks closed back in the day. And I suppose the only, it's a rhetorical question actually, but I do feel that these projects at this sort of scale, the one bit of analysis I'd have liked is if you shrunk it, would it still work if you shrunk it by, let's say the planner said, well, I think it's 400 metres high. If the planner said, okay, you can't go taller than St. Paul's, could you still make it work? And I think that idea then comes, how do you make these mixes? Because what this really is like, it's like the city in one building. And I think the problem with that, which is why I'm glad you made your connections to the wider city, is it's a bit like socialism in one country. It sounds attractive, it looks theoretically possible. In reality, it can't and it doesn't work. However, what I will say, to quote a great historian, better a fertile error than a sterile accuracy. I think it's a fantastic project, well done.
Yeah, I mean, correlation's fascinating. It's hard to add anything, but I think this is probably, I think you can really start to debate the quality of aesthetics here. I mean, I don't know whether it's beautiful, but I don't think it wants to be beautiful, but I think it fits really well, and I think it's something that sits quite nicely at a part of London that really doesn't really have an intent, it emerges, and it makes it fascinating. So I think it's, let's put it like that, if anyone tells you you have to build a 400 by 500 meter cube and you come up with this, that's great. Whether you want to build such a cube for starters is a different question, but fascinating and yeah, very entertaining presentation. Thank you.
Thank you very much for your presentation. I'm going to try to be brief. I think one of the things that I really appreciate in this project is the control that you have in the modeling of each one of the components is very well executed to a point that when you do the final visualization, they are really convincing because you have a full control of your own modeling. So very well done. Really appreciate it. I've a couple of things. You start with, you know, the use of the Voronoi as a system, and this is the first attempt for you, or is the way you order the scale of the intervention. This gives you this series of fragments that, of course, they have different scale, the small one, the big one, that represent also, in a way, program distribution and so on. One of the less, for me, convincing part of your project is actually this exoskeleton, meaning that by the time you have the Voronoi as a scale, to control the scale of the different intervention, by the time you have that fragment to give you, again, the second layer of definition, I see a lot of potential of doing this only as a way of interlocking this program one into each other. I mean, there is one of the millions of diagrams they showed us when you actually show how the theater, stadium, whatever it is that you have as a big program is actually, you know, relying on 1 or 2 points in between 2 towers. And I thought, how powerful is this? And to a certain extent made me question in a project like that whether you could have pushed it without this kind of big force, no, as a secondary object within your own set of criteria that is the exoskeleton. But I mean, this is my view on your project, so I should have kept it for myself. But I think in a way, there is a very strong argument to look at those sections as a powerful way of interlocking programmatically, structurally, and also in terms of circulation, your own, you know, overall composition.
Copy of the comments. Thank you for giving us such a compelling story about and it's such an ambitious project, like creating a city within a city, as it's been mentioned. I think I agree with Viviana in terms of where to stop in terms of, you know, the process of using the Voronoi as an element to kind of organize. For me, it was that moment where you were talking about the figure ground, where it was incredibly successful, because in a way, there's 2 aspects in my mind. You know, Voronoi as a logic, you know, it's been used quite a lot, but actually the relationship of how it fragments and how it can create different effects within the city that was shown on that kind of plan that you were illustrating, gave me the kind of click, because when you start seeing some of these irregular kind of shapes, you can start to imagine moments where people kind of encounter and, you know, as a city. But then introducing this kind of second system sort of dilutes a little bit that aspect. Nevertheless, I think you have been probably one of the few projects that I've seen from this brief that actually leans more on the experiential side, and like telling the story, you know, a day in a life became really strong, and you can kind of relate more into what it means to live in a city like this. So thank you for that.
I want to congratulate you as well. A great presentation. I really enjoyed listening to what you were saying and how you were explaining the project. And I think the visuals are really amazing, like Viviana said. It really looks like the project is almost built already, so you can really visualize what it will be if ever it would be built. I don't agree with London being very experimental. I think London is very conservative. It would be amazing to see such a building in London, because I think it's too traditional, the way the city is done. But yeah, I wanted to congratulate you also for all these beautiful models and the way you were explaining the models. Also the fact that you have, I know it's a detail, but that you have names by your models or explanations. I think that is also quite a nice thing to add, and also to give us a model to play around with, to really see and be able to study on our own what it looks like. So I thought that was a very nice addition too, in terms of presenting. So thank you very much.
I also want to congratulate for the presentation. It was thorough. It was enjoyable to watch in terms of graphics and in terms of visuals. And it was entertaining and fun, I have to say. So good job on that. And you know, it's a tricky challenge. You try to give a very complex answer to a very complex question. But nevertheless, you managed to successfully have a cohesive story and image and spatial organization, mainly to the structure. Perhaps my only, it's not a provocation, it's just an invitation maybe for the next thesis, in case you want to continue. But it would be interesting to see perhaps how these structures, that the unifying element of such a complex organization could differentiate itself in different parts of the world. So I'm thinking how in London could be different than, for example, just a simple, not simple like white cast concrete, and how it could be have a different tectonic and expression. Perhaps it would be something interesting to express and experiment in different part of the world. I'm thinking about engineers and architects that successfully managed to do that, like Eladio Dieste. Imagine a building like that with different expression in tectonic and technology in different parts of the world. I think it would be really, really interesting to see, and that's for the next one. So congrats, it was really good.
Wow, thank you guys. Truly rewarding. I love the project. Actually extremely well presented, I thought. The way you introduce it, you get into the job, the way you lay out the thesis, the precedents, then this kind of additional element of figure-ground, figure-figure, gestalt switches, and making the void a theme. But also, I think the way the Voronoi have been handled was very beautiful in terms of regular, irregular, large to large, or many, many small around a large one. So this kind of range of granularity, and I love, I mean, Jill is right in terms of the views within the city. They were always very important for me from day one, because you have the granularity. That makes the districts within districts, and it works. You can see the grain of these blocks has something to do with it, and you have larger and smaller structures. It juxtaposed that kind of rawness and roughness. Of course, it's slightly more unified. And I've always looked at it as a square mile on the one hand, Canary Wharf, and a particular square mile. If you look at it from the other side of the river, it's nearly a one mass, messy. But what is important to remember, I think what is lovely here is that you have, in the city, you're always on the one plane, and then you end in these cul-de-sacs. And then you have one moment maybe on top of the walkie-talkie where you have this, but nothing corresponds. But here you go into the fabric, you look down and cascades, and you have layers up, below, and all around, and you have much more synergy. What Rem meant with the bigness thesis, which he wrote up 10 years after the projects, which was the Bibliothek Nationale, the Karlsruhe, and the Seeberger, was the regime of complexity which you can unleash beyond a certain scale, and the kind of relational density, intensity, that so many things you simultaneously connected with. And if you think about real estate, of course it's expensive, or location means what are you close to? And here you're close to many, many things. And it's not only close to next door, but visually connected. And you feel good when you step out in the space and you have unfolded these kind of 250 destinations. And then the way it communicates into the city. Of course, you have to go across the river to see the city of London, but this one you see from everywhere, and it's a new landmark. Somebody said, yes, I really like that ambition. So, truly rewarding, and thank you so much, guys. Fantastic.
Yeah, really. I mean, I think most of it has been said. It's really a beauty. I mean, I love the theme, and I'm excited about this. This is the first year, right? You're doing this new, so there's more to come. Just because it's already so good, there's like two things I was missing that would have at the beginning. I also agree, it's a beautiful narrative. This little detail about the fact that, if you would compare all the towers that are currently in planning in London, just add up all the square meters and all the building cost, and then transfer this into yours, right? Because that was part of the brief or the thesis, the exploration, right? And it was just missing. It was just such a strong little hook, you know, to at the beginning to establish the narrative, and then I do agree. Space syntax, you know, in the 3D is, I mean, in reality it's very difficult, you know, to solve that problem. But it's great that you tried it. In that same vein, I think it would be nice to have seen the light and the wind as well, right? And so the natural element and because you do have some sort of, you know, green element that runs through, and this comes with an ecosystem, and it comes with wind, and it just has this other, just another layer of quality, you know. But all these are just things to make it, you know, even richer, the experience. Otherwise, yeah, I think I love the project.
I mean, just one thing which you can always criticize, and it's hard. How many things, layers can you kind of visually take in? But what is striking and the obvious is the dichotomy: public space, private spaces. But where it's not so easy to track is residential versus office versus, and also what you don't track so well at this point is sun direction. So the kind of the brise soleil, the depth, and the north, south, east, west, etc., etc. So there's obviously other aspects of this. And so this is one of the three, is the most kind of dense and the most uniform to some extent, with expressing mostly only the private-public dichotomy. But I think the other things are there. But the question is always how conspicuous they become, and how much else can you differentiate the other things without, for instance, breaking the public-private dichotomy.
Hi, just to give you a bit more feedback, because I saw the same, you know, subject yesterday, and I said it will be a landmark, so it is a big challenge. I hope it will happen, because I feel London needs something like that, something breaking the rules, you know, like a statement. I think you did better, to be honest. It's more landmarky, it's more convincing, not fully, I mean, but it doesn't abstract. It's sympathetic. You have very nice spaces inside. Even the music, because those teams, your teams are using music, is very good, and your music was completely different to the previous one, which was, you were calm, very elegant, very nice. I couldn't be critical. Maybe just something to think about in future is, you know, if you really want to be future-proof, think how the building could evolve, because no one will be able to deliver it very quickly. It will take years, and demand will change, you know, and our culture will change. So somehow your AI systems should help you, you know, design a building that is live, you know, like a tree, like an organism, and evolves when it develops. So yeah, that's all from me. Very, very well done.
Maybe just a small remark from my side. I'm kind of curious, because some people have lived in London much longer than me. When, for example, Richard Rogers dropped Lloyd's into the urban context, or when all of the high-tech work from Grimshaw to Hopkins and others started to appear. I imagine that sensibility of actually trying to develop a high-tech 2.0, it seems to me like this project has some kind of sympathy with that kind of way of thinking about things. What I appreciate is the fact that you are moving kind of between scales. The word narrative comes up, and usually that's a word that's a little bit unsettling for me, because it usually goes into a story and a particular perspective. But in your case, I think it was very useful to be able to kind of both at the same time work at the large figure kind of situation, much more urban kind of synergies, but at the same time trying to localize that from a human experience. I think that humanization aspect of it, I think, is important, because there's a sensitivity there that in some sense has to continuously be brought back into the conversation. So I thought that was a very positive thing on your part. I also think that, you know, the conversation that we had with some of the other projects spoke about how a project like this, which is both infrastructural, city development, urbanism, building, would happen over time. In your case, with the Voronoi logic, with the framing structure, there is a kind of interesting challenge to the traditional megastructure. which I think is useful because at the same time it has these kind of individual cells that has been brought up, but at the same time you're not overly kind of expressing those discrete puzzle pieces. So it gives the opportunity, I think, for that to be a next stage of development and a way to actually also realize that in time. I think one of the things that would be really interesting is to see how the City of London would also respond. Because right now the idea is that the monument is, in some sense, that conversation. Those discussions, once again, I think, like with Venturi, with others, with OMA, we get nostalgic about this kind of period, talking about this kind of work, but this is something different. If your generation of architects is actually being a little bit self-critical about that kind of discourse relative to the kinds of challenges that we have today. And all I'm just trying to suggest and to encourage you is to look for those opportunities for where difference can be meaningfully kind of expressed. And I think you guys did a really good job of kind of walking us through that path. But I think like every project, especially when it's more research oriented, like being able to kind of articulate what the next research question would be, I think is really important, so that the friction and the desire and the need to work at multiple scales is always somehow embedded in the way that you're thinking about this work. So I think it's a really good way to, you know, continue the conversation that we started with the other two teams and then, you know, bring it to a certain kind of resolution with this discussion. And I think you guys should be commended for that. Patrick is excited, wants to invent new projects on the fly. Okay, we got one more. If I could ask phase ones, if we guys can just move the models into the South jury room.
Oh yeah, exactly. I mean, like it would have been funny if like on the top of it, like a typical high street, then
This is wired. You want me to get it?
and then you see like all of like mini London, like a little church, a little high street, like basically like double wide. Just
I can pay this one.
Shy to speak up, but yeah.
admire the power of the workflow methodology. It's going to change forever how we design this. I think it's super important to put in perspective how that shifts the responsibility for the architects. That's been said. I don't know the name of the message we talked about, the decision-making process and all that. I think that's super important even at the academic level to start putting this perspective, as well as not taking for granted the results of all this very quick and fast and not easy but fast generation of something. And be able to question it, to run some quality analysis and quality check, and because otherwise you take for granted something that just been generated. And yeah, someone said there wasn't any problem in the design, but I mean, it's very easy just to take for granted what you see just because it looks.
Well, yeah, that's where then once you create the system, then you can like you can kind of look the win-win situation. You can see like you get this one is appealing to the architect, this one is appealing to the developer, the city. Yeah, exactly. So it's simulating. Kind of win-win situations if people were to participate. Like, so if there are these many players, you start with 2 and then you can have 3 and 4, 5. But eventually, I mean, if it scales, like you can have like direct democracy, where like you start with 2 and then you can have 1 million people. But in order And for this to work, like you need like architecture to be truly generative from like the probability aspect, economic aspect, just trying to enable the system of automation in a way like that we can then try thousands of options and then kind of figure out which one works better for people and which one works better for the environment.
Okay, everybody. Thank you, everybody, for having the stamina to stay with us. We have one more project. It's all yours.
Okay. Hello. Yeah. Good evening, everyone. Myself, Sumant. With me, Supreet and Kian. Today, we are presenting our project, Architecture of Co-Intelligence. We are from Spatial Studio, where our work explores multiple forms of intelligence as a framework for performative architecture that responds to planetary change. The brief Everything Intelligence asks how architecture can engage and extend intelligence, both natural and artificial, to sustain life in an era of planetary crisis. While intelligence today is often viewed through artificial systems, we begin with nature itself. For us, seed represents primordial intelligence, a capsule of genetic knowledge that has evolved and adapted over millennia, sustaining both itself and the interconnected web of life it supports. Seeds can be represented in dual forms as physical specimen embodying evolutionary adaptation for survival, and as digitized data sets encoding ecological parameters that enable analysis, clustering, and spatialization. Climatic change is reshaping every aspect of life on Earth. Scientific assessment warns that over 40% of bird plant species could face extinction in coming decade, marking an unpredictable crisis in global biodiversity. Current architectural precedents address biodiversity, such as Solbau Seawald and Eden Project, remains largely passive. These typologies document nature rather than working along with it. Artists like Rafi Kanadol has attempted to expand these fields, translating vast data sets into immersive visualization that evoke sense of non-human agency, yet these remains representational. They aesthetize data without materially sustaining the system they reference. This raises a large challenge of tangibility. How much are such work truly educating or materially solving planetary realities? We begin our precedent study with Millennium Seed Bank, managed by Kew Garden at Workhurst. The facility stores billions of seed and integrates in-house research center, enabling scientists to conduct long-term conservation, research, and biodiversity preservation. Unlike many other seed banks, Millennium Seed Banks allows visitors to observe functioning and research facilities. However, despite of this level of transparency, the seed bank operates passive. Visitor interaction remains limited, and the seed are stored as static asset rather than actively engaging with natural system. In response, we envision a new architecture typology that shifts seed bank from passive repository to an active living system. Greenhouse and testing rooms evolves into continuous biomes where plants are not just tested, but actively brought back in life, and the system becomes educational system that brings visitors close to nature, transparent and direct engagement. We start our research by understanding how AI works. The trend of AI applications have spiked in recent years. Generally, we as whole see AI can solve complexity and handle redundant tasks in short time. But how does these AI understand context as we understand the world? Well, AI thinks through numerical values. Any inputs put into AI is tokenized, being converted to numeric values, and then computed in trained models and neural networks, and then they are de-tokenized to get some kind of information out. For example, image-to-image model works by breaking images into pixels, converting them into numerical values, and it learns and detects patterns to generate new images. Well, how do we use data sets for architecture? Our architecture is governed by multiple interrelated taxonomies. Species taxonomies defines biological requirements of plants housed within the building. Programmatic taxonomies organize architectural functions necessary for seed banks to operate, both building and master plan scale. And architecture taxonomy integrates this system into unified spatial logic. Together, these layers form collective intelligent architecture typologies. We envision a building that is simultaneously an active repository, a knowledge center, and regenerative biome. The seed bank thus evolves into co-intelligent infrastructure and operational architecture that preserve genetic diversity, sustain microclimate, and regenerate life back into the planet.
So we began with species taxonomy. Under species taxonomy, our workflow involves collecting ecological data sets to train a model that analyzes and predicts potential species loss. The model then clusters species according to shared environmental conditions, resulting in design of adaptive microclimate and spatial configurations. The resulting data is then converted. So we began by developing a prediction model that combines 3 global data sets: ecological conditions, where all the values are normalized and a specific weight is assigned to the model. This generates regions with species most at the risk of extinction due to combined environmental pressure, along with the list of affected species. The trained model also provides us with detailed ecological parameters for germination and regeneration, that is replanting for each species, as seen in this photo card, including preferred climate, temperature range, light levels, and humidity. Volume proximity defines its physical footprint, and soil depth and substrate indicators inform routing behavior. Also, each species is characterized in conservation status, ranging from least concern to extinct in the wild, which helps prioritize critically endangered and endangered species. Linking ecological conditions with conservation urgency enables early intervention before extinction. All of these parameters help in integrating biological needs into architectural spaces. So these species have to be planted according to their ecological layers to replicate natural forest structures. This sequence demonstrates the vertical organization of plants across subfloor, forest floor, understory, and canopy layers, ensuring that each species occupies an appropriate spatial and environmental niche within the overall system. This layering ensures that plants sharing similar traits are spatially organized while respecting their distinct environmental niches. So to construct these ecological layers, we trained a model which uses unsupervised learning methods such as k-means clustering to group species by similar traits. This distinguishes trees, shrubs, climbers, and ground cover, and these are visualized using TSNE maps, which compresses high-dimensional data into spatial maps that reveal clusters of species with similar environmental requirements. And we get the data of the regeneration clusters, which look like this, which explains the vertical hierarchy and successional behavior of the species. For example, cluster 1, 6, 7 contains small forest plants, cluster 2 contains climbers, 3, 8, 9 represents tall canopy plants, and 4, 5, 10 relate to the understory shrubs, establishing the structural basis for regeneration organization as seen in nature. But these regeneration clusters only tell us about the structural role of a species and doesn't ensure same microclimatic needs. 2 plants in the same layer may prefer completely different soil, humidity, or temperature conditions as indicated by varying colors. So to resolve this, we run another algorithm called dbScan, within each regeneration cluster to create the microgroups of species that match closely in climatic requirements. The outputs illustrate species clustering around particular soil types, humidity levels, and temperature profiles, leading to ecologically compatible groupings suitable for cohabitation. This is a representation of those regeneration clusters, which are further divided into color-coded microgroups representing species capable of coexistence in buildings by creating microclimatic zones based on shared soil and climatic needs. So algorithms like dbScan is valuable in architecture, as this enables the natural formation of architectural organization rooted in ecological compatibility rather than predetermined classification. Now, to deal with the complexity of organizing thousands of these species with competing habitat needs, we developed this workflow to generate the master plan taxonomy dataset. This integrates species taxonomy and seed bank programmatic relationships with a contextual color field for data sampling. Species taxonomy and programmatic relationships are processed in parallel using a graph-based algorithm, while the contextual color field is analyzed through a self-organizing map. Together, these systems produce an optimized spatial field that informs the master plan, indicating how and where species should be distributed across any site. To translate this abstract spatial field into a coherent physical logic, we studied the self-organizing and adaptive behavior of soap bubbles. We observed the formation of bubble clusters by varying the number of bubbles by inflating or deflating the cells. Then we observed closely the geometrical property by inflating different number of bubbles to see how they interact with each other under controlled parameters. Our experiments indicate that soap bubbles can closely pack while preserving their spatial properties, which aids in developing a self-organizing master plan. One strategy to expand our study on a digital tool is circle packing dual geometry, which shares geometrical properties with bubble clusters and enables control over cell size in relation to plant species spatial requirements. Using this bubble cluster geometry in the master plan, first the primary programs necessary to facilitate the running of the seed banks are placed, and next the microgroups are inserted between the primary spaces. The radius of these are directly calculated from the plant data by converting each species bounding box into a size value, scaled by a seed multiplier depending on the criticality of the species. For placing the program, the AI model uses a weighted adjacency method. Spaces are grouped into core seed processing, technical support, and public or staff areas. Each pair is assigned a proximity weight between 0 and 1, defining operational dependence, and a spring-based solver organizes space by operational dependence rather than manual placement. These primary spaces are sized based on the number of species accommodated, with specific area limits for different programs. Then to place these spaces across any site condition, a multi-factor optimization process is used, allowing the spatial layout to adapt as environmental parameters change. The AI evaluates continuous fields of accessibility, existing infrastructure, and terrain, each normalized between 0 and 1, with different program groups responding to different drivers. Like accessibility acts as the primary driver for initial placement of entries. An access gradient is generated from the road edge, guiding 3 entries. Public at peak accessibility, service at a distant but highly accessible point, and staff within a mid-access zone. Next, the placement of program varies on the existing infrastructure, like public spaces are drawn towards accessible central zone, service spaces align with strong infrastructure, and mixed programs adjust flexibly between them. For placing each plant cluster, we know its preferred humidity band from the ecological data. We invert that preference into a target terrain value so that the wet-loving species aim for low DEM values and the drought-tolerant species aim for high DEM values. To support both seed bank research and educational biomes, species are zoned by conservation status. Extant in the wild and high-care species are placed near labs, while endangered species form core regeneration zone. Then a time-phase regeneration strategy inspired by natural succession is applied to recreate the hierarchy. Based on all these rule sets, the algorithm generates the master plan with specific sizes and coordinates. First, the primary spaces are positioned using adjacency and infrastructure logic. Then phase 1 plant groups, mainly the tall canopy clusters and early ground species, are placed together so they can stabilize and establish for the first 2 years. Intensive care species are positioned close to the labs, After 2 years, mid-story species are added in phase 2, followed by another layer of small species in phase 3. This is the overlaid plan in phase 3, which shows the master plan after the system has matured over time. And all of these will be placed based on the data about the number of species, radius of each cluster, and the coordinates. Each of them carries their own specific climatic profile, day and night temperature, humidity, light levels, soil type. So spaces that share same conditions can be grouped together, and this blob represents the volumetric capability of them. Now, to convert these blobs to spaces, we use the concept of cellular subdivisions. So AI generates this layout and gives the coordinates, which we can use to subdivide the space into microclimatic pockets that replicate the exact condition each species needs to grow.
From the proximity of volume, species, and climatic metadata, we developed spatialized data using architecture taxonomy. In contrast, other two data sets, for architecture taxonomy, we tailor a synthetic data set that's with generative algorithm that routed from vectorial rule sets and material property to generate data sets that taking volumetric, climatic, and performative properties. Our studies start with long span structure strategies to accommodate large, diverse number of species. The data we work with is highly dynamic and constantly changing, requiring architecture to behave more like living organism, capable for adaptation over time. In response, we looked into tensile architecture, drawing from architectural precedents and developing techniques such as Frioto tensile model to spatialize our architecture system. While we aim to create enclosure, we began working with fabric. To introduce constraint and control within the membrane, we merged fabric and string by stitching. We developed a working prototype using C data as a proxy to observe test system behavior. Well, this is a model which actuates and generates spaces based on the input data. Since we noticed that there is a limitation to study further within the single layer membrane, we developed an idea by adding second layer of fabric, stitching them together. By doing this, we could generate various spatial conditions, such as connecting exterior to interior, creating shared conditions, and forming in-between spaces depending on requirements of species. For the interior subdivision, we expanded the string logic by introducing pull points and anchor points. We generated complex spatial configuration. The aim was to create different subdivision for varying purpose that needs within the biome, while demonstrating how system can adapt and change. This physical model was used to study subdivision logic within the structure. These are some iterations exploring enclosures, transition space, and biome. By adjusting human scale within the same model, the architecture scales adapts to support different spatial purpose. After we grasp intuition of relationship between force of membrane within the same to demonstrate different spaces, could serve different programs. Like this large pocket act as shared environment for multiple species acting as biomes, while the smaller subdivisions provide isolation, intensive care conditions for species requiring strict conditions. By offsetting selected cells and pulling the bottom layer down, the membrane naturally forms continuous valleys that can function as circulation paths within the system.
After experimenting with different subdivision strategies, we observed that the number of subdivisions significantly amplifies stress within the membrane. This led us to explore further on manipulating the pylons, allowing their movement to directly respond to subdivision and calibrate the system. For example, as the subdivision increases, the pylons are required to move further apart from one to the others. To enable deeper understanding and easier evaluation, we translate insight from physical model into digital exploration. This simulation demonstrates that as subdivision increases, the resulting of overhead height decreased. We introduce non-vertical vector forces that calibrate the system to control subdivision property, such as height and area, to achieve a subdivision R at. We extend the investigation by selectively pulling a single point at a time and evaluate the property change according to the distance between vector points and the cell. We found that when a vector point starts closer to a cell, the maximum height the cell can achieve is slightly lower The relationship then will be taken into consideration as a parameter to control cells property for further study. After understanding the relationship between mainframe behavior and cell subdivisions, we develop a set of vector rules to generate subdivision with various spatial properties. The objective is to identify potential vectorial blueprint that capable of producing space under different conditions, such as climatic control, accessibility, openness, and the ability to connect multiple cells. Pulling down all edges and points generate an enclosed climatically controlled space. Release one edge, create a potential access point. Release additional edge, enable multiple entry direction, and reduce tension on the mainframe. Now releasing two adjacent edges provide a single access point with increased openness. Releasing edge while maintaining the intermediate vertices introduce transitional space that could be one part of a circulation. The pooling vector can be moved away from the cell center, creating a more welcoming space with the potential to function as transitional space. Building on the single cell instructions, we introduce additional subdivision and define relationships between them. In this scenario, access points are positioned at a distance from one to the other, resulting in a low level of interaction between cells. When closest edge of two cells are released, the cell can share access point, introducing a stronger relational connection. Applying a pooling vector to share edge of the isolated adjacent cell, merge them into single spatial units. These conditions occur when both cells share the same climatic requirements. When cells have different climatic conditions, those with shared requirements are joined, while cells with different conditions remain isolated. In the scenario that cycle of plant is isolated in cell is completed, the subdivision can adapt itself to merge with other cells, only if the new generation of plants share the same conditions. Based on these rule set, we drive the digital model to iteratively generate a large number of synthetic samples. Next, we explore material strategy that enable control over climatic condition in response to specific species requirement. We apply different material systems, fabric, latex, and hybrid of fabric and latex across spectrums from permeable, semi-permeable, and impermeable. Each material has its own capacity to regulate temperatures, light, and humidity. It is also evaluated alongside with deformation variable, which influence the tensile system with vectorial force at once applied. Based on the evaluation, the material we apply into we apply material into previous rule set according to the climatic requirement. We develop our exterior surface, treating it as a performative skin that being regulated from vectorial rules is respond to climatic conditions in order to harvest resources that necessary for sustaining plant species below. We focusing on water and temperature as they are critical resource for plant growth. We begin investigation how rainwater runoff can be controlled to enable water harvesting. We use deformation of the surface from vectorial movement to create different topography and evaluate capturing ratio from amount of rainwater that surface can retain. We capture one state of the data as a benchmark to evaluate our experimentation in the first iteration. The water can be captured at 61%. To maximize water capture efficiency, we shift vector outward to modify the surface topography, expecting to have more capability to collect more water, also applying downward pooling vectors at the valley to direct water toward the ground. Running the simulation again, we observe that the surface achieves higher water capturing ratio, increase it to 76% point. At outward pooling and downward pooling create valleys to the center of the cell pooling position. As the mainframe reaches its pooling capacity, we introduce additional pooling vector to generate deeper valleys. The water capture ratio increased to 86% as the valley is deeper. When we shift the pooling vector toward the surface center to reduce the stress in the central area while maintaining 3 downward pooling vector, this redistribution of the stress allows the central valley to deepen. As a result, the water capturing ratio increased to 92%, but it's also reduced the spatial height below, introducing a trade-off that must be evaluated against the requirement of the space underneath. For solar exposure, we again introduce pooling vector point to increase exposed surface area and oriented towards solar radiation. The system enhances potential of heat transfer to the space below. Surface performance is evaluated by aggregate area across 4 radiation bands: very low exposure, moderate, high, and peak exposure in ratio to the whole surface area. This setup has a high exposure area is around 65%. Then we again move vector point toward the cell center, introduce an additional subdivision to observe the result change. The results show that the amount of the phase has highly exposure sun increased from 65% to 72%. Next, we move the vector point again to reevaluate the system. The results show that the proportion of the highly sun-exposed phase decreased to 64%, as a deeper valley formation creates more surface area that are not directly exposed to the solar radiation. From adding subdivision, application of material to performance of the exterior skin, synthetic data are sampled with vectorial value in relationship between mainframe and subdivision. These numerical values represent instruction for architecture to intelligently responding to complex conditions. This is our rendering of the project from the exterior. And this is the interior space, where we have pylons control vector on the surface exterior. This is the subdivision, how we classify 3 species into groups. To conclude, the project used ecological data sets, synthetic data set, through a collaboration between natural and artificial intelligence, positioning architecture as an active mediator between data, intelligence, and the living world. Our seed bank is no longer static. It adapts, responds, and evolves, operating as a living system. It is designed to negotiate complexity in nature to sustain life in the era of planetary crisis. Thank you.
This is the adaptive subdivision model, which we did in order to get an intuition of how we can pull down different points to create the interior species. This is the 2-layer subdivision model, which we did to differentiate the conditions between the exterior and the interior. These are few of the material study models. It can be fabric or it can be an hybrid material of, in this case, we use fabric and latex. This is the string material model where only these strings were used in order to create the structural framework. And this is the latex material model to create an environment where we would need more humidity. This is our first prototype model, which we used to generate the spaces from the natural data set. This is the multiple layer subdivision model where when we stitch different layers of fabric and pull them at different points, we were able to generate species required for the programs, whether it can be biomes or it can be intensive care units, which are these smaller biomes. And these are our initial data-driven prototype models, which we did in order to understand how we can connect the real-time data into a physical prototype. And demonstrate the final prototype.
Yeah, let me just turn this on. So this is our latest prototype, enabling showcases double layer and multi-axial movement of the pylons, where the motors activate the additional subdivision. In that way, the pylons get information and behave according to it. So there is an addition of subdivision, and pylons get the information based on those behaviors. So every time the subdivision added, the pylons get the information and start behaving according to it. Well, thank you.
Okay, I'm going to start. Well done, guys. I think this is the first presentation that takes ESG into consideration. And also I'm convinced because you proved from, by your story, why you got to where you have got to, and you actually created something that's, visually convincing. So yeah, well done. It's very mature and almost ready to be delivered.
I think also huge congratulations for me. I think it's a fantastic project with a lot of layers. It somehow is a project that is kind of like a digital gardener, right? And it reminded me, especially the images where you show the clustering of all of these species, kind of Piet Oudolf, who's this famous, probably the world's most famous landscape architect, right? And I really like that you kind of go to that granularity of clustering all those seeds and making it kind of this activity of gardening it and clustering it, and then that ultimately everything around it is then kind of the consequence of that very granular organization of plants. And I think there's something extremely poetic in the activity of that gardening, that kind of being in the soil with the seeds, and then the almost cold and mechanical system that arises from those organizations. I thought that was really successfully shown in some of the videos and also in this model where you see these pylons slowly pushing the surface to ultimately garden, right? To tend to those species and to this plant. So I think it's a very sophisticated and kind of unexpected project that goes all the way from the climate to the seeds, to these granulates, to then creating that kind of artificial environment. The one thing that I missed a little bit was just I would have loved to then see it somehow deployed in maybe an urban context or in a city and do that kind of provocation of now we put this, again, maybe I'm still a bit biased from the previous project, but what happens if you put this in the center of London, right? What happens if you say that this is becoming Hyde Park or it's becoming a new park, and it has that capacity, right, to really be, a park. It's very logical that it does it, and seeing how this would interact with the public that just takes a daily stroll to it on a Lime bike, kind of going through this seed bank, I think would have been just one more thing. But yeah, I think it's brilliantly presented, very, very, very beautiful.
Yeah, thank you very much. It definitely is a lovely starting point. I think there's two thoughts I have. One is, in some way, we're living in an odd time where almost feels like we need a digital crutch to remind us what ecology does, what plants do, how ecosystem works. And you're visualizing it in a very kind of strong manner, right? It's an educational piece, almost like it. But I think this is knowledge that we somehow used to have a bit more internalized, and now we are building these digital crutches. But I would lean into that and go even further. And once you have that system, I think there's two really beautiful ways to evolve from here. One is to actually create a digital layer where you can see the invisible dynamics that are happening, in the soil, in the relation, between the plants. Because when you, in your analysis at the beginning, a lot of the way you did the clustering was relational, right? And there's a lot about these ecosystemic relations in a forest ecosystem, but which this all comes back to. And so now there's a very strong visual learning experience through the mechanics of the thing, and I think that you could go more into detail and show us the next layer of hidden dynamics that are here, and then it becomes a really interesting park or a very interesting experience. I love the idea to put it then in context of a city and I think so. It's a really rich beginning of something. And then lastly, maybe once you have at the moment it's focused on the water and the sun, right? But in reality, all of those plants actually send signals which you can capture, and they can directly influence the dynamics. So it becomes a real-time dialogue between the natural living material and the physical structure, right? But all this is here. This is like for me, this looks like the beginning of a really interesting exploration that you can start layering on top. So it's a very lovely project in that sense that it is that soil in a way for more stuff to grow from. So thank you.
Only one thing to add to that. Oh, sorry. Very quickly, which is that there was an early image which had inputs, nice diagram, and then output, which is sort of what we see. And I think the missing thing is the outcomes, which is sort of, and what happens next, which is what you're saying. But beautifully done.
Yeah, and to jump on that, really congratulations. I really like your transition from the passive seed bank you were describing to that dynamic approach. I think it opens up like a huge potential when you think about. I really see this as a potential laboratory for to studying species and influence on climate. That was the original goal of projects like Biosphere 2, but Biosphere 2 was static. It was you wouldn't have that ability to test the influence between species and between climates. That offers new potentials. Being able to study, you were talking about the influence between species, that symbiosis effect that would happen here is super interesting to be able to study it in a dynamic way. Same thing for the climate influence. That pockets that you would be able to create is really a mean to switch from that monoculture that we've been developing more and more to switch to that polyculture strategy and be able to understand precisely what happens. And to jump on what was saying about the live monitoring of that, I see really well how you could plug computer vision to all that and be able to monitor super well how all that behaves and identifying new strategies to make these lost species live again and what would be the impact. And yeah, I think that's fantastic. Thank you.
Thank you very much. Really rich presentation, very clear for us to follow it, although you are the last team of the day. So congratulations on that, because I think it made our, now the feedbacks much easier. I like the clarity. I like the fact that you really looked into this local to global deformation, that you talked about how interaction between the different species with the environment are actually making different configurations to appear. And I think there are a lot of very interesting study that you have done. I have few very quick comments that maybe for a future project would be interesting to relook at. One element is that you talk very much at the beginning how those different species are actually happening also at different height, and this is very much part of your own final elaboration of the project. And I was wondering whether there was any point where you started to add different layers, allowing for different, vegetation to grow at different levels. You also thought about how humans could interact not only on the level of the floor, but also potentially, being able to appreciate what a canopy will look like, or what the intermediate or the in-between vegetation will look like. And this is where maybe the second comments come into it. There are two aspects that are still very much rigid in your project. One is that the ground is a flat ground in all of your exploration. I mean, that could have been easily, in a way, avoided, because no landscape will always be a flat landscape. Actually, a lot of plants do need to have a bit of a, different leveling in the ground. And also, maybe at one point you shift by using, this very big textile surface into, creating this height, those columns that are holding then a rigid frame on top. I think those kind of steps that you consciously made actually took out quite of the complexity that was emerging by only using, those multi-layer and intersecting layers of frame versus textile. So overall, it's a very strong project. I agree that it would have been nice to see it tested in an environment, just to see how this system could actually respond if placed within the space. But otherwise, very good model making, very clear presentation, so congratulations.
Just want to put a downer in just on the side. I mean, because I think of course it's a great project, and that's why you kind of get place of prominence, but I feel you've rested a bit on your laurels from the December presentation, and I've seen nothing you've added to. I mean, everybody has been calling for the citing of that, and that was mentioned. And that point, I didn't imagine a city sighting. I would have had imagined a kind of landscape sighting, where you have slopes, where you have rocks or slopes in a shadow, where you could also launch it from a cliff and that would have also talked about a certain scale. I mean, this is an ambitious project. So once you would have scaled that, which I would suspect wouldn't be in the corner of Hyde Park, but something larger than Eden, then you couldn't have left it so generic. Because imagine this for 3 kilometers is going to become oppressive. So what I see is this kind of, and what you said is also important. You could have valleys, rivers, different microclimates, and there might be trees which you have to scoop out around. And I was looking for, in a way, that this membrane is also differentiating. At a certain scale, there is. But I mean, I like the 2 layers, but cable networks, or what is the mechanics of this? What are the actual materials and how they migrate and change? When is it opening up? When is it getting shading paillettes on top? And when they flip open, or things like, Achim Menges kind of curling up elements, when this thing allows breathing coming in? Because the microclimates, they I don't see, if this is a homogeneous canopy of like a greenhouse. Greenhouses are done for one species. This, you need to differentiate that, I would say. And we talk, your sun exposure, etc. So that's where I think there was for me, is a letdown. And sighting, which is, so it's incomplete. Sighting is incomplete. The scaling also, if you scale large, these pylons, how do they either have to shoot through and you have a huge eye, or you have to do a kind of umbrella, so they have soft dome. I mean, there would be different. You have some of those to orchestrate those, and to see how this it gets differentiated. So these kind of hexagonal cells and so on. I mean, that's where I feel. How do you enter this thing? And where does it feed into the ground and so on? But I think the scale is what probably you would want it. And so that's, the sighting was a critical mistake, and I don't know why you haven't gone there. Basically, I'm not sure. I mean, you have, it's basically the same project that you had in December.
Hello. Okay, so we never have like a specific site, because what we are looking at, we look at the dynamic, and also where this thing can sit, it can sit like almost anywhere, because it's a prototypical project. We imagine it as if it sits on one climate, whatever cell that outside of the control subdivisions, it will share the same climate as the exterior conditions, meaning that the subdivision will define whether that specific plant is suited to that conditions or not. That's why.
Well, you don't know what I mean, there's no mechanism. Sorry, but you're a bit defensive. I mean, basically, since you haven't cited it, you didn't know what to do next. And these cells, we don't know. You're just ascribing climate difference. Just telling us. There's no nothing backing that up. Yes, you have generated separate cells. As far as I'm concerned, they're all of exactly the same conditions. Unless you have artificial humidification. I mean, also that network could be, open net, water harvesting out of mist in front of the. I don't know. I mean, I'm just curious why. I don't think it's a merit to say this is endlessly flexible, then you should have put it into 3 sites. Sorry, guys.
Patrick, let's put it this way. I think your comments are valid, and I think for sure that is things that they could consider. Any kind of prototypical system should be tested in different scenarios. I think, though, that there is something to be said about engaging with a certain rigor to move past representation. So in the claim, and particularly in my studio, of not being the biggest fan of just representation, and really asking the students in some way to really start to grasp the challenges of data, to really look at the species and to try to deal with all those things. I think it's fair to say that they haven't fully expressed how the bioclimatic subdivisions would actually be tested and all these things. The fact that they acknowledge all of these species, the fact that they're using an AI model to drive all of these things, the fact that that is embedded within an architecture that is making not a claim for kinetics, but an argumentation for a dynamic subdivision. I think that this deserves a lot of, in my sense.
There's no doubt. I mean, we would, let's say,
No,
it was the winning scheme in December, but for instance, when I'm talking about citing, I think it's an engine of differentiation.
I totally, I'm not saying that your
it's not
comments are
representation.
My point is that we also need to be clear about a certain consistency of design research that sometimes doesn't allow for those kind of leap of faiths all the time. And especially in particular to my studio, which has been dealing a lot with phenomenon without the building structuring a big part of that discourse, I think you're right, that there are things that they could be done. If this was situated in a context, that would also be a conversation. People, all of these kind of things. All of that things, I think, is well taken. On the other hand, and I state that because I think like when we also put projects together to build a kind of conversation, and I think something that we're going to kick off that conversation once again next week, because we are really that kind of glutton of punishment for ourselves. The reality of that conversation is going to be what? From my point of view, what's interesting is to look between the different projects and to start to see what achievements have actually been made and what learning outcomes can now start to be unfolded to basically set the bar for what the next stages of projects are going to do. I will tell you, just for the model that's standing in front of you and Niels, the fact that they were able to do a demonstration, the fact that this is not really like diffusion assumed development, but actually people actually working to try to develop that stuff, to make it computer tangibly, I think that has a lot of value. And I think there's also a reservation from the team not to show everything. They hardly talked about the development of these prototypes. The fact that they are there with a certain maturity, a couple of videos, and I think that also speaks to a certain kind of maturity and confidence in the project. I have no doubt that they can cite it in multiple places. One of the underlying theses, though, of doing this is that this isn't just about like aviary in London. This is really about developing a prototypical system that is a hybrid program between seed bank, between things like Eden, between making that publicly accessible. It's a prototype that is planetary from that point of view to allow that differentiation to not only manifest itself based on the species, but on the context. I completely appreciate that context is very important. I also think that it's also important to talk about working through the demands of what a research actually entails. Sometimes we want things that the project is not really there yet. From all of my teams, I think this team has taken this AI, we see some flowers and things and seeds and all of that stuff. it's a serious kind of AI engagement into speciation and stuff like that. That is a huge contribution to the DRL. And it's a beginning, it's scratching the surface. And that's why I'm suggesting this, because your comments are important and I value them. And I think in this audience, I think it's also to be valued. I also value the restraint to not try to just spatialize it, animate it, and fly through it. Because
No, I'm not exactly right. I mean, that I wouldn't expect that here, but you had 3 weeks, and for instance, what I did like in terms of the morphologies, you had these kind of blob bubbles sort of emerging. And, you know, for me, there's no reason why they couldn't be there. So you have the Frauto, let's say, Olympics, cable nets with glass into Mannheim, into the umbrellas in Saudi, into which close and open, you know, etc. But then you add to each of them. You know, the glass will be fritted, and you have the Frei Otto dark tent, which he had in Stuttgart, where you have where the mushrooms are growing, with the black cloth, and then that, etc., etc., etc. So that's where I feel this would have been, because the ambition of this is, I mean, Eden is somewhere in there as a fragment, which is basically these soap bubbles, and you know. So I think it's an orchestration. There is something. I know you have the purity gene, single system,
purity,
endless repetition. But if you want to go for a square mile on this, you can't use only that.
Patrick, thank you for thinking of me in such a pure way. But today is not about me, and for sure it's not about you. It's about the conversation that's been here. So from my point of view, it's slightly like this. It's not about single system. It's not about one project and however many decades we're operating. The conversation here is really like, what are the next steps? I take on board all of the comments that you're saying, but that's not even that important. I think the students would also recognize that they would want to do those other things too.
Absolutely.
Because they've been struggling with the things, to be honest with you, that a lot of other teams don't struggle with. Which is...
all of this was there in December.
Patrick, I appreciate...
And they're given some hints. So that's what's
Patrick, you're giving hints, and I'm accepting your hints. I'm even sort of taking your strand of purity. But to be honest, we're going to leave that theater for another day, because
Okay.
the reality from my point of view is that the project's merits are self-evident, and it doesn't need validation from me or you. I think the reality of the thing is that the project is opening up a certain way of dealing with data, and also because from my brief's point of view, when I said that we're going to challenge this kind of AI stuff, we've been working on this kind of stuff for a long time. It's only the last 4 or 5 years that everybody's talking about AI, and the reality of that is because it's easy to illustrate. It's very difficult to actually build any model of intelligence, any framework that talks about spatiality, any real-world physics engine. So I think like we are just scratching the surface, and I prefer to leave the conversation open with the challenge that all of those things should be picked up. I'm not sure that it's fair to claim that one team can do all of that. So I state that from that point of view, and I will let somebody else be the concluding conversation, because I don't want to hear myself anymore.
Yes, that'll be nice.
But take the microphone away from Patrick.
I got it. I just want to say one thing to the students. If your project generates discussion, it means you did something really well. So take this as a good point.
Well, I mean, just some last remarks, because I mean, I have the benefit of not being behind the scenes, so it's quite interesting to hear some of this. But in a way, for me, if I summarize the project, is around the coherence in the material approach that you took and how that influenced the intelligence that you embedded into your systems, which is amazing because, in a way, the richness that materials bring through these models, and I think these are amazing models through and through, has allowed to actually, create this really animated debate on like where can this be, right? So there's that research question on how do you apply it and how prototypical it is. For me, it's more of the question itself, to echo Theo's previous provocation on where can you take this? Because this is, in a way, it can be applied into other facets, right? The more interesting question for me is how you start to then continue this exploration of the intelligence of materials into a larger scale to really stress test it, right? And I think that's going to give you other hints as well of applicability in different scenarios, but even the applicability in other kind of species, in other aspects of nature and planets, right? So I think that, for me, is like the strongest point ever. So thank you.
If I can add a quick comment. I think I just wanted to put a thought there of where could this go further. I think you've created a very unique, permeable skin between climate and growth. And almost it is, Jim mentioned it, and we talked about, you know, a knowledge experience, but also a platform for research and experimentation. And and in some ways, basically, you've created a new way of being able to track and understand behavior of growth through even just the geometry and the changes of it, of your canopy. So it almost begs a question, could you use this as a platform of research where you are engineering and you are growing this ecosystem, which eventually will not need it? And it's grown in such a manner that it can sustain itself within, and you can intervene, and you can keep on intervening at different temporal points. But this idea that it could be a platform to test new combinations, new synergies that could allow the new systems that could sustain themselves in the climatic changes. We see a lot of, we're talking about what species should we be changing, what's being planted, given the forecast of where we're going. So this could be a beautiful platform for that. So almost you are, build it so that you eventually don't need it.
Yeah, I think I just maybe are we running out of time? Oh.
No, we're not running out of time.
Does it work now?
Somebody wants a window into the DRL. We do these arguments.
I think I just want to, after all that has been said, I think what I really like about the project is first of all, I mean, as has been mentioned, you invested a lot of kind of rigor in researching the material and its form and its dynamic gestalt. And I think what this project also can deliver, and I think that's probably why it's architecture, not a machine, is that it can communicate, or that it can tell the observer something. So I think this could be a very educative project, right? Because in a way you create a form for something that is intangible and that is probably often also overlooked, and that's probably also why we are very careless with our environment. And I think what this project does, it creates a certain sensibility for how fragile an equilibrium you contain within it, and you do it for a very strong reason. I think that's a very strong connection to your brief. And speaking of AI, and I think there's almost like a bolt-on project that you could do, which is creating a feedback loop, right? Because probably the most expensive form of compute that you can afford is fluid dynamics, and that's actually what you started off with, right? It's climatic conditions, and you could start to model them. That's very, very expensive, but then you could do a few runs and create some ground truth, and could see whether you could start to predict that. So you can start to see whether you can actually get a real-time prediction of your climatic features, and then see how that could lead to a catalog of shapes that your building could then start to embody. So that could almost be like a shape grammar as relates to climatic requirements. And I think it would be very interesting. I mean, you spend a lot of time then on compute on geometry. Yeah, so this looks like it became a very geometry-heavy project. But I think you can then also, in the second step, introduce a simulation dimension that has to do with fluid dynamics and the conditions that you're trying to create for your environments. And that's, of course, kind of an order of magnitude more challenging, but as technology evolves, and evolves very quickly at the moment, that might be an interesting next thing to do, to see how you can create a live system that reacts. Yeah. But yeah, very impressive project, and also, I have to say, very impressive artifacts that you've produced here. Thank you.
I think Patrick wanted to make you challenge more from this point. But my personal question to me about AI is, to what extent we are supposed to use to design the process. I try to use the AI and ChatGPT and all other software, and somehow it's very difficult to control myself, but also difficult to manage the data itself. But coming back to your project, I think you are incredibly well managing data, and I was surprised that we can actually make a poetic and animating space out of this technique, which is quite unfamiliar to me actually, because I met Peter Jumter and all these people who are making a poetic space. They are not really using the AI, but somehow out of your project, I think one of the best compliment I can make is you actually create a well-structured design process out of very the ordinary data you can get in the real world, and you are carefully reading this the data by means of the AI and all this your modeling technique to the certain quality of the space. I think that is kind of very successful job you did today. Thank you.
Yes. I also want to congratulate you. I actually love the purity, if I must say that word. Conceptual clarity. I mean, I love the fact that it's evolved for a living organism and it's conceived as a living organism in itself. So it's very poetic, I think. And I love how you revert the idea of the vault from something that is really massive and static and in something that is incredibly dynamic and ever-changing. So it is, in my book, very inspiring, and I would love to see it developed more, especially in the skin. That's something that it could follow later on, and then I will also see it as a bank vault in a city environment in the future. Perhaps more of this, less of the classic bank that we have. It would be much more enjoyable. And perhaps even the skin could become, it reminds me that it can also become something more, you could collaborate with artists that have been working with knitting and colorful elements and installation in the urban environment, so it could take also a great role in placemaking and in our cities. So I really love it.
I mean, I think what's really nice about the feedback in all of its forms, I think that there's a clear next generation of things that you need to do. Which I think is actually really important. We usually think about research kind of coming to some conclusion. But the runway for this one, I think, is quite long, and I would take all of the feedback on forward. The only thing that I would like, if I'm allowed, is just to speak to my own criticism of it, which is more about the fact that a big part of the things that motivated you in the project, like we talk about climate collapse, we talk about all of these species. Seed banks are kind of preservation, but they're not really production of a regeneration project. So for example, a lot of these things are kept, they're sustained, because the seeds obviously are not just put on shelves, they have to be regenerated. That whole process of regeneration, that whole process of actually cultivating these species, that whole process of building a kind of infrastructure not for itself to be enclosed in that, but actually to make these kind of architectures redundant is important. And I think in this last drive to put all of these things together, to synchronize the digital, the physical stuff, all of these things, I think, Patrick's comments, I think, are a good moment to clarify also your own communication of the project and its motivations. I agree about the materialization. I agree about all of the aspects that we would want to see develop next. I think they are legible, which makes that super exciting from my perspective, because that means that the work already now has a certain momentum. The question is, will you continue with it? And I think at the end of a 2-day presentation where we kind of try to qualify the role of design as research and its relationship to what other people call as practice, you may have to start to consider, hey guys, everybody who's having a conversation back there, it's really great, but you can do it somewhere else. The reason I'm stating that, and we're bringing this to a conclusion, is more about the fact that all of you guys now have to consider what the next steps for yourselves are. This isn't about just like coming here, doing something, and then at the end of the day, that's great. You're motivated, you guys have skills, you guys have a position in the world, and you guys need to go out there, and I think just do it. I'm not necessarily sure that you need to go into an office that somehow is going to somehow fulfill all of the magic that you want. You may have to take a leap of faith in your own ideas and try to find, if it's not tomorrow, because everybody's got to pay rent and the rest, but to really try to think that these ideas can be lifelong projects. I mean, it's hard not to think about Buckminster Fuller and Fry Otto and all of these legends. And in particular, Fuller thought about an experiment as a 50-year project. If we are learning also from the shoulders of some of these giants that were talking about a lot of these issues a long time ago, I think the value of it is to see this 2.0, to see this kind of complexity with intelligent systems, and to try to really work and to kind of put forward an alternative. I think this would be, a very positive thing that all of the staff of the DRL would share, to see what the next thing is going to happen. I think it's really important to conclude the 2 days by just saying how difficult all of this stuff is, how much entertainment and theater we provide for our students in every review and discussion, and how all of these projects are really shaped not by individual agendas. This is a collective experiment between the different studios, between the different tools, between the different people that are coming here. I think this is super important. It's also a reminder to the AA, having people in this space talking about architecture is cool. It's interesting, and it's also a hell of a lot of work. So I think it's very important to kind of look around. There's a lot of stuff that's going on. Making that accessible and sharing that is really the only way that we're going to move forward with actually responding to a really messed up world. And I'm using very nice language to explain my true sensitivities to actually all of the dynamics that are happening outside of this room. So I think you have to be encouraged and motivated and not really look for validation just from us, but you need to listen and to share with all of our different critiques. There's a lot, I think, to be learned, and I think we also learned a lot. So I just want to conclude the event by really thanking our critics and everybody in the audience that made some time to kind of share this with us. We are approaching almost 3 decades, which basically means that Patrick and me are really long in the tooth in this kind of digital experiment. But I state that because within the world of the digital, which everybody talks about at some point in the 90s, we were always talking about the computational, by the spatial, by the architectural, and I think that this is just scratching the surface. The tools are making it much more legible for us to be working collectively, but what's happening is that we're becoming quite lazy with the kind of instantaneous gratification that some of these things do. So we're not in the business of kind of illustrating architecture, we're in the business of trying to expand its discourse, expand its impact for people, and people deserve better. To do that, I think it basically really needs everybody on the same kind of agenda, to think that this stuff matters, because a lot of people are going to tell you otherwise as soon as you graduate from this place. So I state that as a motivation for ourselves to kind of keep that enthusiasm as we write the next series of briefs, but actually for everybody in here, not just to kind of be celebratory like you survived the DRL, but be motivated that what you learned from this place is something that can feed into different ways of thinking about how you're going to navigate a much more complex environment outside. With that, we are going to bring this day to a close. And I'm going to ask all of my students and our students to collect all of these models. We will have an exhibition of a lot of this work at the Zaha Gallery that will open at the end of the month, or maybe the beginning of the following month. We're going to figure that out in the next week. But we would encourage everybody to come to that as well. And yeah, just thank everybody for your time and patience. Thanks, guys.